Hi there. Welcome to this AZ-900 Microsoft Azure Fundamental exam. As you know, this is going to be your first exam if you are trying to learn Microsoft Azure cloud skills. And you are into the right video where I'm going to teach you close to 15 hours of a complete video content which I'm going to deliver in a single video, meaning you're no need to go to any other video to watch all the concepts that are related to Microsoft Azure Fundamentals exam called AZ-900. And this complete exam is updated the last 9th of November 2020, and this entire recording has done post to that, meaning I'm going to release in the month of December 2020, so you have all the topics that are up to date. That's the first advantage when you go with this entire video lecture. And coming back to the topics, I have already downloaded the topics. This is the exam out skills complete PDF file. So this PDF file talks about what are the skills gonna measured and the way you're gonna get all that percentage wise concept. So within this entire single 15 hours video, I'm gonna teach you on identifying the cloud concepts like how best you can save your capex and opex, and high availability concepts and elasticity, agility and resiliency. All that concepts we're going to talk, and also we're going to talk within this complete. So it's not just the one topic. To be frank with you, the entire concepts that are visible here within this PDF file, which was generated in the month of 9th November 2020, is up to date. So any post to this, any new topics has been added in any case. So in that situation, I'm going to make it as the next update as a part 2, which you can find out in my YouTube channel. But for now, as on date, which is 2020 December, you have, this is the latest file which we have already covered all the topics. And just to tell you how best you can prepare, so you can learn the cloud concepts, just about the describing the complete cloud concept, which you're going to get at 20 to 25%, and also core Azure services, which talks about how the data centers are their infrastructure. That's the Microsoft infrastructure was built. We're going to learn which you are going to get it close to 15 to 20% of the scoring. And coming back to the core solutions for the management tools, how you're going to use the management tools like Azure Synapse Analytic or maybe cognitive services, all that, Azure GitHub, all that were coming back into the 10 to 15%. And also within this you also get the monitoring section. Within that you will be learning Azure advisory, monitoring and service health, and ARM templates for automation, all that. And coming back to the general security and network features, also you would be learning with the network security groups, firewalls, DDoS protection, and securing your secrets with Azure Key Vault services, all that. And coming back to the other section, which is going to be your identity and governance and privacy. With this respective, we are gonna talk more about the identity management, which is Azure Active Directory and its functionality, and single sign-on and multi-factor authentication, conditional access, and in fact we have a demo on that. So you have everything here, including the RBAC, policy management, governance policies, blueprints, framework, cloud adaptation framework, all that were discussed within this 15 hours course. And also coming back to the Azure cost management and SLAs. SLAs determines if in case of Microsoft services goes down, when they're going to respond, how they're going to compensate the downtime, all that gonna talk within this specific section. And if you look at these has been slightly modified in the November 9th 2020. So similarly, in case if you're watching this in maybe in a 2022, let's say, who knows, in that case, whatever the changes has been happened, so you would be finding here as the complete changes within this file. And this file specific changes I'm going to either append to this video, or if I at all append, this introduction will not be there definitely. So if really a minor changes, then I'm gonna actually update in a new video I will be releasing. So that being said, if you're trying to practice, if you're trying to learn more about Azure Active Directory or fundamentals, this is the best course, and this course will cover all of your skills that are going to measure within AZ-900 exam. All the best for your learning, and stay tuned, and you can comment, and you can make any questions can be asked within the comment section. If you have any questions, I would be happy to answer them as soon as possible. And if you really like it, please subscribe to my channel and share it with your friends and colleagues. That really helps me and to others also. Thank you. In this module, we're going to learn about cloud concepts. With regards to the principles of cloud computing, we begin with the introduction, and then we would be learning with the what exactly this cloud computing and benefits of this cloud computing and compliance terms and requirements. So this is the most of the things are purely basic, since I assume that you're completely new to the Microsoft Azure. In case if you're already aware of a little bit of the Microsoft Azure, then you may skip this section altogether, but I would recommend to check out, since it is more about very basic things. Like in this, we also talk about like capex, operations, expenditure, capital expenditure, cloud deployment modules, and types of the cloud services that we have. And these are the things we are going to learn. So in another way, the module would cover with the objective of exploring all the possible common cloud computing services and exploring the benefits of cloud computing and deciding which cloud deployment model is best for you. I hope this is useful for you. Let's catch you in the next lecture. In this lecture, we're going to learn about what is cloud computing. A cloud computing is renting your resources, for example, a storage or maybe a computer or maybe a VM for that matter, from a different company. So when I say different company, it can be, for example, the cloud service providers. When I say cloud service providers, it can be a Microsoft or Amazon or Google or maybe some other company. So we are going to rent from them, and we would be using that specific computers with a different CPU, or maybe with the different hardware configuration. So ideally we are using their server from their data center. So what would happen is, this is the full responsibility goes to the physical hardware relevant to cloud service provider, and inside the data would be protected by us, or the data what we wanted to put it into it is comes to us. So the physical hardware requirement goes to the cloud service provider. So let's take an example like computing power. Say when I say computing power, like these are the words which we normally use it within the cloud computing. Let's say computing power or compute power. So what it means is like it can be a Linux server or Windows server with the maybe which has a web application, or it's just a server which you are using for the computing purpose. And also you have the storage. When you say storage, maybe you're storing some kind of files, folders, or maybe a database is stored. So that's called storage. And the networking is such as a securing the connections between your cloud provider and your company between, or within your resources you're protecting, not to compromising anything for the public, because these cloud computing resources can also be communicated from the public cloud or public network such as internet, for example. And now analytics is a visualizing telemetry and performance data. This is become as vital these days to visualize what is happening within your computing with the help of your artificial intelligence and machine learning. So let's jump into the a visualization purpose, so that you would be easily understanding what exactly the cloud computing services because we started with the computing power, so let's jump into that specific one, so which is in this case cloud computing services. To begin with that, for example, if you're quite new already, or maybe if you have already Windows admin experience, or maybe a good professional with the development skills, then you might have already know that you can create a physical machine, you can create virtual machines, right? So within the virtual machine you can host different operating system, and then you can, like for example in this case Linux can be hosted, or maybe you can call a Windows 10 machine, and then you can install the applications. The entire thing can be done within the normal physical machines, on top of physical machines. So this is how they are gonna give you as a rent. So we talked about renting of resources from Amazon or Microsoft or Google. It means that they would have a physical hardware, and what they're going to do is they are going to install the host operating system. On top of it, it could be they install the hypervisor controller. For example, here it could be a VMware, it could be a hypervisor like Hyper-V OS, and then on top of it they are creating different VMs which has fully integrated with the cloud computing. That means on a one click they can create the VM with the desired operating system and the desired applications. So that's how it's going to work. Now there's another concept called containers, which we are going to learn in the upcoming lectures. If you can come up here, this is where we're going to learn about containers, and also we're going to learn about the serverless applications. So serverless applications also we're going to get to know what exactly the serverless applications. So to begin with that, just to give you an introduction on the containers. So containers are similar to VMs, but it is a little bit of higher than the VMs. When it's a higher, actually it is a micro containers, micro computing services. Let's say you have the physical machine which remains the same here, the host operating system same, but here container engine will be there. So there's another software that's called container engine. On top of it you would be actually having container 1, container 2, container 3. So what would happen is within these containers you can install the application, so it is fully without any dependency on the operating system. Whereas here there is no dependency. If you see here, there's no dependency, but here the applications are dependent on the guest OS. So that's where it is dependent. So it is next layer of virtualization. Now when you go back to the serverless engine, or the serverless programming, or serverless services altogether, where you don't need any server. So if you see here, you need to have at least a service, right? But in this you don't control, or you don't have a server. For example, what you would be doing is you would be building everything into the functions model. So one event will trigger another function, and that function will trigger as another one. For example, you booked a ticket, and the ticket is an event. Once it is triggered as success, it would send an email as a confirmation, and that email would acknowledge somewhere. So a flow will go on, because everything is a module specific to the functions. So by using these function models, it's actually more secure and more easiest way, and you don't need to pay for the server cost. All you have to pay is just for the execution of that code or that function. So that's how it's going to work, the serverless computing. So let's jump into the more understanding of what we have so far talked about. For example, we talked about the computing power. A computing power is nothing but your physical hardware. On top of it, you're going to creating a VMs, so that on the VM you would be logging and you would be installing the applications. Now when we talk about the containers, a container is basically it's isolated execution environment altogether for your application. Let's say you have application 1 and application 2. or maybe application 1 with the 1.0 version, application 2 with the 2.0. So you can install, you can onboard those applications into your containers, because these containers have fully isolated environment altogether, and they are similar to VMs, except they don't require a guest operating system. So that way you can think about it, and these applications and its all dependency is packaged into something called container, and then the standard runtime environment used to execute these applications. So this will allow your applications start very quickly, because there's no operating system inside, and it's just the app that needs to be launched. And this has been actually come up with an open source project called Docker, is one of the leading platform for managing containers. Docker containers are provided an efficient and lightweight approach to applications and development, because they allow different components of the applications to be deployed independently within your different containers. And multiple containers can run on a single machine, uh, because it's just a package altogether, and containers can be moved between machines, and there's no dependency on that. And the portability of the container makes it easy for any of the application developer or any of the applications to deploy it into multiple environment, either on premises or it can be a cloud. So it's often no changes to the application. Again, once you have developed that, you don't need to change it. It just onboard it and forget that application or that container. It works on its own. Now if we go back to this serverless computing, so this serverless computing, so far what we learned is we said we want to have application, we want to have VM, or we want to have the at least a Docker to host that application. Now this applications, that is a serverless computing, is like whatever you have the application code works without creating, configuring, or maintaining your server. That means the code itself, the core idea of that is the application will be broken into separate functions altogether, which would trigger one action or one event to other one, will be correlated or it's like passing a function to another function, and from there it's gonna trigger. So if the execution is completed, it would wait. And this is the ideal for the automated tasks. For example, you can build a serverless process that automatically sends an email confirmation after the customer makes an online purchase. As we explained, the serverless module or the model completely differs or different from VMs and containers, because in the VMs and containers you are going to pay for the execution time for the VM or the containers, or the processing. But here it's all about you only pay for what exactly processing. Like let's say you have a server in the VMs or in the containers, which contains this example one, which sends an email. So you have to pay for the total cost of the VM, regardless whether the customer purchase or not. But if you go for a model called serverless computing, you would be only paying when a customer buy the product, then only we need to send an email, right? So once the function called purchase that product was executed, the another module, another function will trigger to send an email. So you are actually isolating the cost to keep the 24/7. Instead of that, you are actually paying for only one time, one execution cost, and that makes more easy and more cheap for you. So this architecture doesn't work for every app, definitely. So you need to have a dedicated logic or a for sure business case logic, then it works very well. Now when we talk about the storage, like whatever we do on the servers, we talked about computing, we talked about VMs, we talked about Dockers, we talked about serverless, but at the end you are going to store something somewhere. That means you have to pay for that. That's where the storage comes into the picture. For example, you're buying a movie ticket online, or you're looking for a price for online item, taking a picture and sending an email or leaving a voicemail. in all these cases, you're going to actually uh, you're going to store somewhere. So the storing is a different purpose. For example, photo storage is a different, and triggering an events or looking for a price is completely different. So it all has a different business case. Similarly, cloud providers typically offer services that can handle all type of data. For example, we talked about buying movies or the files. So this would definitely store into a different purpose. But uh, what they have done is they have segregated what model is suitable for you. For example, you're just using only photos to be stored, or maybe small files. So in that situation, different storage type is suitable for you. That's how you're gonna store it. So let's go into the more. For example, if you wanted to store text or movie clip, you could use a file on a disk. That's one of the example. If you had a set of relationship such as an address book, and could take more structured approach like using a database. So that's where you can store your data. The advantage of using cloud-based data storage is you can scale to meet your complete needs, and you don't need to worry about your on-premises way, like whether I'm filling up my disk or not. So you would be paying for what you have used. So if you find that you need to have more space or more storage for storing your movie clips, or you can pay a little more and add your available space. In some cases, the storage can even expand contract automatically, so you pay for exactly what you need to chosen, or what you have chosen, or any given point of time, that whatever you have used for data only you would be paying. So I hope this is useful for you to understand about computing and storage and serverless computing, containers. So the end of this summary for this lecture would be: every business has a different needs and requirements. So cloud computing is a flexible and cost efficient, which can be beneficial for every business, whether it is a small startup or it can be a larger enterprise. It would be suitable. At the same time, not all the applications are suitable for the uh, cloud. So make sure that you also read that. Hello and welcome to this cloud services benefits and consideration overview lecture. We will be talking about a look at the concepts that we'll be discussing in the next few lectures in this module. Now, over the next few lessons, we will be looking at cloud concepts, especially that benefits and consideration of using cloud services. I'll go through each of these different 6 points which we have here, like high availability and scalability, business agility, economic of scale, and capex, opex, and finally the consumption-based model. Now, we would start looking into high availability, fault tolerance, and disaster. In this specific lecture, we're going to learn about how the systems can proactively or reactively respond to your errors, if it is an fault tolerance, and if it is the high availability point. When we talk about the high availability, how redundancy within the data centers, and how redundance of the regions, that all help to ensure that our applications and systems are up and available as much as possible. We are going to learn about the high availability with respects to regions and data centers. And fault tolerance, as I said, we are gonna work with the proactively as well as the reactively, how best we can handle those errors when they happen. And for the disaster recovery, how best we can recover from on-premises to cloud, and cloud to cloud, or on-premises to, for that matter, for any other Azure data center or your own private data center. And also we talk about scalability and elasticity, and we will take a look at how we can increase and decrease the number of servers that we have, or maybe scaling up, or another way, or scaling down
that based on our traffic and the load of our applications and the systems, and for the fine-tuning with the service performance, all that we would be looking into it in depth. And coming back to the business agility, we also look into this lecture, how to use these cloud services. By using these cloud services, we can free up our business time and money and resources to pursue being more competitive in the market rather than focusing on our IT managing. We'll take a look at capital expenditures and operations expenditures, and we also compare both, and then with the traditional and data center investments required, more money upfront versus cloud model, where we pay only ongoing monthly cost based on our usage, right? And we also have a look on it, economic of scale, where we would be actually getting more cheaper for larger companies like Microsoft to create and manage Azure cloud, versus if we try our own with our own data centers, how much more it would cost. It would actually costing us by dollar to compare with the Microsoft Azure data centers. And finally, we will look into the latest lessons of the consumption-based model. We will look at how using Azure Cloud Services allow us to only pay for the resources that are using, and only when we are using them, allowing us to achieve the most cost effective whenever it is possible. And that's the sixth point. So hi there. In the previous lecture we talked about 6 different concepts, and now this is the time we are going to learn about high availability. So in this lecture we're going to learn more about high availability. If you want me to define what exactly the high availability is, something which is acceptable with a continuous performance. That means despite of a temporary workload fluctuations, or maybe something goes wrong, in that situation also you have the continuous performance. So that's how I can define high availability means. Now let's have a consideration of what exactly the data center redundancies. So when you talk about the data center redundancy, when they are trying to design the data center redundancy, they will consider about the power failures, cooling, networking, for example, multiple internet service providers, that's ISPs, and the different cablings all together for each rack. So they would consider all these kind of data center redundancies. And also we have something called availability zones and region redundancies. Before I talk about anything further, I think I just gave you what exactly this high availability and data center redundancy in general. Now let's jump into more specific to Azure. So if you see, or if you go to the Microsoft web link called regions, so let's understand about what exactly the Azure regions. So this is the Microsoft global architecture. You see here, this is the world map. Within this there are 55 regions where they talk about, and they have more than 140 different countries. Their data centers are they are exist. So when you actually look at here, different colors, different symbols are there. If you just scroll, let me zoom it for you, and you see here there's available regions and announced region, and there's something called availability zone. So now we need to talk about what exactly this geographic and availability zones in a minute, but before jumping into that, let's understand what happens. So when they talk about a region, so within that region, at least 3 different data centers they will have. Let's have a look on it. For example, on India is one of the regions. So if you look at here, within this, they have South India as well as the Central India. In case of one once failed, maybe in South India, it will fall back to Central India. I mean, if at all, if you're created as services in such a way to work, right? So you need to consider the region failures also. Let's go back and understand about one more time about region. What exactly region? A region is within this, if you see here, the total regions are only 55, whereas when you go back to other cloud service provider, they differentiate as something else. But Microsoft talks about a region means it's a set of data centers. It's not one, okay? It's more than one, definitely a different set of data centers deployed within the low latency, actually, or within the, there's no latency kind of thing. They would, define, and they would perimeter, and they would connect it within the dedicated regional low level latency network. So that's called a region. That means let's say West US might have located one data center in one region and another data center maybe close to maybe 150 miles or somewhere, another data center. If something goes wrong within this region also, you would have another data center which is up and running. That means the business will work as it is for you. So that's called region. Now, any other provider, when you compare with either Google or AWS, Microsoft has more regions altogether. Let's understand some more terminology on specific to Azure global design or architecture. So if you just go back to one of my slides here, we talked about the region. Region is a set of data center deployed with the latency defined within the latency defined perimeter and connected through dedicated regions with a low latency network. We talked about it, and Microsoft has at least the Azure is generally available in 52 regions worldwide, with a plan of announcing for 3 more additional regions as on recording of 2020 January. Now, we wanted to understand about what exactly the geographic. So geography is a discrete market. That means it's more about the data. Let me show you that practically. Typically, it's containing 2 or more regions. That means not just one region, you have more than one region, and that preserves the data residency and compliance boundaries. So when they go for the compliance certificate by showing for the auditors, so they talk about this boundary lines for the data where it's gonna exist. So a geography allows customers with specific data residency and compliance needs to keep the data applications close. So they don't want to put it into maybe Canadian government data into US. They don't want to do it, so they would create a region and all the data will be in that specific region. So let me show you what I'm trying to talk on this with more examples. So if I just go back here, you see here you have more region like region 1 and region 2. So at this point of time, you can check out the region 1 and region 2 and these 2 data centers. So within these you have different data centers, availability zones, availability sets on VMs, all that. So I have not yet talked about availability zone and availability set. I'm going to talk in a minute, but consider this is one region. Region 2, they are gonna will be data residency within that boundary for the compliance and auditing purpose. Now we'll talk about the availability zone. So when you talk about the availability zone, a physical separation location within the Azure region. Each zone is made up one or more data centers. So when we talk about more, for example, it works with more independent of power and cooling and networking, because one availability zone goes down, other one will be already available for the customers to run their mission critical applications within the high availability and with low latency replication. So let's take on one of the example how availability zones are benefit for us. Let's say you have the availability zone 1 and 2 and 3. So you have 3 different availability zones in one region called region 1. So what is a region? Region is 55 different worldwide regions we have when you're trying to create. So whatever you see here as the blue, so these all are the regions. So what would happen is within this region you have 3 different availability zones. That means they are fully independent data centers that means they are independent with the hardware and the power supply and the internet. For example, one line goes down or one state central power goes down also, other region is already available for you. So it's not the case, because when they design the data center, they would pull a different states power altogether. So in case one major power grid goes down, other grid will be already available for that data center. Similarly, for the internet and other cabling. But in case if the entire availability zone 1 goes down, that is a complete data center goes down, another availability zone is available. So within that is a more than one is available. So you have the availability within that region. So in other way, if I try to talk about more on different slide, so let me go back to this slide. This would explains to you more. Let's see, it's a single VM. When you try to create this VM, what Microsoft offers is 99.49's availability. But when you talk about the availability sets, so when we talk about the availability set, there's a difference between availability zone and availability set. So let me show you what exactly availability set for you. So if you see, an availability set is a logical grouping capability for isolation of VM resources. When I say isolation of VM resources, what exactly VM resource? VM is required definitely power, and that means a physical service will be isolated. Let's say let's read more about it. So when Azure creates that VM, when you place in a availability set, so when you're trying to create a VM, you have an option to put it into availability set. Let's say that's one of the mission critical SQL database server, and you wanted to put it into availability set. So what would happen? So when you place that, it's gonna create more than one computer in the background, and it puts into a different physical servers and different computing racks altogether, different storage units, different network switches altogether. So in case of any of the hardware or physical things goes down, as a Microsoft Azure, or maybe any, for that matter, any of the cloud service provider would give you more availability. So in this case, it's more about, we are talking about Azure. So Microsoft gives there's not going to be any of the failure. So either a hardware or the software failure happens, only subset of your VMs are impacted, and overall solution stays operational for you. So because you have the similar cloned one which is already available somewhere else, or on different rack, different physical server, so it's taking that SQL database load. So that's all about the availability set. So we talked about single VM instance specific. We also talked about availability sets. So these are the availability sets, so which are gonna place more than one different racks and different physical servers. So you have outside representing as only one machine, but in the background there would be more than one machine. So if one goes down, other one would be always available for you as a front end. And now when we talk about the availability zones, we talked about the availability zone. Say zone is like we talked about by showing that Microsoft article or Microsoft link. So this is how it's gonna show you as the availability zone. So this is where you're gonna get it 99.99% in terms of the VM SLEs. Now when we talk about a regional page, this is almost impossible to lose unless there's a globally it is affected all the global regions. So you see here region 1 and region 2 also can be paid with the help of region pairing, and that would be thousands of hundreds of miles. So that's called region pairing. So you can do that, but this is where the data will be residence within that boundary. That's what we talked about it. So you need to understand here one major takeout would be, so the way from the left side to right side, when you move it to the solutions, you are actually getting more higher and higher availability. So the VM itself, the normal VM itself is a higher availability, but when you go for availability sets, you're getting more than that. That's a 99.95. When we talk about 99.99, then this is what the region level, which is the availability zone. But when we pair with the within the region to region, we are almost getting 100%, but Microsoft sees that it's the 99.49s. So that's the availability. When we talk about fault tolerance, a fault tolerance is often built into your cloud services architecture. If so, one component fails, the backup component takes its place. So it's more than high availability what we talk. So this is referred as a fault tolerance, and this fault tolerance will ensures that your customers aren't impacted when there are unexpected accident occurs. So how we do it is the proactively and reactively. So the proactively would be regularly we take the backup of the data, and we take the apps or resources, whatever it is that we do, take the backup and deploy into different availability zones. It's not just a one availability zone, multiple availability zones and regions, so that we would cover more. So if you remember in the previous, this is where you're gonna cover the fault tolerance with the when you deploy for the multiple regions and multiple availability zones, right? And load balances across multiple availability zones or regions. That's what we talked about it, monitoring health of your data apps, and that will ensure your resources are healthy. So in case if something goes wrong of your applications or maybe your data, then we need to act on it. That's called reactive. So when we talk about the reactive here, we would restore the data, apps and resources to a different availability zone. Since one of the availability zone is failed, so we can fall back to other zone altogether or other regions. That way our applications will be available and deployed to different availability zones or regions. That's what we talked, and by restoring and deploying to different availability zones, that would makes more sense for us for the fault tolerance. The last topic of the lecture would be the disaster recovery. So this disaster recovery talks about to recover anything. I mean, you need to have that ability to back up and restore the data or your resources when it is needed. So that's where disaster recovery comes into the picture. So in case of any of the major incidents or non-transient or wide scale of failures, let's say a region 2 got failure, and all the traffic is have to be diverted from the region 1 example. So which is not possible the entire region, but let's take an example as the highest level got failure, and in that situation you need to able to restore. Site recovery should be able to fulfill our requirement. Similarly, in case if some on-premises VMs or the infrastructure is down, you want to restore back to another on-premises, that can be done with the disaster recovery services offered by Microsoft Azure, called Azure Site Recovery. And also if you're on-premises to cloud, for example, your on-premises servers got involved into the disaster, and then you might have to reload that server or spin up that server in Azure Cloud. So that can be done with the Azure Site Recovery. Similarly, if your servers are maybe in AWS or Google Cloud and you wanted them bring them back to Azure Cloud, so you can do that. Similarly, you can do from Azure one region to another region, like one Azure subscription to another subscription can be done. So it's all about the disaster recovery. So if you have the backup of the data and with all the possible things, possible options that you can get it from the Azure Site Recovery. I hope this is useful for you. Thank you for watching this. Hello and welcome to this Azure Fundamental lesson. Today we will be looking at cloud concepts, especially the benefits and considerations of using cloud services. In this lesson, we will be looking at two concepts that together to provide one of the key advantages to using cloud concepts. And these two concepts are scalability and elasticity. Starting with the scalability is ability to increase your instances count or size of existing resources. let's say when we do in two different ways, this can be actually do in two different ways. Let me show you here. So you have the scale up as well as the scale out options. We also sometimes call vertical scaling, and also we call it as the horizontal scaling. Now, what exactly the vertical scaling or maybe a scaling up? When you say scaling up, it means you're actually taking your existing resource. For example, it's a VM which is currently have 2 CPUs and 4 GB RAM. So when you scale up, it's gonna up to 4 CPUs and 8 GB of RAM. That means you're increasing vertically the size of that specific VM. Let's say if you have already 4 CPU and the 4 core CPU and 8 GB of RAM, you want to make bigger of this size of this VM, then you can go for 8 CPUs and 16 core RAM. So when we talk about scale out, that's nothing but your larger instances count. That means you are adding, for example, you have the one image as a one base image. The same image will be duplicated and the number of instances will increase. So if you think about what's the major difference between this and this, here it's only one VM. So when you try to scale up from 2 CPUs to 4 CPU, you have to actually take offline of the existing VM and then add the required CPUs and RAM, right? But here there's no disturbance for your horizontal scaling, because it's a one same machine. It's going to clone in the background and it's going to add it. So let's talk about what we have discussed. So for the scaling out, increasing instances count of existing resources, so that's called scaling out. So there's no disturbance to your workloads. So that's a scaling out. And when you talk about the scale up, so it's nothing but increasing the existing VM size to one size to another level of size. That's a next level of size. So it can be your the workload is not able to handle within that VM. That's a maybe a purpose to you to increase to 4 CPUs and 8 GB of RAM, for example. So when you do this method, it's a disruptive. And when you do this scale out or the horizontal scaling, so there is no disturbance or there's no downtime for that specific VM. Uh, the one of the best example I can give you here is let's say Thanksgiving Day, special offers are offered by Amazon or maybe an e-commerce website. So you have only one website here, which is running with only one instance. Maybe because of the load, heavy load, because you're increasing a lot of offers, that would definitely do the business more. So more users hitting, more traffic is coming up. So you have an option to horizontally scaling up. So that's nothing but the scale out to one instance to another, and that would be automated way. So that's where elasticity comes into the picture. When we talk about elasticity, the ability to increase or decrease the instance count or the size of existing resources. In this case, this is one of the existing resource based on the fluctuation, based on the traffic, based on the on demand of the workload. It automatically scale up, and if there's no demand, it can go even down. So that's the advantage. So by doing that, you don't need to maintain all the time many servers. Like unlike we in on premises, we never know what kind of workload is coming up, and we try to maintain uh, the number of servers in a higher availability mode, or NHA or NLB, or more instances will be there in our on premises. But when we look at the cloud side, it actually only one VM, but when the actual demand comes up, it is elastically, it is growing up in a horizontal way. So automatically it can add up the direction for the scaling up, as well as the it can go for the scaling down also if really needed. That means you're going to pay for that moment. Maybe during the Thanksgiving Day offer time, you're going to pay for the number of instances that are spinned up. So that's the advantage. So based on the changes in the workload, you're going to pay for what you use. So that's the advantage of the scalability and elasticity. So keep in mind that this is really one of the core benefits of cloud. In general, the ability to pay for only what we use and responding to the changes in our application in real time and be able to provision the resources that we handle that extra load. So you can imagine that doing this in our own data centers would be very costly, having to buy many servers and upfront you have to keep them and maintain, manage. It's too difficult and too costly. In fact, it's not difficult. It's not about the technology, but it's all about the you pay more actually. For understanding more about autoscaling, you can visit the Microsoft site and you can go through this. It might not take much time. You can open up this link and check out how to configure the specific settings. Let's say you can configure the autoscaling with the creation of the profile and the capacity. You can create rules like triggering. So for example, if the capacity is minimum maximum default with a trigger point where it's gonna trigger on a specific time, then it's gonna going up or down, we can define. And also you can send the notifications for the same thing so that you know that what is happening. So this is one of the best link where you can go through this. So this is where you can check out your Azure virtual machine scale set. That also you can check out here. And auto scaling can be configured not just for the VMs, also for other resources. So thank you very much for joining this lesson. I hope you learned something in the process, and I hope you had fun participating. If you would like to go ahead and grab a quick break, when you're ready, I'll see you in the next lesson. Hello and welcome to this Azure lesson. Today we will be looking at cloud concepts and especially the benefits of considerations of using cloud services in this lesson. We will be looking at how we can gain business agility by using the Azure cloud. So let's start by taking a look at diagram on my screen. You will go through with each of these ways listed here, which are close to 6 different ways that are listed here, which talks about the business agility. So let's understand what exactly the business agility. So business agility is an organization ability to rapidly adapt to the market and environmental changes and productive and cost effective ways, and how we can take advantage of the available resources to meet our customers demands. So that's a mouthful, another way. Now but let's simplify that and say it's our ability to rapidly adapt any kind of changes. It can be whether it can be business or political, etc., to provide our customers the best possible product, and to do that in the most productive and cost-effective way. So the first point, let's focus on time to value. And what that means is we want to get new products to market as soon as possible, and we wanted to shorten the feedback cycles on our products, whether they are with the customers or internal employees or what we wanted is we wanted a faster return on our investments. That's the focus on time to value. Azure helps in these ways by shortening the amount of time that needs to be provision new resources or scaling our resources out up and down based on our business needs and the time, by being able to focus more on the business rather than our IT management. We are able to get our products market fast and quickly possible to shorten these feedback cycles. That's where focus on time comes into the picture. Now let's focus on innovation within our business. We always wanted to look for better ways of doing things within newer, better technologies. And Azure allows us to do that again by concentrating less on IT management and more on business. That's our own business. With the cheaper cost of Azure, by paying only for what we use, we can instead focus on our money not on data centers or maybe data center servers, clusters of servers, but rather than we just focus on employees' ideas to make them more product better and better. And as well as we can take advantages of all the technologies that are within the Azure offering, and the ones that are financially out of reach for us in our own data centers, like gains of cluster of servers or blockchain servers, uh, things like that. You can't hold on your own data center. It's a huge cost for you, and that's why instead of we can only pay for limited resources, we can use and invest more money in the products of our own business, and the ideas of business and the pupil will lead to the more innovation. We're going to look at the low latency. Uh, what this refers to is the latency and when a business makes a decision until they know if that decision was right or wrong. And we are looking at that because the sooner a decision can be acted upon, the sooner the business knows whether that decision was right or wrong and what else needs to be done. And with the Azure, with the ability to provision even hundreds or thousands of servers immediately when we have them up and running, that cost us a lot less time and money along with running having to purchase and configure install those servers in our own data center. Instead, let us focus on immediate deploying to Azure and evaluating the business values. These decisions or the applications will give you more value for your business. So it takes a complicated process of IT management away from you or from us. Instead, let us focus on just on our business, and in doing that we can respond a lot quicker to the market. The next way would be the economic effectiveness. We want it to be a cost effective as possible in our process, and the use of resources again within Azure, with being able to pay for only what we use and be able to provision immediately hundreds and thousands of servers. We are treating IT in most cost effective way possible. We no longer have to maintain our own data centers, which potentially cost millions of dollars a year. We no longer have to maintain as much staff to manage our IT resources in our data centers, and we no longer have to buy extra servers, let them sit idle during the times that we don't have extra traffic or extra load on our business. In other way, or instead of, we can rely on scaling elasticity of Azure Cloud and paying for only what we use. By doing this, we could achieve great economic effectiveness in our IT budget, simplify by using cloud instead of our own data centers. And the next point would be the rapid adaptation. And this means our ability as a business to quickly adapt to changes in the market, again going to the same point what we have mentioned in the earlier, with the Azure giving us the ability to immediately deploy any number of type of resources that we wanted. We are able to rapidly adapt to changes in the market. For example, if something were to happen in the business, decided that there's a new opportunity to capitalize upon, but maybe we need maybe 10,000 different servers, certainly type of uh, business needed a service, we are no longer need to pay any upfront investment of millions of dollars to do that. We can simply go to the Azure provisional servers and pay just for what we are going to use or the way we provision. We will be reusing and we will be quickly able to adapt the market conditions by getting our IT resources provisioned and configured quickly as possible. And all of these adds up to give our business more flexibility in the long run. And that's where we are talking about the flexibility. As we are able to move quickly to take advantage of new opportunities, our business becomes more flexible. We can take advantages of new market or new areas that the business wasn't previously involved in, and it makes us more flexible to changes that might otherwise be disadvantageous to some or our competitors. And So Azure as a whole within region around the world with redundancies to make sure that we have high availability within the availability uh, to recover from faults or disasters really gives us more flexibility in our business to concentrate just on business problems, not on the managing on IT infrastructure. And so you can see how all these six uh, items play together and focus on the same themes. But they all mean one thing to our business. You'll be running a better business at the end of the day if you can focus less on these IT management process and focus more on putting your own time and money into your actual business. And with Azure, we can do that without worrying if our IT resources are online or if we have enough money to buy all that IT resources or the servers or the data centers and our own data centers. Instead, we can quickly and simply provision that just what we need within Azure, have it up and running immediately and pay only for what we use, and more of our business time is spent on business ideas. I'm going to wrap up this short lecture and catch you in the next lecture. I hope this is useful for you. Thank you for watching this.
Hello and welcome back. Today in this short lecture we will be learning about economics of scale. Maybe you are wondering what exactly is this. The best way to describe is more you buy of something, the less it costs. And you can kind of think that in terms of getting bulk discounts on the things in your cart. Let's take one of the practical example. If you're a supplier for Walmart, they may be offering you a price that is a half or even 1/4 of your typical profit, but their order might be maybe hundreds or thousand times of your normal or typical orders. So even in case that you will be making less profit per item, but in the quantity would increase, that means you're going to get more and more profit, and you may agree for making an agreement with Walmart. So these kind of companies like these are very big companies. They have a circle of efficiency. So to speak with that, wherever they get a bigger and increase their production, then they definitely open new stores and new data centers. Okay, I'm just jumping into our data center concept, but yes, they go for more and more customers, and that increases their business. That leads to lower cost on their end because they could negotiate with bigger discounts and lower price for goods that they are selling, which both in turn into cheaper products on the market, which then lends to more revenue and more sales of those cheaper products, and ultimately that leads to more money to spend for the company, which will help them expand even more and lead it again in increase of production. So this cycle goes around and around. Now let's put these terms in our Microsoft Azure and how this related to Microsoft Azure and how it leads to low cost for us to consume as Azure services for us. At the same time, in the background for the Microsoft, how it's going to be comparatively cheaper when we try to build on our own any of the data centers. So like a company like Microsoft goes and build a data center, they have advantages of being able to get a low cost of land, building the data center and construction cost and data center itself. The service goes to data center with the power, labor, things like that, and a cheaper and higher buying power. So Microsoft will have the higher buying power, so they get in a cheaper way, cheaper cost altogether. Uh, they have increased security based on security staff or equipment, higher reliability because of the redundancies they can put into data centers and having redundant data centers themselves and things like that. Also for the Microsoft serving more customers, allowing for higher rate of utilizations for their service. Let's take more about the higher utilization, which means for example, sitting idle instead of the servers are sitting idle, what they can do is
as in date, for example, if there is 50% of the CPUs all day serving more customers, they can go for 80 to 90 plus percent of utilizing of the servers that get last bit of profit. They can go out and they're running data centers and ultimately being able to get an extra profit throughout these higher server utilization rates is going to result in lower cost for everyone, for Azure production and the services. And finally, Microsoft is going to utilize multi-tenancy model. When we say multi-tenancy model, for every customer or every individual or the small business are also considered tenants of users of Azure, which is one big system for Microsoft. So think about it in terms of this. The more users you are using your system, it lowers the cost of management and the server per user, because now you can have one administrator working on the server that is used by potentially hundreds of clients, versus in your own data center having to hire one dedicated person at least to manage all of that just service. And so you can add these things together to look at it and imagine Microsoft and Azure down here. Now in the cycle of efficiency, we can see that Microsoft grows and opens more and more data centers within Azure, and that leads to the lower cost for them even further, and lower prices for us, which will encourage us to consume more of the Microsoft Azure products and the services, which will give us at the end Microsoft the ability and money to expand even further. Um, that cycle continues. So if you wanted a one line of answer for economics of scale, so what I can say is economics represents the purchasing power and the ability to negotiate discounts, and scale represents the scale of the company that we are talking about, whether it's a small business or maybe corporate gains like Microsoft or Google or Amazon, or both of them have different economies going. So finally, when we compare with our own data centers, so you built your own data center and Microsoft built their own data center. So at the end, Microsoft builds in a cheaper way compared with you. So it's a big gain, and they get huge discounts. That results the economics of scale. And I'm gonna attach a PDF file, or maybe you can look at this specific URL, or maybe I would try to copy paste this specific URL within the description of video or in the resource section of this PDF file. You can go through this one of the PDF file which was generated by which was created by Microsoft. They compare with the hotspot versus a core evolution with Microsoft normal cloud computing evolution, which they started comparing from mainframes to client and server technology to cloud. And they says that the cloud is a very similar trend, like you when compared with the hotspot versus a car train, similar thing is going to happen for the cloud. I hope this is useful for you. Thank you for watching this. Hello and welcome to this Azure Cloud Concepts, and especially the benefits and consideration of using cloud services. In this lesson, we will be looking at capital expenditure versus operational expenditure. What we are really gonna look at in this session or in this lesson would be the difference in cost building and operating our own data center versus using Microsoft Azure services. We are building our own data center. Assume that this would be the normal scenario where we would be thinking about to build our data center. So that means we have to think about our cooling requirements, and also the energy and most efficiency of our carbon footprint and water usage and capacity of power we're gonna need for our data center, and the cooling capacity, the amount of the physical space, the number of computer cycles, which you could think in terms how the powerful of our servers are. All these were not only have to think about for our current load in our system and for our applications, but we have to think about future capacity as well. So within our data center, we are always in this mindset to having expand our capacity in some way or other way to keep for the future demands. And what goes along with this is inevitably is higher upfront investments or higher costs just to do all these things. Let's look at this in the sense of how these expenditure release to a data center are related to data center of our own versus with Microsoft Azure services. So opening and running your own data center are really more indicative of capital expensive. When I say more capital expensive, the capital expensive means your money and resources, so that the capital expensive is an upfront investment. You're paying money upfront for something, and that something is usually a permanent asset for you, such as a LAN or maybe data center or construction of your data center building or the servers within your own premises. And purchasing bringing the benefit of over a long period of time. That's the main benefit when you have on premises. But so it might take a few years for you to build the entire data center to get built and become operational and finally start providing a profit for you. And because a lot of these capital expenses are upfront, they are usually not recurring costs. And this means that usually just pay one time upfront and you are done paying versus a recurring like a monthly or yearly cost or something like that. Let's take a look at one of these images and try to understand about what happens if we try to open our on-premises data center is. The first one would be we need to pay for licensing costs for the software for that service what we had, and we have to look at the actual servers themselves to have to buy all of those in upfront. And also the power, we would have not only to pay for the power utilities coming into our data center, but all our backup generation equipment, and the same for the cooling. We would have to make an upfront investment for cooling equipment as well as ongoing maintenance for these investments for cooling, and that would have make a large upfront investments in real estates just for the land and the data center is on. Well, we have to make large upfront investments by considering all these when we look at for even the including the physical security for our data center. So we have a plan for, we should have even plan for the disaster recovery within our on premises. So we need to make more redundancies into our data centers, and that would even cost more upfront. And we would have to have a large IT support team or staff to manage and maintain our data centers. We would have to have more training costs for our staff to support and manage and maintain our data center. So it's not just limited to that, the cost would come up like a hidden cost. So to speak or for operating your own data center, it's not just buying the servers and paying for the power. There's a whole swatch of cost associated with running your own data center. And with all of these upfront investments put together, you can see how this usually adds up quite a bit of investment for your people, most of the people now on their hand. Azure Cloud provides a much simplified model within this as a subscription model. So what we're going to do is we're going to take the subscription. So that's nothing but the operational expensive or operating expensive. Well, unlike capital expensive, operating expenses are not upfront investment. They are usually a recurring cost. So example, a cost of your cable TV or internet bill, or maybe a cell phone TV, a cell phone bill, or cell phone services which you normally pay, or a power services or power utility bill what you pay. Similarly, this recurring expenses would be charged for you based on the subscription fee. For what you use, only you have to pay. So pay only you, whatever you use the resources for, that only you're gonna pay for it. So There's no upfront investment. You didn't buy any permanent assets, but you get an intermediate benefit out of these things, and you get a benefit of the period of the time that you use the resource. So you only pay for the amount that you used. So if you look at the image at the bottom of now and compare the cloud and on-premises data center, we can see the whole lot of less cost right off the bat. So within our subscriptions to cloud provider, we are able to provisional the resources that is what we needed when we need them, and only pay for what we are using on a monthly basis. So the amount of the capital expenditure that have to put into is very slow and very low. In fact, sometimes it could be nothing upfront at all, like with Azure. And we could just pay our first monthly bill for whatever we used. That will allow us to also reduce the IT support staff as we need, as well as the training. Now let's think about some of areas where that we could eliminate right away off the bat if we switch to Azure. Things like physical security for data center. If we had a place for that, we would no longer need that role, because the physical security is managed by Azure and their data centers, not by us. So it's the responsibility of Microsoft altogether. Also, within IT support, we might have or had staff those job was to replace faulty hardware within the data center. Well, once we no longer have data center on our own and start using Azure, we no longer need the role as well, since the Azure maintenance staff will be performing hardware upgrades and the fixes instead of our staff. And so you can see the difference now between a capital expenditure and operating expenditure. Capital expenses being upfront investment that usually don't recur, they usually result in purchasing of something permanent, and they create a benefit for over a long period of time, versus our operating expenditures, which are not upfront investment but rather recurring cost, and they create immediate benefits for usually don't result in permanent assets. We can refer back to our image with the left side and think about the expensive planning items that we no longer have to consider or think about as we move to Azure as well. And the main benefit that brings about is that we can spend less time worrying about IT management and data center management, and we could spend a quality time on focusing on our business. And so with Azure, we get the ability to do by shifting our IT process from capital expenditure to heavy model to operating expensive model, heavy model, like we see in these images. You see this big one transformed to a lower one, which is more powerful, and you don't have much things to worry about, and all you have to pay is just a subscription fee. That way you can manage your services. So I hope this video has helped you to understand about CapEx and OpEx, or the operational expenditures. Thank you for watching this. I'll see you in the next lesson. Hello and welcome to this consumption-based model lesson. You can think of consumption-based sort of like you pay as you go model. I hope these words you might have already heard about when it comes to the cloud model. So when we say about pay as you go, that means whatever we use the services for that specific minutes or hours, we are going to charge for that. So there's no upfront cost. So it's all about the services what we use, we're going to pay for that. That's called a pay as you go model. We will take a look at what we mean by consumption based model now within Microsoft Azure. Instead of buying any kind of equipment upfront like we used to do it in our traditional data centers, we only have to buy the resources that we need when we need of them. So let's first look at this image, and we'll talk on that when compared with the traditional data center versus the Azure services model. Now with the traditional data center, you see the blue line, which is the capacity line, which is usually planned for a different step. So when we go upfront for our capacity, we might need to add up new servers when we need then level out or more sometime, and then we need to add new servers again and again because of the demand from the customer, which is the red line of the consumption which is coming up. So you might need to look into it. So now if you see here, as the demand arises and falls, we might not either be meeting our demand. If you see here, if the demand is going down, that means here the servers are ready, but they are sitting idle, they're not fully loaded. When the demand is going raising up, the customers will feel the dissatisfaction because of the services are not working properly, which would you normally see in your traditional data centers. So these are the both bad areas. One is the waste, and the other one would be the customer dissatisfaction, which are results of incrementally buying service ourselves as we need them, or not being able to match the demand of our application nearly as precisely and we could like. And like with Azure, on the other hand, we see two lines. In this diagram, there's no waste or no customer dissatisfaction because of the we can set it up properly, elastically, and scalability configuration to auto scale automatically based on our demand. And whenever there's no demand, just scale down those servers so that you're saving the cost. At the same time, when you have a business, that means you need to make your customers fully happy. So you're increasing by using the scale up or scalability or elasticity based on configurations within the Azure. So that would makes more easy for you to configure in such a way. This makes us a pay-as-you-go model and gives you more returns in terms of the cost saving. So this kind of touches on the consumption-based model, paying only for what you're using and when you're using it. And so with the consumption-based model, we have no more upfront investment, and we no longer have to buy servers in incremental like we used to buy it in the blue line in the image of the left side, which is our traditional data center. And instead, we can pay as you go model, and what it means is we are going to paying for only when the resources are used. Additionally, we can even get discounts within Microsoft Azure. When we reserve with Microsoft, you can get anywhere from 10 to 40% discount on Microsoft Azure products and services is just by committing to 1 to 3 years of time frame, so that you would be getting discount for Microsoft Azure services. This is sort of bulk discount at play as well. The more servers or the more resources that you use, the lower price you can get it on each individual server or resources. Like I said, just a kind of like a bulk discount. And our model is one where we only pay for what we use. So again, if you turn the machine off, you're no longer paying for it. If you turn it back on only, then you're gonna paying for that. Otherwise, you're not gonna pay for that. As Microsoft Azure grows larger and larger, they are able to offer lower prices. You will be able to pay less for Azure services as Microsoft Azure grows. So in other way, when you go for the larger commitment, think that we are buying our servers or hardware or the resources within Azure. It's more like we are renting them, not exactly the buying, but we are just trying to renting them. I can rent a server for 1 minute to maybe 2-3 years also, and I can pay for only for that 1 minute. If at all I used, or if I just switched on that server, I'll just pay for that 1 or 2 minutes, whatever the time which the CPU executed. Or I could rent a server for 10 years if I wanted, but the point is here we are only paying for while we are using it. So it's really cost effective. So this is very useful for the small business and individuals who wanted to start their infrastructure on immediate basis. or host their application servers in a world-class data centers without any of problems that you have or expenses of building your own operating data centers or operating system. And maintaining those data centers, when we look at some of these services that we can use, we have computing services that we pay for only CPU, and like I said, if we rent a server for 1 hour, we are paying for pro-based cost for just for that 1 hour. So think about when you buy that specific server, you would be paying for heavy cost, but you're not using in that situation. If just the 1 hour if you use, you are only paying for that 1 hour of Azure services. So which is a good and which is a cost effective. When you talk about data transfer, whatever the data is getting transferred from external to our data center, that's not going to charge. But anything going out from the data center, which is Azure data center to out, you're going to charge. So which is a good in other way, and it's more granular level of pricing for in a GB base what you're going to charge for that. And storage also the same way, for the per GB it's going to charge for you. So it's so easy, like what we have discussed so far is pay less when you reserve, and pay less by using more and more resources, and pay for use model, and pay less when as you grows, because once they get huge discounts and you are getting that benefit out of it, and pay for only computing power based on a CPU or whatever the time was executed. And similarly, the storage also, whatever the data you are going to store, for that only you're going to pay. You're not going to pay for the data which is not stored. Unlike in the traditional data centers, you would be buying a huge, big, bulky SAN disks and the storage drives or storage, but in this case it's unlimited storage. All you have to do is you have to just store your data and segregate in a right way, and that would take care of costing, which is very less in cheap. In fact, it's very, very cheap when compared to traditional data center data storage with cloud storage. And coming to the data storage, data transfer, as I said, it's going to be charged by gigabytes, which is a data out, not into the inside to the data which is coming to Azure data center. It's not going to charge, but anything goes out. That means, for example, you hosted a server, so that's a huge transactions is going to happen. So you're going to charge for that because the data is going out from Azure data center to outside to your customer. I hope this is useful for you, and I hope I made it very clear for the consumption based model. Hello and welcome to this new module. In this module, we will be looking into infrastructure as a service, as well as a platform as a service, and also software as a service. So we would be looking into these three different services and their offerings. So finally, we will be comparing and contrasting of these three different type of services. First, we will start with the infrastructure as a service, and then we will go for the platform as a service, and then software as a service. So these are the three things we would look into it. So these are the common way of presentation wherever you go. Normally they would try to put it in this way, like in your on-premises data center you manage everything, including your networking, storage, server, that's your hardware, virtualization, your operating system and middleware, and your applications and data, and similar things. But when it comes to the infrastructure as a big block, you will be only managing from the middleware and the applications and data. But whereas other services like servers, storage, networking, virtualization will be managed by your cloud service provider. And when you move to the platform as a service, you are fully responsible for the application creation inside that, the granting the permission, such things, including the data. But the applications are hosting only will be done from our end, and we don't care about the middleware things. And this is a responsibility goes to Microsoft Azure or any other cloud service provider for that matter. And software as a service is everything is managed by them, and we only use that application. Let's say you have Office 365 or Google Gmail or such things, or we just use it and we don't care, where it is hosted and how it works. So if you are a developer company, you develop some application, you can simply host it into Microsoft Azure and offer for your end customers, saying that, hey, I have a software as a service solution for my application. So they would love to go for it, because you are providing in a higher availability mode. So there's three different levels to choose from, three different service types what we have here, and we will choose which one is best for us in the final lesson, and we will comparing and contrasting each of these services into three, and bringing up examples of certain situations where it would be best suitable for which service to go for, or which particular model is the best suitable for you. I hope this is useful for you, and catch you in the next lecture. Thank you. Hello and welcome to this Azure lesson. Today we will be looking at cloud concepts, especially at the infrastructure as a service. In short, we also called as IaaS. So we talked about in the previous lecture about Iaas and PaaS and Saas as an overview, not complete in detail, but this is the lecture focus on IaaS. So if you see here, it's going to be hosting purpose Iaas used, and PaaS is used for the building, and for the consumer purpose Saas will be used. So let's jump into the IaaS specifics. So this is what we discussed a little bit, but I'm going to talk on the same one with a more clean picture. If you can check out here, on premises. When we talk about on premises, so that is nothing but your own data center. So within your own data center, you will have your own networking like switches, routers, and storage and servers. And that means you have to buy servers, you have to buy the storage, you have to buy virtualization softwares and do that virtualization and install the operating systems, and you have to maintain the patch management and middleware, and you have to build your data with some kind of applications with the runtime, and finally the applications will be out for the consumers or for your business ready. So that's how it's going to work for the on-premises. That's good. Now let's have a look on IaaS, that is infrastructure as a service. So we talked about Azure offering as a service models, which are three of them. One would be, the first one would be the IaaS, which is a bigger one, and mostly it would be a costly one. When I say costly, because you would be having huge control on your IaaS, except the physical things. If you see here the orange one, which talks about where managed by Microsoft or any other cloud providers. So this slide is just for, not just for only Microsoft Azure, it can be for any of the clouds. So it's a basic one, very basic one. So IaaS is the infrastructure as a service, manages your complete solutions, especially from the networking, your and storage and servers and virtualization. These are the things are managed by Microsoft, and you can manage like installing the operating systems and the middleware, runtime, and your applications and their data. When it's managed by these services by other managers, that means the service provider, in this case Microsoft Azure. When it says server, it means that if anything goes to the server, for example, there could be a hardware fault, or hardware drive goes offline, or memory goes out. So these things are managed by Microsoft Azure. Data centers will be handling all the replacements of faulty hardware, things like that. So what it means to us is that we need to manage within your IaaS. There are the operating system and your middleware and your runtime components and data, and our own applications itself we would be managing here. So here we will have a lot of flexibility, though we have a control of the operating system, everything on above it. So we have ability to within our Iaas to rent out our virtual machines, and we have the ability to control aspects of that virtual machine or the machine completely from its OS middleware to runtime. And we can imagine that if we had an application that we needed to host that had a lot of pre-requirements, required applications, or other required softwares running in order for our applications to work, you can see that since you control the OS and the middleware and runtime, you have the ability to that. You can install that since Iaas, because it gives you that flexibility for most of the control of the resource, except the physically controlling the machines. Anyway, we don't need to have control for hosting any of the applications. Again, we are looking at Iaas, PaaS and Saas from the perspective of how much control we have over the resources that we were using within Azure. So Iaas is used the most control when you compare with PaaS or Saas. If you see here, the blue blocks, which is applications and data, is here reduced to only two layers. That is, the application and data only can be controlled in the platform as a service model. Whereas with the software as a service, you don't have any control at all. So another way for Iaas, you have a maximum control of the things which you wanted to install, you wanted to configure, all that except the physical things that that are not part of our Iaas, as these are managed by Microsoft Azure data centers. So we have really total control over most of the resources that we have, since we have access down on the operating system level. We can install and configure anything that we need on these servers and the resources as with all of our cloud services. So there's no upfront cost as we just pay as we go model. That means only the minutes or the hours what we use this server, the spin up time only will be calculated. So it's still a lot more cost efficient than the managing your own data center here. Along with that, there's no physical infrastructure to manage. In this case, it's fully, the orange one is fully managed by your service provider, in this case Microsoft Azure. And finally, this makes an easy transition to cloud. If you have any of servers you wanted to transition to Azure cloud, you can do that. A lot of companies with an on-premises data centers already have an virtual machines that are being used, so it's pretty easy for them to just spin up a virtual machine in Microsoft Azure and duplicate all their on-premises images to Microsoft Azure. Along with that, Iaas also provides very easy scaling options. Remember that we also talked about the on-demand increase of our applications, the flexibility for scaling your resources. That gives you an extra benefit when you move from your on-premises to the Azure cloud. But some of the Iaas approach that are this is the extra level of control over our resources will cost an extra bit of management and administration that we need to do it in order to keep those servers running. For example, we'll need more staff to apply operating system patches, since we have access to the operating system, and you need to take care of the specific patch management. And so most of in couple of different ways, as well as a kind of a con of the Iaas approach. But it may be outweighed by your business needs to have that control, because you wanted to install that specific application and you wanted that flexibility. Since this flexibility is not coming on other PaaS or SaaS applications or SaaS based solutions, so you have to manage, you have to install that specific patches and manage that. So that's where a little bit of additional resources might need to consider and have to work. Whereas PaaS and the SaaS models, this operating system also controlled by your Microsoft or other cloud service providers, so you don't have control on that, and you can only look at your applications and data in the PaaS model, or in the SaaS model, even not even application data, you have to just work on it. Let's say an example, Office 365, like your Outlook, or maybe a Gmail application, or maybe GoToMeeting for that matter. So these are our SaaS based model. So it's so easy when it comes to the SaaS, but it all depends on what business is demanding. So if you have a business which are installed in on-premises and you want to migrate to Iaas, so it might need to considered as Iaas model. That being said, definitely the resources and other things are additional cost, and also when you go for SaaS and PaaS model, it's a cheaper when compared with the Iaas. But again, as I said, if your business or your application demands that have extra control, might give you overweight or benefits for you, then a slightly higher cost can be paid for that. So when you think about Iaas, let's think of a keyword called which is hosting with Iaas. We're simply looking for the resources to host your applications, and we are willing to spend that time and a little bit more money to configure and control every aspect of those resources down to the operating system level. When I say down to the operating system, like applications, data, runtime, and middleware, and till your operating system. So it's a convenient way to host your applications or our applications in Microsoft Azure in a way that's pretty similar to how a lot of organizations are set up already, which is with the virtual machines. And so in our next lesson, we are gonna have a look on it, PaaS and then SaaS applications, and with the comparison. And I wanted to give you compassion with some kind of examples that would definitely give you more confidence on what kind of approach would be right for you. I hope this lesson is useful for you. Thank you for watching this. Hello and welcome back. Now, platform as a service and its counterparts such as here the Iaas and PaaS and SaaS, which are nothing but infrastructure as a service, platform as a service, and software as a service. They all three really represents different ways in which Microsoft Azure let us consume the resources that they are providing us. When we looked at Iaas, that's infrastructure as a service, we looked at how it was more of hosting model as a keyword what we have used, and that gave us the most control over underlying the resources, where we have the operating system to installation, application, data, and runware, runtime, and middleware. Everything almost we have almost similar to our on-premises. Almost half of that we had the control. And now, today we will be taking a look at a platform as a service. So in this lecture, we actually include more components managed by Azure and less by us, right? Because if you see here, all these things are managed by Microsoft Azure and very less components managed by us. That moves us to a corner, but that also gives us the flexibility to save the cost. At the same time, it's one of the popular one platform as a service model. Let's have a look on it now. When we last looked at the Iaas, some of the products within the Microsoft Azure that correspondence to Iaas were virtual machines, or there may be networking or another resources. So we talked about in the Iaas like creating virtual machines maybe, or networking. Now with the PaaS, there's actually quite few more offerings than the Iaas, because it would be a very less if you can look at, but there are more powerful apps or powerful things which are available. And some of the offerings within the Microsoft Azure that are PaaS or storage, for example. So if we were to do a storage from Iaas capacity, in this we would rent out a virtual machine and set up a storage drives, and then we would give our storage needs to that VM, and then we would fill up that storage as a service. But it's a platform as a service case. What's going to happen is, in this case, we don't have to manage any of the server level components. So what we do is we simply take how much storage we wanted, and we start using that specific storage. So in as a platform as a service offering, you don't have to manage any of these server level components which we used to do it in the infrastructure as a service. Instead, we just up the storage up and running will be available for us. So we just consume the data which is available as a storage as a service for us. So let's less for us to manage here. If you look at here, it's very less to manage, and it provides a kind of similar interface for us to build upon. And let's remember that word called build. So we talked about the host, and now it's for the building. So when we looked at Iaas, our keyword was hosting, and we had most control of the hosting of all resources the way we needed. With the PaaS, we are looking at the building on top of it. So building on the top of it will give another layer of flexibility to build and use the applications. Let's take one of the examples. Maybe let's use the SQL database as the PaaS model. So when you go for the Microsoft SQL as a database model, you can have a look on it. SQL component which is available as the directly available, instead of here in the infrastructure as a model, you install the VM, then install the SQL, and that means you are responsible for patching here for that VM as well as the operating system level and SQL level and their availability model. Also, you are responsible in infrastructure as a service model. Whereas for the platform as a service model, we get the direct SQL. So it's a headache of Microsoft Azure or whoever the cloud provider in that case. So in our case, it's a Microsoft Azure. So they maintain that SQL high availability purpose. So for us, we get the SQL database and we use the SQL database. So the same thing, to put it into other way, with the PaaS offering, Azure actually manage the SQL administration for us, and all we have to do is to just consume the database, and that's the that's where we get the access. And finally, our app service is another one example of a PaaS offering model of an app service, which is just a service within the Microsoft Azure to host it. So you do have your, maybe I'm going into the technical altogether, like I said, app services, I said, VMs and networking. So let me show you what exactly it means. So this is a Microsoft Azure portal. When you log in with the portal.azure.com, you have this dashboard, and in the left side you have the three lines. So this is where earlier it used to be docking to this page, but now they have removed that. So you just have to press your mouse, click on the mouse here on the three dots. That's where it goes to here, and this is the dashboard, what you get it here. And here you have different services. So if you're looking for some kind of services here, like maybe a SQL example, so this is where you search for all the SQL specific. This is a list of all services where you can search it. So let's jump into a specific service of what we are looking. So if you are trying to create a virtual machine as the infrastructure as a model, all you have to do is just go here to the virtual machines and spin up here the required virtual machines. So whatever the virtual machine name and the region, all that, we would be looking into it maybe in the other sessions, but this is just a fundamental. So this is where you create your own virtual machines, but we are talking about now platform as a service. So platform as a service, we also talked about a application model. So what happens is you have the web apps within Microsoft. So if you see all services here, you do have different services. So if I just go for app, so you have here the app services. So this is where you can create your app services. So let's say I can create your new app service. That's going to be a platform as a service. That means you don't need to worry about the hosting and other things. So whatever the website name, for example, I give here maybe a Mathy example, whatever the name. So this name is going to be unique. Later on, you change that to your own service, and you would be getting that FTP and other services to upload and do whatever you wanted to do it. So now let's jump into the actual demo. So we talked about an app as one of the example here. So what happens is within the platform as a service, you do have you don't have a control of that hosting specific or the installation flexibility what we used to have it in Iaas. But with the PaaS, you have that application is ready for us. So it's our headache, how we wanted to grant the access and what kind of application should have the contents within that. For example, if I take it as the one of the Iaas, whether like Apache or Iaas thing like that, I can take care what to be doing, what kind of configuration to be done while I'm setting up my PaaS offering. So if I just go back here and show you one more time here, you see here the Docker container, or you want a Windows or Linux. So that all flexibility it's gonna ask you, and it's gonna make you more comfort, like Iaas you want, or Java, or Node or PHP, what kind of web app it should be. So this is what it's gonna ask you when you try to host that specific application. So that being said, the Azure will handle the complete Iaas configuration, and the server and the OS middleware configurations, etc. for us. So you can kind of see already just from the description of these products how PaaS offering, such as managing your storage and the Iaas specific things, definitely goes to your OS flexibility, and that all goes into the responsibility of Microsoft Azure. So PaaS is going to take a step forward when compared with the Iaas to manage your operating system and middleware and runtime as well. So let's consider the case of app services, which are a web service which is offered from Microsoft Azure as a PaaS model. That means when we wanted to manage our own Iaas, in that model we need to look at your Iaas like a VM and the OS level patches and middleware, runtime, data, and finally the application comes into the picture. But here that responsibility goes to the Microsoft Azure, that gives the more flexibility for us and more uptime for us, more confident on our applications to run on it. I'm sorry if we went any of the too much of the technical. So let me jump into the Microsoft Azure portal. This is our portal, and let me show you, how best we can create one of the web application and configure the auto scaling for that specific web application. So what we do is we just create here the resource group. We would talk on that. Maybe a resource group is a top level. So give here any of the application unique name, like the website URL, like yahoo.com is not a unique. So similarly, app demo unique ID, some random ID which I'm giving here, and here I'm choosing the model that the Microsoft offers as a PaaS model, all these languages for your web developing, for example Python, Node.js, and maybe ASP.NET. So I'm just taking the ASP.NET since it's one of the easiest one to demonstrate, and also region I have taken as the central US, and this is where it talks about the size of the each of the web application, how it's going to charge for us, like if you take it P3v2 or P1v2, P2v2, so the charges would be 19,300, and that's INR which is showing, because I belongs to INR region, but if it is a US, so it would be showing as a US model. So if you see here what they are offering, additional ties with the additional custom domains and auto scaling, all that. So I'm just taking one of the model in this case, and I'll simply take maybe 200 or 400. So if you see here, auto scaling is 20 instances. You can go up to 20 instances, 10 instances based on that. So I'm just taking default one. I'm not changing much with the RAM of 1.75 GB. And the later point, when I click on create, it's going to analyze and it's going to give you a summary. Then once it is ready, it's going to ask me to click on create. That's where I'm going to creating the web application. That means it's going to test dummy web application which is ready for us on a .NET framework based application will be ready. So what we do is in the next once the application is ready, we ask our developers to develop the application right from the web console or maybe from their Visual Studio or whatever the tool they use it. And once they are ready, they would start uploading by using the FTP, or they can connect directly from the Visual Studio. But for now, let's create the application. Once the application is created, we think that the application is created and it's readily available for us, and assume that your developer is developed. So as a next step, I would actually configure the auto scaling. But you can look at here, once I submitted, this is the deployment page where it shows the status for you. So this might take maybe 5 or 10 minutes. So I'm going to cut off this page and directly go back to the specific to resource page. And then because the resource is the top level where it creates all the components, all the objects that we created, for instance for this web application, all this. So this is the test URL or the web page which we just created. So I'm just going back to the, not for the availability, let me go back to actual app. So that's app. So you see here in the right side, here the URL also available. So if I just click on that, it's going to open up for me. So the application is ready as we discussed. Now as a next step, I'm going to configure my scaling out for the number of instances to be go up, or maybe I can go for custom specific auto scaling. This is where I'm going to configure in the. You can add the condition here in this case, like adding another role, like maybe for my queue of the application is this, and the aggregative of my average of my CPU percentage, if it is reaching to maybe per minute, it is reaching to more than 70 percentage for the 10 minutes. If that is staying at that level, then I wanted to increase the count of every instance of this application in the background by 1. And cooling period is the 5. That means it's every 5 minutes it will go and it will validate and check for that, and it will reduce that once it is cooling down. So that's how I can add this specific condition, and that would actually creates me auto scale. So all these options are available for with the PaaS model. So this was just the example for the app service example. Now, so PaaS also provides us much easier scaling experience experience in the long run, and because of all these pros with the PaaS, it's a lot quicker and develop. And you see how much time it taken for us to simply host an application, and then it's the developer job who's going to develop this and then since there's a lot of less time that you have to spend on managing of any kind of infrastructure with app services, you can immediately just get into the building of your actual web application with your developers, get into hosting them without having to worry about infrastructure to be created where we used to do it in on-premises or in Iaas. So it's so easy for us. So but again, it all depends on some of the financial companies. They are not ready to go for a PaaS model because they wanted to store their data on their own premises, or maybe they're okay to have the control. So in that situation, they would go for Iaas model, not for the PaaS model. So it all depends on the business case, and business dictates what model to be chosen. So just to conclude, or maybe the old PaaS offer is much simpler approach than the Iaas in terms of consuming resources from Microsoft Azure. The key word we wanted to think about is with the PaaS is that building applications to run on your Azure on these platforms. Again, from the app service perspective, instead of running the Iaas model, like having virtual machines and configuring your Iaas, doing all that pre-work is readily available with the PaaS model. That's what we have had a look on with the autoscale and other powerful mechanisms and the application model for PaaS. So I will catch you in the next lecture on Saas, software as a service model. I hope this session is useful for you. Thank you. Hello and welcome back. We will look at software as a service in this short lecture with the example of Office 365 and Salesforce. We took a look at Iaas, that's infrastructure as a service, about how that provides with the hosting kind of model that gives us the most control over the underlying of the servers and the storage. Then we had a look on platform as a service, which gave us the management of the operating system and middleware to Microsoft Azure, but we gave the control, we gained the control of the flexibility of ease of deployment and consuming of these Azure resources. In this lesson, we are going to take a look at software as a service, in a short SaaS, and we are going to see how it will take the management away from us and provides the easiest to consume model for all of these three. Well, we will look at the software as a service now. Some quick examples for the software as a service, providing the Office 365 or Salesforce. Let's take a look at the Office 365 in a minute, and particularly let's talk about the email functionality. If you wanted to implement an email system using infrastructure as a service model, then you might need to have to spin up a virtual machines and then installing the softwares like Microsoft Exchange Server and then plan it with the firewalls, and a lot of efforts are required. But when we gave it to these efforts to be eliminated, when we go for SaaS model, it's the readily available as the service for us. So it's quite exactly opposite side of that. We have a SaaS model, which that we don't have to be administrator or doing anything, managing anything like an Exchange server or other things, and that's exactly what Office 365 does here. We can sign up per user based within our organization for the email services, and we don't have to worry about what servers they are hosting in the background, and whether the upgradation of those servers, such things. All we have to do is just to consume the product and use that for the SaaS model. So when you try to use that or consume, so you have to log into Portal.Office 365. For example, I'm just talking about this application since I know it, and most of you might be already using Office 365. So we would just have to log into the Office 365 website, log in and check your emails and calendar tasks, and you can collaborate and consume that product without having to do anything to host it. Since it's quite opposite to the Iaas. And when we sign up for more emails for additional users, in addition, not to worry about any additional servers and configuration or runtime software, such things, because everything is managed in the background by Microsoft or the SaaS provider. So we have to just think about the subscription cost and just subscribe them and go ahead and use those applications. So it's easy, and so there's nothing, literally anything for us to manage within this model. We just have to consume these services, and consume is the key that we talked about for the SaaS as the keyword. And we just have to worry about consuming the softwares, and we pay for month for our services, Office 365 subscriptions, and we just use it anytime we want it, and we don't care about its hosting. And so it's very easy approach for certain things like email, but it doesn't really apply to every situation. So keep in mind that the software as a service is one of the least used there are out of this Iaas and PaaS. Saas is the very least used model that we have looked into so far. And now let's take a look at some of pros and cons of the software as a service model. With the pros, there is no management, as we talked, whatever is so, and no administration is required, and we have to do which we can reduce our costs quite a bit, and that we don't need any dedicated staff to manage these servers. As with all of our cloud service types, there are no upfront cost, and we can pay as you go model, and there is no physical infrastructure for us to manage. Now, Software as a service in particular, we can give us a fast setup, probably faster than Iaas or PaaS, because it's readily available, because there's no network for us to do in regards to setting up servers, resources, or building applications on top of platform. We simply consume that, and it's simply just immediately begin consuming the SaaS service, and because of that, anyone can use it. Like, think about, Facebook, it's readily available and we simply consume it, and anyone of skill level can be used. Anyone's with any level of the skill can be used and configure these services, which might help us to reduce some staff cost even further. But there are some cons with the SaaS as well. The downside would be you don't have much customization when compared with IaaS or PaaS model. Let's say you wanted to set up some customization within your mail services. Since we have taken Office 365, let's say like you wanted that must be exist within your control, then you might have to end up with the IaaS model compared with the PaaS or SaaS. So not every product is suitable. At the end, the business will demand what kind of control you wanted on that specific product. But if you're compliance policies or your business demands that it must to be go for IaaS model or PaaS model or SaaS model. So keep in mind that we are evaluating software that happens to be SaaS, and finally the vendor, in this case Office 365, is a Microsoft and Azure. They may have access to our customers' data, since they will be hosting the data within their data centers or within that SaaS module, because we're talking about not just the application, the data also will be with them. At the end, we have the client interface with us and the data is storing with them, whereas the PaaS model, at least we have a little bit of control over the data and the application layer. So again, if you have certain compliance and the security needs that needs to go fulfill, and then one of them is the keeping all sensitive data on premises, you may want to consider not using SaaS model in that particular case. But as you can see, software as a service kind of extends IaaS and PaaS quite a bit by going into full on opposite of your own on-premises data center. With the SaaS, everything is managed by Microsoft and or Microsoft Azure, or really from the vendor that's providing the service. And in return, we don't have to do anything as far as managing services. We just have to consume the services. So stick around our next and final lessons on the comparison of each of these models and where the best suitable products will be in a suit, or what business demands. Based on that, I'm going to talk on that lecture. See you in that lecture. I hope this is useful for you. Thank you for watching this. Hello and welcome back. In this lecture, we are going to learn about the ideal use case of each of these approaches, like IaaS and PaaS and SaaS, and how they are each differ from one with another one. So as you remember, the host is the key which we need to remember for IaaS, and similarly for the PaaS as a build and consume for the SaaS. And we also talked about the two of the different examples for the SaaS application as the Office 365 and Salesforce in the previous lecture. Now we remember that from our on-premises data center that we have to manage everything, our networking, storage, and servers virtualization, which is really at hardware level, as well as some of the software level components like operating system, middleware, runtime components, as well as at the application level, our actual applications themselves and the data that they create and save. So we have to manage every port of the stack when our data centers are on premises. Now, with the infrastructure as a service, what Microsoft is offering is Microsoft actually managing networking, storage, servers, and virtualization components. And we get to manage our OS and middleware, runtime, and everything above of it. And this gives the absolute most control over how our servers are running and what we can do on them, like installing an application or maybe configuration of a custom specific thing. So it's so simple way to think about IaaS, or infrastructure as a service, is that there is really not to use that you couldn't do with it, or nearly anything and everything that's possible to configure, like setting up your web server, for example, or maybe mail server, or for that matter, you can do even Bitcoin mining or anything. You can do it almost on the servers. Now, when you come back to the because we are able to do it all these things because we have a control on the virtual machine layer also within the IaaS. So IaaS is a kind of a most generic approach. In that case, it can satisfy nearly any use case. It's just usually involves more work. When I say more work, you're going to set it up, these things, the servers and the configuration. So there would be human resources will be used, as well as the cost also involved. You will have to actually set up your server yourself and configure it in order to get your services up and running in this case. And that may not always be a bad thing, but one thing to keep in mind is with IaaS, the higher cost and that come to you, because you are doing everything on your own, and you will need people for that time to set it up, all these servers and these additional resources. Whereas with the PaaS and Saas, you don't need to configure that kind of stuff. So really, the ideal use case for IaaS is when you have an application that requires other applications to be installing and running, requires some pre-requirements or software or specialized components that to be installed on the server, and you don't necessarily get the flexibility to do it with the PaaS model or maybe SaaS model. So it makes SaaS is the best approach, use cases like that, and you have the flexibility to install any of the software that you need, and you want it to do pretty easily. So in that capacity, IaaS, or the infrastructure as a service, we will remember from our keywords, which is hosting, where we go for the planning and capacity and everything. We would do it on our own. With the PaaS, we are really building upon the platform that is Microsoft giving us. For example, a SQL database, you wanted to use it as a service or maybe a web app as one of the application. So you don't need to worry about the runtime or middleware or the operating systems. So the ideal case for the use of this PaaS model, or a kind of generic boilerplate applications. Web applications for one are very good candidate for PaaS that we can give you as example, which even in fact I have shown you as a small demo in the previous lecture for the PaaS specific. But with the PaaS, that what's being managed for us is what it makes is a lot simpler in case if a web application is really just building an application and focus on that and then deploy it through PaaS, like our Azure web app. In that case, similar case goes for SQL database to host it as one of the PaaS example. So with the PaaS, you just get a much quicker model with which to deliver your products and services instead of having to spend more time on configuring. In this case, if you see in the infrastructure as a service, you have to install. Let's take one example as the SQL database. So here, in the PaaS, the SQL is readily available, and you simply have to use the SQL service. But whereas here in the infrastructure as a service, you have to spin a VM, install and configure, and then install the SQL server and configure the database, and then your application comes into the picture. So you are spending a lot of resources and time. So instead, if you are going for the PaaS model, it much quicker model with easy to deliver your products and services instead of having to spend more and more time configuring resources. So the ideal use case for the PaaS is really twofold. One of the kind of boilerplate standard applications like web application or databases, or also for the new applications can be come up with a PaaS model. Anything that's built now as of today really should be built within the cloud in mind. So they call this is the native cloud approach, and that's simply because as cloud grows more and more powerful and bigger, it becomes more sense moving your on-premises applications by considering them when you're developing in the mind of cloud sets. So you can easily migrate permanently one or other day to cloud. So that's the in-house approach you should be looking into it if you are trying to develop any of the applications on your on-premises. So with the PaaS, we looking at build upon the platform that is provided to us. Now SaaS, our final model, manages everything for us, and our example that we use with the latest was Office 365, which is the email services, or maybe you can take it as the Salesforce as one of the example. So the infrastructure as a service equivalent would be setting up your own email server within the within your own servers. But with the SaaS, we don't have to manage anything. We can get email just to sign up to the new user as a new user from the portal, like portal.office.com, and then you sign up and you pay based on your consumption model with your email services, or per user based, or whatever the model they are offering for you, and at the end you are paying for them on a subscription model. So you are actually consuming. That's a keyword what we used, if you can remember. So again, if you look at the things like email programming, like Google Docs or Office 365, even social media like Facebook or Twitter, they are all considered as a software as a service. They are the softwares that were can be consumed immediately, that require no configuration or no management on our end. We can simply pay as a low monthly fee for them within the Azure, like we said in the lesson. That's not a lot of pure SaaS products. But Office 365 is a kind of one of the biggest one that we can think about it, and because of the things that we can also remember, like SaaS is one of the least used model between Iaas and the PaaS, and the SaaS is not because it's a not good, but there is just not as many offering as there are mostly within the PaaS or SaaS arenas within Microsoft Azure. So while you may not see this lot of SaaS offering out of there, it doesn't mean that there's nothing good or bad thing. So it just means that each application type has its own place, and the only few are really suited for the SaaS based application offerings. So in case of SaaS, really the best candidate are kind of again like PaaS applications, like email, office applications and the products. We don't necessarily need to manage anything underlining these applications. We really just wanted to consume them, and that's a kind of a keyword what we wanted to use. So as I said, I have given the keywords for every model. Like Iaas, I gave as a host as a keyword, and the PaaS I gave as build, and for the consume is the keyword for SaaS. So any application or services, we don't really care about building ourselves or managing ourselves. We just want to consume. That's a service really good, a candidate for looking at the SaaS service. And so we can see this image, this entire image, and we can imagine that that's really come down how much control you have within these each and every model, and based on that you can consume, you can use, you can build, and you can host. If you need as much as control as possible, we can start with on premises, and then if you can give some of the hardware level control, we can move to infrastructure as a service model. If you can give up of the middleware and runtime control, then we can move to PaaS. And finally, if you can give up all control over how the software is written and hosted, we can move into SaaS offerings. And as we move across, we also saving more and more money along the way. So I hope these series of lessons are help you to understand about Iaas and PaaS and SaaS. Hello and welcome back. We will be looking at cloud concepts, especially the public cloud model in this lesson. Over the next few lessons, we will be looking at public, private, and hybrid cloud models. In this lesson, we will be looking at public cloud model and what all of this really represents at the end of the day are just different ways to consume Azure services or different ways to deploy resources to the cloud or to the data center. Now, with the public cloud model, the most of the important piece of that is it is a multi-tenant implementation. When I say multi-tenant implementation, what exactly it means? Well, it means that multiple tenants or multiple customers are sharing the same set of resources or hardware or maybe a storage service, things like that on the cloud. Let's take one of the example. Let's say there are two companies and they both have virtual machines in Microsoft Azure platform. It might be possible that both companies' virtual machines actually exist on a same physical server, and that is a good representation of public cloud model. There's multiple tenants, multiple customers using the same hardware, storage, things like that. Now, within the public cloud model, all the hardwares that are being used is owned by, operated by a service provider. In this case, it can be a Microsoft, so it's a Microsoft Azure as the cloud service provider. It can be Amazon AWS or Google provider, maybe G Suite. So things like that. In our case, owned and operated by completely Microsoft. So we have the Azure as the service provider. And so some of the pros with the each of these models are no upfront capital expenses. So let's talk on that pros. We don't have any upfront cost to actually buy hardware ourselves. And because of all these hardwares and the service things like that are already in Microsoft Cloud, and there's no maintenance on our end to pay. We simply consume the resources that are using or that are at the Microsoft end, and we simply log in from the Microsoft Azure portal and we use them, and Microsoft will pay for the Azure staff with the uh, to make that hardware or the resources to be up and running for us. So that's the high level of reliability and scalability purpose and the maintenance. So it's not our job here. So many Microsoft Azure data centers, and they are so big with public cloud model, gives us a very easy scalability and we can quite easily scale up. So as many as resources starting from 1 to 10,000 servers, we can easily spin up in no time. So again, with the public cloud model, what we're really looking at is using the hardware that's shared across multiple customers. Now, that's not to say that one customer's application or systems using maybe a cloud brings down an entire server and affecting another customers. Microsoft makes sure that situations like that are managed and a customer facing an impact doesn't bleed out to other customers. So right off the bat, let's not worry about our system is being compromised by another customer. There are protections built in for that. But at the same time, it is still a lot cheaper for Microsoft to put many different customers into one server so that they can get the most utilization out of their servers as possible, and in return be able to make the most profit and then offer the lowest prices for the customers, and the cycle continues. That's what we even learned in the previous lectures. So most of the use of the cloud at this point is actually being used by public cloud model. But one of the cons that we wanted to look at that is less customizable, since we have less access over the hardware, since we have less control over the actual physical servers, there's a less customizations that can do around the server hardware and security, things like that. And another con potentially for the public cloud model is more latency within our request, since our request now going to an offsite data center somewhere on the Azure data center, there might be some additional time in our request getting to the data center and being served, because it's not on our on-premises. We are not sitting on on-premises. We are sitting on a internet trying to connect to the Microsoft data center. Now with Azure, there's so many different regions. This is probably not luckily, but it could be the case for each application that you are thinking about moving the cloud, which is a public cloud model. You need to take a look at where your customers are located and if latency will be an issue. And finally, one of the bigger con with the public cloud model, for certain industries or type of applications or potential for governance issues. So that what exactly it means, that is the governance issues means like a financial industry, such things, they don't want to give the data to store on the public cloud. Instead, they wanted to store it on their own on-premises servers. So that's where we're going to learn about the private cloud models or hybrid cloud models. So there's a lot of rules within this specific potential governance issues or regulations about how data is stored, or where it is stored, things like that within the financial industry. And as you can imagine, some rules and regulations requires that organizations store data on site or store in a specific way, that they have some kind of a control on various aspects of it. Now, if you're using the public cloud model, right off the bat, we are not storing data on site, and we may have all the control that we need and how data is stored. So with the public cloud model works for a large variety of use cases. There are some of where you may need that extra little bit of control that you don't quite get with the public cloud model. So just be aware that with the public cloud model and sharing hardware across different customers, you may run into issues with a few particular applications. Now, we will get into how to address this when we look at hybrid and private cloud later. But to summarize, we will remember that the public cloud model is a multi-customer specific one. That means multiple customers serving from the same servers, or maybe, who knows, where resources are shared across several different customers. That adds up to no upfront fees and lower price for us in a long run, since Microsoft can manage getting the most out of their service for us, and we don't have to worry about any of that. So I hope this has helped a kind of explanation for the public cloud model. I'll see you in the next lecture. Thank you for watching this. Hello and welcome back. In this short lecture, we will be looking at cloud concepts and especially into the private cloud model. In our last lesson, we looked at the public cloud model, and we remembered that one of the main points of the public cloud model was it represents hardware and the services shared across multiple tenants or different customers altogether. Now, today, when we look at private cloud model, we will see that that's in a lot of ways that exactly completely opposite side of the public cloud. Now, if you look at the screen of this, what exactly the private cloud, all the hardware and servers resources are dedicated to a single individual customer, and that's one of the main points of the private cloud model. And we can think about two different ways. One way is, if we had our own on-premises data center, we would consider that as a private cloud. Of course, how we build is that's completely all different case, but at the end, it's just serving for only for the one customer, that is just to you. And if at all, if you take the second way to think about it as a private cloud model, is having isolated resources within Azure. For example, by default, Microsoft Azure can be a public cloud where all the application systems resides on the servers that are also being used by other people. But what if Microsoft Azure offers you a private cloud model in isolated resources? That's called, again, a private cloud. Yeah, that is also possible with the Microsoft, where they offer for you a private cloud model. For example, if you see here, a private cloud consists of computing resources used exclusively by one business or one organization. So with the Microsoft Azure, you do have an option to go for a dedicated private cloud or dedicated agency, a specific data center. For example, if you see private clouds more oftenly used for the government agencies, financial institutes, and other mid to large size organizations with business critical operations seeking enhanced control over their environment. So, but it would be at the end, it would be managed by somebody else, which is again here the Microsoft Azure, but you do have an option to get it or request from Microsoft to get a private cloud model. Okay, but if you're thinking about in on-premises, how you can do it, it's all the normal data center, or you can go for Azure Stack is another product which is built on Azure Stack. If you see here, so this is the Azure Stack, which talks about the hybrid computing specific, but you can have very similar experience, similar way. You can have your own cloud on your on-premises, or you can go for the System Center. Microsoft System Center product. So this is makes a complete suite of different products combinations, also which makes you your on-premises uh, data center as the private cloud. For example, you can use the virtual machine managers to spin up automatically and manage with the servers with the configuration manager and the DPM for the backup and recovery, and for the self-service for the ticketing and orchestrated runbooks, which is a very powerful method where automatic execution would happen on your on-premises or private cloud. This would be the runbook execution. So all these integration with different tools for the managing, this is especially for the monitoring purpose, SCOM, and the service manager for automation. Whatever the monitoring tasks would happen, that can be automatically monitored, and then that can you can act on it proactively and reactive methods. So with the combination of System Center, yes, you have the capability of doing your own private cloud model. But now for this topic, what exactly the private cloud to understand? So it's a single tenant implementation and owned and operated by your IT organization, or maybe somebody's IT organization, and define your own data management policies, how the storage should be and when it should be retired, and what is the time frame of the archiving the data. For example, you want to store for 5 years, 10 years, it all the governance in your hand, and it would be a self-service and automated capabilities provided by new agility softwares like System Center or Azure Stack kind of thing. So what are the pros and cons by having this model? It's a fully customizable, so you have full control. You can request your IT team to do whatever the modifications at the hardware layer or any other layer you wanted to do it, and higher level of security, because the security it's in your eyes. You can visibly see what's happening within that private cloud, and you can get a better performance comparatively with the Microsoft public cloud. The reason being, when I say better performance, it might be coexist nearest your location or in your data center, so you have a direct connectivity. So it would be definitely a better performance, and you can choose what performance you wanted based on the budget that you have. But there are flip sides. Definitely the cons would be the higher upfront capital expenses you need to invest to procure those hardware and that software, all that. And for the risk side, definitely under utilization of resources, because you may not be using full-fledged all the resources, and higher ongoing cost, definitely for the managing. But it all depends again on your business, because maybe your company is into financial sector. You wanted to have the data fully controlled by you, then definitely this is a better way of managing. So again, to summarize, the private cloud is a way to isolate and dedicate a specific set of resources like servers or maybe storages and things like that to a single customer, and which is which is a completely opposite model of public cloud model, which is multiple customers using the same resources in the public cloud model. So with the private cloud, we get our own set of our resources which come at expensive of higher cost and upfront. That's a cost is again we are putting upfront and ongoing for these resources. But what we get is the benefit is definitely we get more customization options and higher security option, as well as the better performance is what we get it. So again, you can think the private cloud model is completely two different ways. Whether it's going to be your own data center with, as I said, system center tools or other Azure Stack or some other different tools you use it, or using isolated parts of Microsoft Azure Cloud. So the main point is that the single customer has a specific set of resources. So that concludes this private cloud. I hope this is useful for you. Catch you in the next lesson. Hello and welcome back. Now we will be looking at hybrid cloud model. In our last couple of lessons, we looked at public cloud model as well as the private cloud model. With the public cloud model, different customers using the same set of hardware servers like storage and things like that with the public cloud model. And with the private cloud model, we looked at how hardware and servers and storages were dedicated or completely isolated to one specific customers. So the major difference would be here for a single customer with the private cloud, and with the public cloud, multiple customers using the same resources. We also saw with the private cloud how we could look at into two different ways, either having our own data center, which is a private cloud we can consider, or isolated portion of Microsoft Azure that we are using, and we can also call it as a private cloud. In this lecture, we will be taking a look at hybrid cloud, and we are going to see how it combines aspects from both that is public clouds and the private clouds point of view to give us the most flexibility within the hybrid cloud. So what we are doing is we are actually connecting these two different clouds together so that they can communicate with each other. For example, let's say we are using some resources in Microsoft Azure Cloud, that's a public cloud, and we also have some either on-premises servers or networks that we want to connect the servers which are inside your private cloud wanted to communicate with the public cloud servers. Then we enable the communication, so that way it would actually establish the hybrid cloud. So again, so when it actually establishes communication, we called that actually represents in the form of the bridge or whatever the connectivity format, that's called the hybrid cloud. And again, some of the pros and the cons for this each and every approach would be there, right? So we wanted to discuss those approach. So before that, there are two bullet points. One would be the combination of a private and one or more public clouds represents the hybrid cloud, and also it actually enables the IT organizations to become as brokers of the different services. Now let's have a look on the pros as well as on the con side. So the first point would be the pros side. It actually offers a great flexibility. Some applications or systems on your end may require save data in a certain way, or maybe a compliance issues or security issues that require you to do a certain way of designing your own applications or those as specific applications so that data doesn't actually go out or something like that. So you might have such kind of requirements or things like that. So you can put them into the public cloud model. So what you would be doing is, instead of putting on the public cloud, you would be putting into the private cloud, and the applications you wanted to secure it and you wanted to isolate it in environment you are putting. So at the end, when you bridge them, it's one application with the end customers. That way you get the great flexibility. And now let's take an example for the resilience to the outages. Let's say if your private cloud is on premises data center and you have an outage for whatever the reason may be, but you always have an ability to fall back to your public cloud in Azure or vice versa. You might have to set it up where if your Azure resources goes down, your systems can be failed back to your on-premises data center, but things like that can be done automatically. So that's one of the examples. So it makes it easy, really nice in that if any of the outage does happens, having these two different clouds kind of like act as a redundancy in the background to keep your servers or services up and running. So there's no down for your business in front of the business side. Also, there could be no capacity ceiling when you take this kind of hybrid approach. Now let's think about on-premises data center as your private cloud. Were the if you are considering to expand your on-premises data center, it might cost us a lot of money to expand and building, getting more servers, things like that. However, if we decided we are no longer going to expand our data center, but any further purchases will go through Microsoft Azure, and we wanted to set up in the public cloud as one of the options, so that what would happen is that way we need more services. We no longer have to worry about building them into our current data center and buying more hardware. So we can just start deploying new servers, new applications, new business specific things to Azure. And because of that, we have no ceiling for the capacity, since Azure can scale infinitely, or we are never going to run out of space for all of your applications to start moving over to Azure. So this is also provides a great way to transition to happen from your private cloud or from your on-premises data center to move to Microsoft public cloud model. Since we are only using our private cloud for the applications that require this greater level of customization or security, we get the manageability there that we need. But we don't have to apply it all of our resources. Some of the apps that we have that are easy to manage can just stay in the public cloud, and we don't have to do anything special. Now let's talk about the con side. The con side would be definitely it's going to be higher upfront capital expensive is needed, because we are definitely talking about the private cloud. Also, when we talk about the hybrid also consists of private. That means private cloud itself, a on-premises data center, or maybe the service which you own. That means you are putting upfront capital expenses. Since we have dedicated servers or are in the isolated resources in our own data center or on premises data center or maybe on our private cloud, we risk underutilizing these resources, and we have higher ongoing costs and maintenance of those resources, since again they are dedicated just for us, and more maintenance also. Additionally, our private cloud might give us a little bit less compatibility with our public cloud depending on our situation. Usually on any of the on-premises to Azure or Azure to Azure hybrid cloud will work just fine, but in case that you wanted to hook up different cloud services, like making a hybrid cloud out of Azure and AWS resources, there might be some issues with compatibility that's getting going there. But on the whole, the hybrid cloud model is a great approach to kind of getting the best both worlds. You can deploy easy applications to your public cloud and save money that way. But the systems and applications that going to have that needed additional security and customizations can be deployed to your private cloud. and both the public and private cloud can talk to each other and act as a one big system altogether. Being said, I'm gonna conclude this lesson and catch you in the next lesson. Thank you for watching this. Hello and welcome back. We will be looking at cloud concepts in this lesson, especially for the comparing as well as we do the contrasting the three different cloud models, that is the public cloud, private cloud, and hybrid cloud. In our last few lessons, we learned each of these models individually, and also we learned about the best use case. The summary for the public cloud model was a multi-tenant implementation, and that means the multiple customers used the same set of hardware like storage servers, things like that. The main point of public cloud is that you are sharing resources with others, but you are doing in a way to lower your own cost and lower the management and administration of the resources in your end. Using the public cloud is best for one of these scenarios. Let's take one of the example that we discussed. For example, your company developing some of the new applications and that no need to communicate with your on-premises servers. So in that situation, you can simply spin up into the public cloud. So that's anyway not communicating anything with your on-premises, or maybe data is not storing anything on your on-premises. In that situation, that's the best use case for transitioning to the cloud. So whatever the new upcoming service will come, you will start provisioning into public cloud. And the good way to keep your cost down as you deploy all these new applications. Additionally, if you're writing new applications, their systems, the public cloud model is probably the best approach to take it as well, because it's going to let you write your applications in that in what's called a cloud native way. And that just means that you can write your applications in a way that most take advantage of the all features of the cloud. So by doing this, you are kind of reducing the need of any kind of customizations or need for a private cloud or anything like that. Like servers, if you take it as example of web applications or hosting web applications maybe in a public cloud, such things will make it easy for us because they are suitable for easily for the cloud model, so that you don't have much management on those machines. But again, with all this, main point of all these was that they really the best candidate for the public cloud is just an application or the workload that do not need much customization. That's the point we should always keep in our mind, because in any way of customizing the servers or security and things like that, because if you start doing like a data security and such things, you might have to go for the private cloud because of those customizations that demands your business. When we talk about the private cloud, if you're looking for data that must be stored on your on-premises or shouldn't go to the public cloud, in that situation you might be have to consider for the private cloud. That way you can fulfill your hardware layer or maybe your security or physical security. All that can be addressed with the private cloud model. So most of the companies will end up with the hybrid cloud, where they talk about the public and the private bridge connectivity between these two, so that the systems that do not want to contact with the on-premises, we simply host on the public cloud, and the systems that are needs to be or data must be on our on-premises, we would just simply put into the private model, but we would actually make them to enable to communicate with each of these private and public cloud models. So that way you are going to establish a hybrid cloud model that is a best combination for the private or the public cloud models, and this will actually makes easy, and this is the one of the fastest model, or most of the companies they use the hybrid cloud model. A really good use case can talk about the hybrid cloud would be you're trying to transition from your hybrid from on-premises to the cloud. if you're having an on-premises data center which is with your private cloud and you wanted to start using Azure as a public cloud, then taking this hybrid approach would be a great first step. And you can keep your existing on-premises data center, but you can just set it up your public cloud and Azure for upcoming servers that are not really need to communicate with your on-premises servers. You can even wire up with the two to communicate to each other, but it's not a fully rewritable of your system. You're not taking up on-premises data center offline or maybe immediately switching off to Azure at all. So it might take some time to go for that transition time. So in that situation, you might be ending up with this hybrid cloud environment. We are setting up essentially a second data center with the Azure public cloud data center and Azure, and you're going to eventually migrate all of these resources from your on-premises on your private cloud to public cloud. So it's a great, again, the first step in transition to the cloud by setting up the public cloud that you or your private cloud can start offloading the work to. And so I hope this has been helpful in clarifying different situations that might you want to consider using these different cloud models in whether it's a public or private or hybrid. Thank you for watching this. I'll see you in the next lesson. Hello and welcome back. In the next few lessons, we will be looking at core Azure products and services. Especially, we will be looking at Azure Architecture within the Microsoft Azure Cloud. We will go through each of these 5 different concepts which we will be exploring in more depth over the next few lessons. Our first lesson will be looking at the regions within Microsoft Azure, and we will take a look at how there are currently 55 different regions, each made of multiple data centers within the spread of that region. Next, we will be looking into availability zones, and we will see how an availability zone actually groups into 2 or more data centers together, and we will see how there are multiple availability zones within a region. We'll also take a look at how we can deploy certain Azure products and services to specific availability zones. So even if one is down within our region, the other one can still up and running and servicing our request for our applications. In our next lesson, we will take a look at Microsoft Azure resource groups, and we will see how we can group resources together inside one resource group and that all share the same deployment lifecycle, as well as how we can use a resource group to scope access control across the collections of different resources. In the next lecture, we will also have a look on Azure Resource Manager, which is the main deployment of management of API for Azure resources, and we will take a look at different ways we can use this via, for example, REST API or PowerShell, and we'll take a look at Azure Resource Manager templates, which will give us a nice declaration way of defining all our resources that we need. And final lesson will components that will be just discussed within the Azure. We'll take a look at how we can deploy our applications and systems across multiple regions. So even if entire region is down, our app still stay up. We'll take a look at how to deploy across availability zones. Again, if one is down, we can make sure that another is up and running, our applications still stay up. We will take a look at correct approaches to setting up resource groups for grouping our resources within resource groups. We will also take a look at in-depth at using the Azure Resource Manager properly, so we can consolidate all of our work into a set of templates that define the entire infrastructure we needed. So I hope you are excited to learn about these core Azure architecture components. I hope this lecture is useful for you. Thank you for watching. I'll see you in the next lesson. Hello and welcome back. In this session, we will be looking at Azure regions, what they are and how they can be useful for us. A Azure region is a multiple Azure data centers. When I say data centers, more than one. It's very important that to understand it's a multiple data centers within a region, and all these different data centers are actually within a specific distance from each other within the region. And that's mostly so Microsoft can kind of guarantee that they can and they will be able to communicate with each other over the fiber optic network as quick as possible. So they are no more than a certain amount of miles away from each other. Now here you can see that there are Microsoft regions. If you can go to this lecture, the same lecture description, you can find out here there are close to 55 different regions spread over 140 countries or different places you can see here. And this is where it was clearly mentioned government secret regions also available which are undisclosed within here. So a region is a set of multiple different data centers together, and the reason that there is a multiple data centers in a region is so and an entire region can stay up even though a natural disaster or some other accidents happens. Since there's a different data centers spread out, potentially a couple of 100 miles away from each other, it gives Azure a lot more flexibility standing up to one particular accident or disaster at one certain data center. The way we can kind of take advantage of having all these regions is just to use, it's called a multi-region deployment. What that means is we can deploy our applications and systems to multiple different regions to kind of take part of that resiliency that Microsoft offers to us. If something does happen within a certain region, another region could still be fine. And if our apps or systems that are hosted in both, then the region that's still up and be able to take over the load, and our apps and systems are less likely to go down. That's the main advantage of deploying multiple regions to ensure that you have as much uptime as possible for your applications and systems. And there's actually a few different ways that we can do a multi-region deployment. The one would be the active passive, other one would be the active active. Let's talk on these two with the designing way. Let's have a look on this. The first one would be the active passive method. So in this method we're going to talk about how this design is there. For example, you can see here Contessor.com, which is a public DNS. When we try to open, it is actually routing with the help of dynamically traffic manager. It's going to back to the active region, which is in this case east one, and similarly it can also drive the traffic to west side. So let's explain on this how this multi-region failure would happen, because if you see here, this region is Azure region west, this is Azure region east. So let's talk on this, how this works. What some folks like to do is to have all of their applications and systems deployed into two regions, but only one as a primary region they use. And we can see that in this image to the east region, and you will see that they have an active region set as this east region, and at the top of you will also see there's a passive region which is in the west side. This active and passive kind of situation is really best for failover, meaning that if you want to have all your traffic go through east region by default, if something goes wrong, the traffic will dynamically route back to west region, but only when something really goes wrong. And what this active passive setup allows you to do with multiple region deployment is to fail over instantly without any notifications to the customers. That means they don't even knowing uh, it happened, but they must be exist from one region only. That's that specific region. And what that gives you a lot more resilience to outages in specific regions. But this comes at higher cost as well as. So obviously when we deploy our assets in two different regions, in this case east and west, we are going to have to pay the cost for all the resources that are using in both regions. Think another way. So these systems will definitely will have the storage. So the storage must be there in the west region as well as in the east region. So another way, we are actually paying for east region even though we are just using as a default. That may be a word, but think about in this situation for west region, we are paying even though we are not using. We will be only using these resources when it actually fail over. But this is a little bit cost to be paid. That means you're not quite utilizing fully, and so there's a kind of hidden cost with active passive setup, in that all of your passive applications and systems are being paid for but not really used. So this kind of active passive multi-region deployment is really best when all of your customers or users are in the same region as well. And the reason for that is because if you're going to have all your traffic going to just one active region, is the best that region be where all your users are. So they all have lowest latency in your data centers. Now when we look at into even better setup, though, when we talk about an active multi-region deployment, we can see that on the image on the right side. Now what an active arrangement is, unlikely active passive, where we have an entire region deployment but not being used. Active has us deploy all of our assets to multiple different regions. We can see in this image west region and east region, but both being our resources in both regions the entire time, because the traffic is dynamically sending to both the places, though we won't be paying for anything that we are not actually using. And this will provide a couple of more benefit over just the standard resiliency to outages in specific region. In that now we can see when our applications or systems are up in multiple regions, we can use Azure products like the Traffic Manager to distribute the traffic and workload across regions based on whatever the closest to where our user is. Let's take an example and explain the same thing. If we have users all around the country and we know that we need to deploy at least 2 servers, we could look at a couple of different options. We could deploy 2 servers in a single region like East region, but our customers in West might have higher latencies getting into that East region data center. And also if something does happen to East data center, we may not be protected in the case of failures, and our apps and services might be down. Now another way to do that would be to deploy one server in East and one in West. So we still have 2 servers that we need to run our applications and systems, but we can spread them out across regions, and this provides a couple of different benefits. Again, our customers in West will hit West data center and our customers in the East data center will hit East. So wherever they are close to their data centers, they are hitting into their regions, and because of that all our customers will have low latency possible. Also, if one of those regions goes down, our traffic manager can take care or can just point all the traffic to the regions that is still up, and our users won't even notice that our systems are down in any data center. And then on top of that, if that situation does happen where one of our data center is down and all of our traffic goes to a data center that is still up or a region that's still up, we can also have the region set up to auto scale. So when it does have to quick up an extra load, we can automatically scale out our servers as needed to handle the load and scale them back in when we are done. For example, our other region is back online, and so between active passive, active deployment, my suggestion is to always try to go with active approach, as it gives you a lot more resiliency to disasters and outages that happen within specific region. But again, to summarize, that the region is a grouping of multiple data centers in Microsoft Azure. We're all connected by a very high-speed internet network, and they all are spaced out within a certain amount of distance between each Azure data center, and they can guarantee this super fast communication with all data centers combined make up an individual region. And when we buy Microsoft Azure products and services, we can choose to deploy them to one or more or many different regions. And in doing that, deploying to multiple different regions, we can gain an extra level of availability and distributing our systems globally. So I hope this is helpful in clarifying Microsoft Azure regions a little bit more for you and give you more insights on how this works for your applications and systems. Thank you for watching this. I'll see you in the next lesson. Hello and welcome back. In this lesson, we will be looking at availability zones, what they are and how we can use them. In our last lesson, we took a look at Azure regions, and we learned that a region is comprised of one or more data centers. But there is one more level between a region and an individual data center, and that level is an availability zone. So what exactly availability zone? So availability zone is a unique area within your Azure region, and that is made up of one or more data centers. And there are going to be multiple zones within each region, and we can kind of see this looking at image in the bottom. We have a box here representing the region, and we can see three different availability zones within each region, or within this simple one region. Each one of them will have one or potentially more data centers that makes up the availability zone. And what availability zone really do is allow for higher availability for our applications and systems by protecting us from individual data center failures. And the way they can do is because some Azure products and services can be deployed in one or two different or more different availability zones within a region. And also for Azure products and services like storages, for example, can we set up a replicate data across availability zones automatically. And when you do things like this, you can get that extra higher availability just because your data is now separately replicated in multiple data centers and multiple different physical locations. I'll take a step through that example and see that what I mean here. For example, with Microsoft Azure Storage, we can choose to have our data replicated across different availability zones within one region, or we could have our data replicated across multiple different regions. If you can take a look at here in this region, for example, here, if one of them goes down for some reason, or one of the data center goes out, and that's where our data is stored, well, this is no problem if we used zone redundant storage, because we save data to zone 1, it is automatically copied and served for us from 2 or different zones. So that's again a zone redundant is some of the storage specific word or storage specific type, but in the background it is actually storing into a different availability zones. But if you can take an example, if something goes wrong within this data center, within this region, our data would still be lost even though we choose potentially to save it across multiple availability zones. In the case of something like this, if we were to save our data across different regions, we would have most protected against data loss, because it's very unlikely that multiple regions will go down at the same time. The services from Microsoft Azure can be deployed into different availability zones, and let's take a look at your browser here. What Microsoft says is within this Microsoft web page, if you can see here the availability zone 1 and zone 2 and zone 3, and these services are very similar what we have discussed. Now it's gonna talk about, like, you have here most of the services where it is coming up. For example, here they are talking about Linux virtual machines can be served from America, Europe and Asia Pacific. And the storage can also be done. A different Azure services can be offered from high availability zones. Let me show you how when we create a virtual machine it looks like. If you see here, when we go back to virtual machines and create a new virtual machine here, it would be asking you here in the availability options. By default nothing will come up here. If you start choosing here as availability zone, so you need to choose here 1 2 3. So that means within that region there are different data centers. So you want to replicate to 3 different or 1 different. You can see here you can optionally specify an availability zone in which you want to deploy your VM. If you choose to do so, you manage disk and public IP, if you have one, will be created in the same availability zone as your virtual machines. So that way you will be getting more availability. That way you can simply deploying to multiple availability zones to ensure that your VMs as much as possible uptime you have. To summarize this, an availability zone is going to be a grouping of one or more data centers within a region. And a region includes a multiple availability zones, so it can internally manage keeping everything up and running as much as possible. When one goes down, all the workload can be then transferred to other active availability zones. So we can take advantage of all this by developing our services specifically to availability zones to make sure that a localized disaster within a region doesn't bring down our entire infrastructure. I hope this is useful for you and clarifying availability zones for you. Thank you for watching this. I'll see you in the next lesson.
Hello and welcome back. In this lesson, we will be looking at resource groups and what they are and how we can use them. In a simple sense, all the resource groups are really a container related to Azure services that we group up together. So when I say container, think that it's like your folder, but you don't have a child folders. You can't create within those resource groups a child folders, because containers are in this format like a group of all the services, all the resources within that Azure groups. So let's understand more about what exactly does Azure resource groups. So now we talked about a resource group is really a container. It's a container of related Azure services that we group together. So let's understand some of the concepts also before we jump into Azure resource groups. So you can see here Azure resource groups in this chart or in this hierarchy. You can see it as in the middle, and below to this all you have is Azure resources, or let's say also services like SQL services or virtual machine services or storage account services or networking services. So all the services can be grouped into a resource group. So these resource groups are we can very well design these resource groups, like all the SQLs or maybe all other services, automation services. All these are coming from your subscription. So these subscriptions are maybe your company may have more than one subscription, definitely, because of a different business unit. So in that situations, the subscriptions, on top of it you have the management groups. So now let's talk about the permissions, maybe to better understand if you're trying to set the permissions. So
if a person has the management groups, so that's where you'll have the full control. And subscriptions, again, the down layer, and the resources, like you try to do the RDP direct to the VM, that's a last layer of permissions what you grant. But at the resource layer, you can grant the permissions. That way you can easily set up your properly arrange your entire resources in a proper way, so that it's easy to identify what services goes to what resource group later point, and that makes very easy for us to manage later part. Okay, let's jump into understanding of the resource groups first. So when I drill down the resource group, as I said, you may have one as line of business applications with the one website, maybe storage, and the SQL database. So you can pull all these three different resources into one resource group. If you think about the infrastructure as a service workload as one of these service, so for that also, like VMs and storage accounts and MySQL, all that into another resource group you can create. So your company have in this situation two different resource groups. One is a LOB app, other one would be the infrastructure as a service workload. So let's understand a deeper layer what exactly this resource groups. So it's a container of related Azure services grouped together. A resource group is not a product individually to buy it from Microsoft Azure. Rather, it's something that we can use to group all the resources and products or services that we buy from Azure. So in other way, when we try to create any of the Azure services, the first step or first thing that we have to do is to place these services or these things into one of the resource group. That means we have to create a first step as the resource group. The idea behind for the resource group is that you should be grouping together related resources. Anything that shares the same life cycle, and is that to say any resources is that should be deployed or updated or deleted at the same time. They all belongs to the same resource group. And it's also important to know that single resources can only exist in one resource group. When I say single resource should be in a single group, just to explain more, if I just create a VM, I can't place into multiple resource groups. I must have to choose only one resource group, and it doesn't allow me to choose multiple resource groups. Also, the resource groups are not tied up to a specific Azure region. They can contain resources from any region anywhere. That being said, all they really are is a way for us to logically group together services that share the same application lifecycle. Also, a really good use for the resource groups is that we can use for them to scope access control operations, as I explained here, like the setting up the policies and other things within the Azure, allow or disallow certain actions or type of things to happen. We can scope up those policies across an entire resource group. No matter who's using the resource group, no matter what kind of resources and services are being added to the resource group, we can affect administrative policies across the entire group. And that make it great for larger organizations who needs and manage Azure resources company-wide. As we said before, resource groups can contain resources in a number of different regions. Well, likewise, a resource can interact with resources in any other resources. Like from this workload to another LOB application, it can interact. So there is no boundaries or firewalls or things like that between resource groups. It's not like the resources within them cannot talk with each other. So it's a free flow. They certainly can. There's no boundaries there. Again, the real main point with the resource group is that we're just grouping together the resources based on their application life cycle. That's a very important point here to understand. So now we don't have to do this either if we have a small applications or systems. By all means, you are able to just create one default resource group and put every single services that you're going to use in a Azure within the resource group. But As you grow, you will find a little bit more helpful to isolate and kind of categorize your resources based on these resource groups and keep different systems, a line of business applications within their own resource groups, vice versa, having everything in a single resource group. So that way, it really helps us instead of placing in a single group, single resource group, well, a better way to manage with the multiple resource groups for multiple line of business applications. We'll take a look at in a few quick examples if you could group resources together within a resource group. So on the top, we have a standard line of business web applications and the resources that we will need to app, services, web hosting, or such things. Perhaps we will need some storage tables and SQL database here. And now all these components are necessary for our line of business application to run, and all these components are kind of a relay on each other. If I don't have a database, my application wouldn't work, or vice versa, because these are grouped properly. Like this is the web server, which is a front end, and the SQL and data which is loads into your web page. So all these are grouped resources. So it's one of our line of business application. If I don't have a database, or my application wouldn't work, vice versa. And so these kind of all the things in the same life cycle. And what we can do in this situation, we can put all them into a single resource group. I can call as LOB app, for example, that as the resource group. Now in a different situation, we might have to end up with another solution. For example, you might have to create maybe two different VMs and MySQL instead of your SQL services and some of the firewall rules, all that you wanted to set up. So you can create one more resource group called Iaas workload, and in fact, both can definitely talk if really needed. But if you group them into one, it makes a complex to see what things comes from where. So if you end up by creating two different business units or two different resource groups, because we are talking about resource groups, so that would makes more sense having different resources falls into different resource groups. So this makes, as you get bigger and bigger, as your company grows, you can start and see it's a nice having each team to be able to have their own resource group. As a company, we can restrict access to which teams can use which resource groups, or which resource groups are allowed to certain type of resources and things like that to create. For example, in my line of business application, an administrator might say the line of business app resources group is not allowed to provision anything except what's listed here: the web application hosting, storage, tables, and SQL database. And you can apply that kind of a rule the entire resource group and enforce it to keep costs manageable and predictable all the time. Everybody doesn't provision something that they don't need to end up costing money for you or for your company. This gives a great way, great flexibility to manage at the permission level for our resource groups too. To summarize, the resource groups really represents a way to provide a container over certain Microsoft Azure resources. For example, a VM or web application storage or SQL, MySQL, whatever the services that are offered by Microsoft Azure. And that container is growing all these resources based on them, all sharing the same life cycle. Other than that, there's no real boundaries, and resources can talk to other resources and the resources groups with no problems. Let me show you what I'm trying to talk. So this is the one of the resource manager link, but let me show you about the VM. So when I try to go to create any of the VM, like I just have to create new VM. So the first place it's asking for my subscription. Below that you have the resource group. So we talked about, if you remember, we talked about the resource groups, right? So these resource groups are on top of it. You have the subscription. So it is exactly asking for the subscription. So that's the top level, and down is you have the resource group. So either you have to use one of them or you have to create one. You can't have, for example, I have NS as the one of the resource group. I can't have one more inside this. All I can do is I can create a new one, for example, demo 1 2 3 example. So it's going to create and it's going to place all the resources or whatever the VM demo VM, for example, it's going to place into this specific resource group. So how it looks like is, if once we created this a VM, if you just go to navigation here, you have the all resources and also you have resource groups. So when you click on the resource group, this is how it's gonna show you. So here you can check out, this is one of the resource group like this NS. So all the services that are coming from Microsoft Azure, you can check out here. So this is what the resource group, and you can't have a nested one. If I want to delete, I can delete here. When I try to delete, it's going to delete everything. That's what it's going to say, and you have to give a confirmation of that resource group. You have to type manually and then click on hit delete. That's going to delete properly the entire resource. So we are maintaining the complete life cycle. For example, when I say life cycle here, so this VM has the here you have the virtual network network card here. This is the network and this is the network card, and you have the public IP and the firewalls and storage accounts and whatever we have, all these resources related to your specific to your resource group, all will be deleted. So when we are trying to create, also the VM gets created and it's going to place into that specific resource group. So we're talking about here the life cycle. So life cycle of inputting all the resources into one place. If you want to manage or you want to delete, everything can be done from that specific resource group. So in that way, it's so easy and very important for the resource group to manage in a right way. Otherwise, think that here if you have multiple VMs, multiple things, you may be wondering this specific network or AZ belongs to which VM. Let's say here you have 2 VMs or maybe 10 or maybe hundreds of VMs, so you would get confused what VM goes to which network or which NIC belongs to which machine, because there is no proper way to look it here in the visualization. So it would be difficult to manage, and also the same case for the granting the permissions. So you can set the access at the resource group. So you can go to the access control arm and you can set up the resources, or you can set the permissions, what kind of permissions you want to set it up. So that's where the resource groups come into the picture. I hope this is useful. Just we'll continue with our PPT to explain more about what exactly this resource group again, and to understand that. I hope this has helped to clarify the resource groups and how we can use them. Thank you for watching this. I'll see you in the next lesson. Hello and welcome back. In this short lecture, we will be learning about Azure Resource Manager, which is one of the very important tool within Azure. Azure Resource Manager, sometimes we also call as ARM or ARM in short sometime. So do not confuse that if somebody calling as ARM or ARM, like A stands here Azure and O stands here Resource and Manager ARM. So most of the time the Microsoft documentation also refer as ARM instead of in a full name. So I just gave the title as also Azure Resource Manager, but most of the time we call as ARM. So what exactly this ARM or Azure Resource Manager? Well, one thing that it makes it very important of the services within Azure is it's a single centralized service that can be used for both managing and deploying our complete assets within the Microsoft Azure. So that's made us completely very critical for within the Azure services, because you see here Azure Resource Manager is the middle, and which can communicate with your identity management solutions. It can be ADFS or Azure AD, and it can actually it can be communicated with one of the APIs like Microsoft Azure Portal, or it can be from Azure CLI, or even the developers can start creating their Azure services directly from Visual Studio. So what would happen is they interact with this Azure Resource Manager in the form of either writing a code in a right format. In fact, it can be a JSON format by declaring those values and properties, and then they would start creating the required Azure services. So not just that creating, they can create as a template, and that template can be reused again and again. So that's all about at the high level of this design side. Let's jump into the complete explanation of ARM or ARM. So what exactly is this? So let's dig into this a little bit more. When we talk about managing our own assets, we are talking about how Azure Resource Manager let us create and update and delete resources, including the ability to do within the ARM templates. So there's a template that can be called as the Azure template or ARM templates, and right way would be the ARM templates. So you create a resource that can be converted into ARM template so that it can be reused later point. Let's say you created with all your configuration a specific service, and you wanted to reuse the similar settings to create in no time, then you simply have to use that ARM template to redeploy again and again whatever the services you wanted. So it's so easy. Now, in addition to managing our resources like we just went over, the Azure Resource Manager also can deploy our resources, which is really cool. It combines both the services management and development and deployment all inside the same API. And what you mean by deploying our resources is once we have configured everything that we have, let's say we have a virtual machine. Once we have configured that, then the next step is to deploy it, which will actually start up the virtual machine and host it on a server somewhere. The same for the app service plan, which is to host a web app. Once we have configured that and pointed to our application code when we deploy it, that's when our website actually becomes public and everyone can see it. And so having this ability to do both create, update, manage your resources as well as to deploy them, to take them offline when we need it for maybe a maintenance, makes the Azure Resource Manager again your single kind of centralized spot for doing all the administration and management activities you need overall for your Azure resources. So now another cool thing would be with the management side. Since when we are trying to deploy with the Azure Resource Manager, we can also add up how the access controls should be done and auditing and tagging of our resources so that it enables us to secure it and organize our resources after they deployed it. With access control, for example, when we say access control, we can set policies so that only certain users of maybe a certain users of in a group that can actually create resources, for example deleting resources, such things can be applied. And with auditing, we have the ability to go back and check logs to see which user actually created or updated or maybe deleted for that case of any of those resources, or maybe deployed that specific resource. And with the tagging, we can apply tags to resources across resource groups and resources so that we can later search by tags and we can see all of the resources being used throughout our organizations based on what we have tagged with them. Just to give you more about the taggings commonly used for the department codes or within your business, especially on the name of, for example, let me show you here in the any of the resources you can give here as the tags, maybe for this resource group which I'm talking. Maybe if I want just for the VM or maybe for a VM, I can give here tags to that specific business unit code, or maybe a cost center code that can be given so that I know I can easily keep track of my billing centers, which resources are being used. And also let's take a step back, and we have talked about the management and deployment aspects of Azure Resource Manager. With the management side, we can both actually create and delete our resources, as well as the effect access control, auditing and tagging across the resources. And we have looked at how we can deploy resources, as well as even take them offline when we need maintenance, all through the same single API that's called Azure Resource Manager, or ARM. Now, we also touched briefly on the fact that we can use templates. So let's have a look on what exactly I'm talking about templates. Let's say this resource, maybe let's take the one of the VM here, and you see here this VM is already got created, but this also have a template format. You see here, this is the JSON format template which is already available for me. So if I wanted to deploy similar one, I can straightforward go ahead and start deploying. So what would happen is the same kind of resource which is gonna create for me. So I no need to again input similar values. Let's say to understand about more, like resource is about virtual machine, type is, so that means it's going to deploy a virtual machine. So similarly, if I try to deploy a website example, this is also same case with the web app. You can check out here web app. This is also getting deployed similar to the website default value. So such things can be deployed automatically. So every resource that we have within the Microsoft Azure portal, that will have its own ARM template, definitely, because that's a middle one, that's the interactive one which we wanted to do it. So that's why we said it's a single centralized service that we can use for both managing and deploying our assets. So it's all about the managing and deploying. So everything will have a template. Let's talk on that templates or ARM templates. That's a big topic this is actually, and we will look into it in the upcoming lectures, but just to understand at high level, to talk on this specific topic within this course, I'm going to give you all the inputs that are required for this exam. Now, you have here GitHub website, which is a quick start templates. For example, you want to create maybe a single VM with the 2 network cards, or a blank VM. Such things, everything is available here. You can visualize how the thing's gonna deploy. So let's see, this is going to be, if I just zoom it, you might easy to understand. It's going to create a network security group. It's going to ask for some of the variables for the public IP, NIC2 and NIC1, both connected to one of the virtual machine, and this is a storage account, this is a virtual machine. So this is how it's going to deploy. So if I just go back to the previous designer, that's a bug actually, I can't go, but if I just go to GitHub once again, just search as the Azure template in GitHub, that takes all these templates which are available 101 templates. So here, take any of the template. Let's take 1 VM and 2 NICs. So we did visualize that, and if you want to deploy straightforward, you can do it from here. But let's talk and let's understand what exactly this ARM templates. So ARM templates are a format which is in a JSON format. Let's have a look on it. So Azure deploy JSON file. So if I just click on this JSON file, this talks about all the structure format, which is a simple input format file. So let's take it also have, if you see here, it also have the raw format. So this talks about very clear view if you're trying to understand like properties of the IP configuration and the variables for the NIC2. Like this is the type of the network card. If you want to create a network card, it goes to Microsoft.network/network interface. Now, so these are the templates which are quickly available for us to understand. And you also have the parameters JSON file. So all you have to do is you have to just give the parameters to be passed, like username and the password, and the rest of the things are already available within this template. That's what we are going to use for the Azure Quick Start template, ARM template that can be deployed. So now let's go back to Microsoft documentation. What we are actually trying to look at here is, like, if you just go to the quick start to create Azure ARM templates by using Azure portal. So let's try to create one of these storage account with this format. So what would happen is you can check out this the template which is coming up here. So let's talk on this specific template for a minute to understand what's going to happen. So here it's going to asking for us to select the resource group. So the resource group is the group which we learned in the previously to as a container, and now the location which it needs as a parameter. You see here it's going to actually ask only these parameters. Later point it's going to deploy. That means when you click on the purchase, it's ready for deployment. After all of these explanation, you should be able to understand the benefits of using Azure resources, because we talked about the repeatedly using all such things. So let's take a close look what Microsoft site says. So if I just scroll down to Microsoft overview page for Azure Resource Manager overview, you have all the benefits listed here. Let's have a look on it. So what we can do is we can repeatedly deploy our applications and solutions, and know that our resources are always deployed in the same consistent way or consistent state altogether. So you're not making any manual errors, since you are following a ARM template, because the template will ask only for the declarative values, as we had a look on here. For example, here it's going to just ask for those values only all the time. You see here it's just selecting, for example, you don't want the central years to be taken by the end users, so that has to be grayed out. So simply we will hard code that value into our template, so that every machine or every resource that is going to deploy it, it's going to be in a standard location called central US. So that way it would be beneficial for us. So let's also think about like you're trying to deploy a app service plan, or maybe a SQL database, or other things like that definitely follow it's a template method that would actually result ongoing things which is going to happen each time, and makes us helpful if we have multiple environments, that we might start with a dev environment, make our templates ready, similarly deploy our resources maybe, and then edit our templates until our environment is the way that we want it, or that way we need it, and then we can move it to our applications becomes more stable. Then we can move to, or we can push it to second environment, like testing or pre-production, something like that. So think about in that direction, which would definitely help you to bring more value for your management and ease of deployment. This really helps. The way we want our environment is set to exactly the same way every single time, and it makes it really great for us for situations like that, where you have multiple environments and you don't want to do any manual work every time to deploy or set up a new environment. So when we use the template in this way, we are using declarative of approach, and declarative means that we are telling the service how we wanted our infrastructure to end up after templates have already run, rather than going through a set of steps each time to configure our environment in the same way. Rather than using the scripts and kind of a procedural approach, these templates let us work with the declarative approach to determining how we want our infrastructure to end up after deployment. And the cool part about the template is that we can even define dependencies between our resources so they are deployed in the right order, which is really cool for us to save, and it saves a lot of time for us as an administrator. We might to see that certain resources need to be deployed after another resource, and we can make it so in our templates, and Azure Resource Manager will deploy our resources in the correct order. Let us take a look at Let's take a look at our overview of creating a template. You can see here, so this template is talking about unique things here, like storage account name as well as the parameters, resources, all those things. So when we actually downloaded this specific template, it's going to actually talk about the similar structure. So within this file, the structure is a JSON format, and you see here within this you have the following values, especially the resource group and location, account type. All these things has been already prompting. For example, if you see here the location, which is actually coming up, account type and kind and access style, supports HTTPS traffic only. All this is a value which is actually a variable value which is asking us to enter as the input. If at all, if you wanted to go for a hard coding, for example, here a storage account name you want to hard code, you can put it here so that it's gonna make it as the not the variable, so it's going to be a hard coded the value. But remember that a storage account is a unique thing, so you make sure that you have that name is not taken by anybody. Similarly, if you're trying to create, since we are talking about the storage account here, the storage account, to create that, what we do is the type on a resource we are going to create as a type as the storage accounts from the Microsoft.storage. So for every type of resource will have a different values to be entered here. For example, here in this case it's just for the storage. So let's have a look on it for another resource. For example, with this specific to the JSON file, again you see here the variable and the resource. You see here the resource type is compute. Under that it's going to actually create a virtual machine. So this is the type you're going to do it. So these things are more flexible when we wanted to edit or we wanted to set it. For example, here it's starting this IP address suffix. Instead, you want to change it, you just have to change a little bit. That would actually go and becomes as a one standard. Or you see here, if I use this template all the time, I'm going to get it the same address prefix that makes my subnet 2 as a standard. So I don't need to input or do any kind of manual mistake with human mistakes when we try to input the data. So that really helps the and gives you more flexibility for us to create anytime with the templates. Once you have the template is ready, all you have to do is you just use the same template. So as I explained earlier, you can use the same template, like you can download this template like this and simply use the template to redeploy. For example, if I want to deploy, you can, all you have to do is deploy, and you can also add it to your library so that you can reuse later point from the library. So that makes very easy for us. To summarize about Azure Resource Manager, it actually provides us a single consistent API and service to use. It internally will call out all the Azure thousands of hundreds of various different Microsoft Azure resources to providers in order to affect our changes on actual Azure products and services that we are using. I hope this is useful for you to better understand about Microsoft Azure Resource Manager, or ARM in short, sometimes we refer as ARM, and how this is going to be a centralized service and how both we can use and deploy for Azure resources. Thank you for watching this. I'll be seeing you in the next lesson. Hello and welcome back. In this module, we learned about Azure Architecture components that we went through over the past few lessons. We'll go through each of these components, what we have learned so far within this short lecture, to summarize our knowledge to apply to the Azure architecture. To begin with that, so let's jump into each of these to understand better what we have learned so far in a summary point of view. So just to recall, availability zones includes more than one data center. So even if an entire data center goes down within a certain region, if you have developed or deployed our applications services to multiple availability zones, the other one that is still up will take over load of that specific applications and will stay up and running. And deploying to multiple availability zones really protects applications from a single data center failure, and doing so it allows us to gain higher level of availability for the applications and services. That's kind of a recurring theme between availability zones and regions. They both kind of interplay to allow us higher availability. With availability zones, we're really trying to protect ourselves from a single data center failure by making sure that our applications and services are deployed to at least 2 data centers into different availability zones. Now, with our lesson on Azure regions, we took a step further and we learned how regions include multiple availability zones within their own multiple data centers. We also learned about how we can deploy our applications and systems to multiple regions, and with availability zones as a combination, we are looking to protect against a single data center failure. When we deploy to multiple regions, we are looking to protect against multiple data center failures or even an entire region failure. And this is less likely to happen, but it is still not impossible, right? And multiple data centers in a certain region might all go down because of an earthquake or some sort of natural disaster, or entire region might actually go down for some reasons, which we may not say, but there's a possibility. And maybe a natural disaster of some sort of earthquake or flood effects takes out of an entire region worth of data centers goes down. So if you're deploying our application, servers, or services to multiple regions, even if that happens, our second region is still hosting our applications or servers or services, which will absorb the load from other region which is up and running. Our customers won't even able to tell us or tell that one of our data center was down. Whether you go with availability zones and deploying to multiple availability zones or deploying to multiple regions, what we are really talking about here is a higher availability for our applications and services. By making higher availability, we no need to tell about any apologies to our customers that our site went down, or going through our data to see if we lost anything or any of these nonsense things that happen when our sites or applications actually go down. We don't have to worry about that. Our business is continuous nearly all the time when we are on Azure, and when we have deployed on multiple regions, and that actually lets us focus on our business and not bringing our systems back online every time a disaster happens. Also, it's worth nothing that we can get a higher availability faster by going with the cloud, and I mean faster compared to if we were to do with our own data centers. You can think how much it would actually cost, how long it would take for us to build our multiple data centers. You can think about how much it would cost and how long it would take for us to build multiple data centers with all that redundancies that Azure currently offering for us to build similar that kind of multiple different geographic regions. Since Azure already has a world-class data centers all around the world, it's a lot cheaper and faster for us to just pay or just buy into that specific services, and we can start our business from there on. And so not only do get higher availability, but we get it immediately based on Azure Cloud. And finally, it gives us easy disaster recovery and backup options. Let's say that we have deployed our applications and services to multiple regions like we were supposed to do. And by some of the fluke of luck, let's say both of these regions usually go down because of some huge, horrible natural disasters. Well, even in that case, when we go down with Azure, it's very easy to recover our assets and get back up. We could just identify the third or even fourth region that are still active and deploy all those assets instantly, and those regions, and get back to the business as soon as possible. With our own data centers, we would have to literally build a new data center before we could recover our assets to there. It's a lot more to do ourselves, and all these really at the end of the day just adds up on us, and keeping our applications up and running as much as possible. Want to deploy them as widely as possible. There's no real one single point of failure, whether it's a specific data center or even a region. One problem in one area shouldn't bring our entire application stack down. We have covered high availability that we get with availability zones and regions. In our next lesson also, we had a look on resource groups, and we looked at how we can use these resource groups to easily manage all the resources that share the same life cycle. We took a look at some of the examples that have taken, such as virtual machines and SQL servers, tables into storage, and all these various resources. We looked at how we could group these together since they all share the same life cycle. So we could manage and administer our resources easily and all as one group. The real point of the resource group is that it is consolidates our management and administrative activities so that we can perform a few functions as possible, but affect the most resources as possible. And it's really a way to organize our resources by their life cycle or by their kind of logical function. Resource groups are a great way to group everything together to keep everything organizing from a business perspective, and they are free as well. It doesn't cost any money to set up or a specific resource group or any of the number of resource groups. So we might as well as take advantage of the features that they are giving us since they are free for us. And finally, in our last lesson, we talked about the Azure resources. We took that's a resource manager, that's nothing but ARM. Sometimes we call it as ARM, which is a single centralized deployment management service that lets us a variety of things like create, update, delete any type of Azure resources, apply access control, auditing, tagging against of any of the resources, or deploy and take our resources offline when we need to do. We also took a look at using a templates that's called ARM templates, and how that's very useful and helpful for larger organizations to be able to repeat their deployment cycle or deployment templates or deployment across multiple environments like test, development, and production. And the main benefit of using Azure Resource Manager or ARM is that it saves us a time and money by giving a single service that we can use manage all our resources together, vice versa having to do them individually. As well, some of extra productivity tools like templates that we talked about providing us even more value in being to continuously redeploy our assets and get them same result every time. And finally, with the tie into Active Directory, being able to allow for security operations like access control and rule-based access control. We get the security that we needed to make sure that rogue individuals inside our organization aren't allowed to create any new resources or cost us money, even deleting resources and take our applications or systems down. Not only Azure Resource Manager or ARM, in short, the single centralized service to use to manage all the resources and encapsulated security as well, making it a very well rounded product that we can use for all our maintenance needs. When we look at these together versus doing this in our data center, we get higher availability zones and regions that would cost us tremendous amount of money to replicate ourselves. With resource groups, we get the ability to group and manage our resources together, when we would also cost us a lot of money to replicate ourselves if we were to try to do that against our own data center. And with the Azure Resource Manager as a complete service management layer, again, we keep getting additional value by using the Azure cloud with these tools that let us simplify our management and administrative activities using these simpler services. I hope that helped you to get better understanding some of ways that we can use Azure architectural components that we talked within this module. I hope this is helpful for you. Thank you for watching this. I'll see you in the next lesson. Hello and welcome to this new module. In this module, we will be looking at the concepts that we will be discussing in the next upcoming lessons within this module. Now, over the next few lessons, we will be looking at the core Azure products and services, especially at the Azure products and services that are available within the computing domain. We will go through each of the 5 different components, starting with computing and storage and networking and databases and marketplace. In our first lesson, we will take a look at Microsoft Azure products and services available within the computing domain. And here we will be taking a look at virtual machines and virtual machine scale sets, which are the base level of computing that we can get it from infrastructure as a servicing model. We'll also check on the greater scalability and less configuration and manual work from our end when we try to go for virtual machine scale set. In the computing, we also look at the Azure App Services, which is a offering from the platform as a servicing model, and also for the web application hosting. Also, we also look at Azure Functions. Again, it's a serverless computing model which we wanted to explore as part of this course. And also we will take a look at when we move to the networking specific, how the networking can connect to the Azure computing environment and virtual networks and load balancings and the multiple instances that runs the virtual machines and the app service plans. All that we will have a look on it. And also VPN gateways and how Azure virtual networks can connect to your on-premises servers, as well as the within the cloud, one VNet to another VNet peering. All that we will be having a look on it. Also, application gateway and how it is going to differ from a load balancing or load balancing servers. A traditional way, we can cover up that as part of the course content. And also our next lesson, we will also look at the storage. When it comes to the storage, we talk about Azure blob storage, file storage, and the differences of each of the storage types and the types of the storage, such as a hot and a cold. All that we would be discussing within the Azure storage. And next we will jump into the databases. Within the databases, again we would look at the traditional databases, SQL, Cosmos DB, and other innovative databases like NoSQL database. All that with multiple APIs, how they are gonna interact with NoSQL database. Such things we would have a look on it. And also we will can take a look at database migration services and how it can help us to move data from on-premises database servers to Azure database or between Azure database servers. And finally, we will take a look at data warehouse, which gives us a relationship database model with with which to work with a big data analysis or analytics side. And also in final lesson, we will take a look at Azure Marketplace, which has the thousands of different software components, or like virtual machine images, or maybe software as a service offerings, or various different application components and APIs that are available, things like that, which is available for us to readily use it. So we can have a look on that as your marketplace. I hope this makes easy for you in the upcoming lectures. Thank you for watching this. I'll catch you in the next lecture. Hello and welcome back. In this lesson, we will be looking at computing products. When I say computing products, you can see here we have all these options starting from the virtual machines, which the pyramid, if you can see here, the base is as model, that is infrastructure as a service model. So when it goes down, you would be ending with the platform as a service model. So let's have a look on it. What are the products that are at this point of time in Microsoft Azure that can fit and where it is fitting. So if you see here virtual machines, they are you have the more control on that. So it falls into the infrastructure as a service, as you know. So when you say VM, if you're quite completely new, a VM is on a physical machine you create as an isolated layer of machine to utilize the existing hardware resources, and that's called the virtual machine. And the similar thing, you can also create the things like VMs within the Microsoft Azure. So in this case, VMs is the first layer, and also you have other one as the virtual machine scale set. So the similar VMs will be duplicated things will be available for you. So in case if the workload is not able to handle by one machine, you have thousands of machines or hundreds of machines can be serve the end user's request. Now this new thing has been added here, is a called containers. If you can think about a container is a microservice layer where like a fabric, a service fabric specific like Dockers and Kubernetes, all that comes into the container. So it's a microservices. And you also have app servicing. So this is where the applications and other things can be hosted under computing. And also you have the functions, or FAAS or fast. The functions as a service also can be used, which just needs a logic and an event-based driven application. So we're going to look on it in a minute, and this will have all these different technologies that would trigger the functions and other things. So this is finally ending with the platform as a service model. Now let me show you, what I'm trying to talk. If I just go to Microsoft Azure portal, and for all services, if I just go to all services and under computing, you have here 32 as in date of this recording, 2020 January. You have here 32 different services. Some of them are in a preview, like SAP HANA is one of the major thing. They wanted to bring SAP HANA to Microsoft Azure platform. So that's still in a preview mode, and such things are completely part of Microsoft Computing Services and products. So within this, we talked about the virtual machines. This is where you can create virtual machines, and you have the virtual machine as a classic model. So when we say about the classic model, we don't have ARM or Azure Resource Manager. If you remember the ARM or ARM model, so that is not there with the classic model. So it's a ASM model or servicing model. That's a completely different, but nobody is using now ASM model. Everybody is migrated to Azure Resource Manager model, that is ARM model. So you can check out here what are the virtual machines you can create here and such things. So for all of these things, you do have a proper planning of what kind of workload you wanted to migrate. Let's say you wanted to start with, you want to migrate an existing application, then you goes to this left side workflow. Otherwise, if you're trying to build a new one, you just try to fit where actually your applications can fit. Let's drive as a new application, like your application whatever you're trying to deploy, do you need a full control on that? In that situation, it goes to the virtual machines, like say data and everything for the financial institutes or such things, like a lot of complexity for configuration and installation. Then it goes to the virtual machines. If not, if it is high performance computing, when we say high performance computing, you wanted to run as a batch of that workload, then you need to end up with the Azure batch as the one of the service. If the applications are wanted as app service model, you can go for the micro architecture model. If not, you want to have a kind of event driven completely workloads, then you can just pay for only Azure functions, so that you're no need to have any servers or serverless technology. When we say serverless technology, don't get into confused state. There will be a server, but the server is not managed by us. So the server will be available from the Microsoft server, but what we do is when that specific event triggers, it's gonna, for example, you order an order and that mail has to be triggered. So when an event triggers as the purchase has been completed, you need to send an order confirmation email to the consumer, so that drives a event model. So during that milliseconds of time or a second of time, you're going to use the functions, so you would be paying for only that second time, so you're not paying for the entire infrastructure. Whereas in the virtual machines, you need to pay for the virtual machine complete cost of that processing and the memory, everything, including as a consolidated. But here with the functions, you are actually paying for only the event driven based. And if you're looking for a full-fledged orchestration, then it would actually goes to the container services. And if you're looking for some kind of fabric model or the container-based like Kubernetes, other things comes into a different technology altogether, like .NET integration, other part. So now this is for the new applications, if at all we are trying to develop. Now let's have a look on it. If we have already an existing application, can that be migrated as it is, or can we convert that and fit it into Microsoft Azure, one of the product services, into the computing environment? To check with that, like if you are trying to build or migrate an application which is as it is to migrate to the cloud, that means there is no changes required to that specific workload. That's called lift and shift. So if it is already cloud optimized, you can directly lift and shift. The workload type would be the cloud optimized. If you're trying to do the cloud optimize the existing workload, you may have to consider HPC or high performance computing workload for the Azure batch mechanism. So batches, as we discussed, it's a multiple, the code will be executed on multiple computers, so that way you get the supercomputer power altogether. Now let's have a look on a lift and shift. This can be containerized. If that's the case, you can look for AKS or Azure Kubernetes services or app servicing model. That's what we have looked into here, like the microservices model. If not, you may have to consider for the app services or for the virtual machine model. So you might have understood by this time. This flow will give you a good idea how existing resources or existing applications can be converted, or when you're trying to design what kind of workload it's going to be end up with, and based on that you can design it. Let's have a look on in the Azure console. You have this here, the Microsoft virtual machine. If you're trying to create a Microsoft virtual machine, it would ask you for a specific operating system and the image that you wanted to install. Let's say you want Ubuntu or Red Hat or Windows Server operating system, or for that matter maybe Windows 10 Professional. And this is where the hardware size, which talks about every operating system or every virtual machine will have a sizing capacity. When we say sizing, it also talks about the cost, along with that how many CPUs it's going to have and how much RAM it will have and what is the performance of the disk operations. So based on these virtual CPUs and RAM and disk performance, this has been segregated into a sizing. So when we say sizing, sizing consists of 8 different models. Let's see, you have here D1, D13, different models. So if you look at any of these models, it is mostly it is optimized based on a category. If you see here, it's a general purpose. This is memory optimized. That means you'll have a more memory. And if you just scroll down, like GPU is more, that means it's going to cost more, even because it has a graphical performancing unit, that is a GPU you have within that NV model. So the VM sizes depends on the model of that VM that needs to be understood and the resources that we used, and every VM will be optimized for a specific type of workload. For example, here GPU and storage optimized here. You see here, that means the more IOPS you have here, 10,000, 8,000, that's huge IOPS. And at the same time, the RAM and memory is nothing but the RAM definitely, and the CPUs, all that would be optimized for the VM. So we would choose the required family of that specific product. Let's have a look on it. If I just go back to again to the all services, if I just go to all services and try to create virtual machine scale sets, so that means it same virtual machine is gonna have multiple machines in the background. Let's say you want a 2 instance count, or you want a close to 1000, any of the for example, I can give here as 100 VM scale. So that means the same VM will have close to 100 in the background. So if one goes down, other one would automatically takes up. So that's the power of cloud computing. Now let's have a look on about the pricing. So when you look at the computing pricing, when you go for a normal model called a pay-as-you-go model, which we normally discuss every time, like the performance of that, like there's no upfront cost, but you would be paying for the minutes that you are going to use. To long-term commitment or upfront commitment, there's nothing like that. So you just have to buy that specific service for some time, and then you would be terminating that VM or that specific service later point. But there's something called a reserved virtual machine instances, where you're going to save close to 72% of the saving when compared with the pay-as-you-go model. The main advantages for this would be applications with the steady state, and the customers who want at a budget predictability, and customers who are committed for that VM for a longer term. So that's called the reserved VMs. Again, in the reserved VMs also you have here 3 years and 1 year model. So when you go for the 3 years, it would be very less cost. If you see here, BS1 model with the 1 gig of RAM, which is costing you close to $0.00, 0.004, that means it's a very less, but whereas here it's costing 6. So 2 cents are costing higher comparatively. And if you go to this again, 2 more percentage has been increased. So when it comes to the spot instances, sometimes the spot instances will be available for you with a discount of 90%. When we say spot pricing or spot instance, that kind of VMs are freely available from the Microsoft data center. So instead of they lying as a free, you can run some kind of batch job and come out of that spot pricing or spot scale set of that VM. So that way you would be maximizing your savings, at the same time you are actually doing your work. So this is very much useful for the customers who want to significantly lower their cost and interruptible application. It doesn't matter that if that specific application got interrupted, it can wait for a notice period of 30 seconds and in advance before the application is affected. And that situations, you would go for this, and you would be saving close to 90% of the cost when we look at the costing model. So these are the things coming to the pricing for the computing, and you can go for the calculator. The calculator would give you a good idea in dollars how it's going to be like. You wanted to spin up this VM maybe in South Asia or maybe in US or Norway or whatever the region, and based on that the operating system you would be choosing and the instance. So this is where it says that per hour it's going to be cost you just the 2 cents. Think about it, it's just the 1 GB or 9 GB of the RAM. It's not even 9 cents, which is very low in terms of cost. So this is 18 cents. So think about virtual computers are so cheaper when compared with our on-premises. Let's move to the virtual machine scale set. So within the scale sets, let's say you don't want to do a lot of customizations and maintenance work, that things like that, but you wanted to make the machine to be workload to go down, or instead of going down, instead of that, if you just go for the virtual machine scale sets, what would happen is a pool of it's a pool of set of virtual machines that it automatically scales based on your traffic coming into your virtual machines, and then by auto scaling it does it in the both directions for the up and down. When we needed more servers, it just creates multiple virtual machines close to 1000 as the maximum limit where you can go for the machine. So it's auto scaling is possible for automatically create or spin up some more virtual machines for that workload, so that your users doesn't know that they don't experience any kind of latency or maybe a workload becoming slow. So for them, every time the machine would perform as they wanted with that high availability and that good performance, they would get it. So let's have a look on the basically the difference between when you look at the manually. If you want to scale up, it takes a lot of time to do it, manual process. Instead of that, a virtual machine skill sets will create from a single central place, so that it has the same image or same disk it will have, and it would just simply clone that image for spinning up another machine. So that way it would automatically create and integrates with your load balancing and your application gateways, so that it knows that what kind of workload is what kind of traffic is coming to these specific workloads, and that would actually helps to spin up or down the set of virtual machines. And then this is also comes into the infrastructure as a servicing model. Now let's have a look on it as your app services. If you just go to all services of Microsoft Azure and then you have the web, this is where the app services come into the picture. So like you have the app services. This is where you can create your own custom apps, which is a web-based applications, and then that can be scale up, scale down, all that can be done. So what exactly app service? The app service is a platform for us to build and host applications, which are the web-based application, mobile backend, and it will have the RESTful APIs and it gives us a lot of flexibility. Our applications can be in any programming language that we want. For example, if you can see here, this is a base. Either you want to choose as a Linux or Windows, you can choose based on that plan, and you have the app service plans also. And you see here you have the programming flexibility where you can choose any kind of programming as one of them, like .NET or Java or Python or Ruby. All these PHP, all these are possible to choose for your web-based applications. And this kind of flexibility gives us we don't need to have to manage any of the infrastructure whatever. So again, and these are the platforms as a service offering. We don't have to manage anything that's underlying these services. Instead, Azure manages it for us and offers auto scaling, high availability. We can support both Windows and Linux operating systems, which is really cool. And since we are hosting web applications, there's automated connectivity between various source codes and the repositories like GitHub, Azure DevOps, or maybe really any Git repositories. And for that matter, this app services gives as an on-demand auto-scaling web applications and the API hosting platform that runs on both Linux and Windows. The infrastructure as a service equivalent would be as setting up virtual machines and then setting up the web server, and wiring things like that would take a lot of time and money for us, and we would also have to worry about auto scaling. We would have to worry about load balancing, all kind of things like that with the infrastructure as a service. When we try to host anything on a virtual machine, this kind of web application, instead with the app service, we just have to upload our code to the app service, tell it is what kind of operating system we want to run our code, and what kind of app service that we wanted to handling, with what kind of language. And that's all. We can once we have configured that specific things, it can handle auto scaling or and everything for us automatically, and this makes us always up and running for us. And also for us, you have the options to run these services into the Docker container, so that you can choose what kind of Docker services you want as an operating system for Windows Docker or maybe a Linux Docker. All that also can be possible to do it directly from here. When we look at the containers, if you just go to the all services, you have the containers options. So this is where container services got depreciated, but you have the Kubernetes services here. And if you just go to the Kubernetes services, this is where you can create your Azure Kubernetes services. This is so easy that what kind of Kubernetes version you wanted, and you can go for the Kubernetes clusters within the Azure also. You have a look on it here, and when you just create, you have a plans and you have the scaling option, what kind of auto scaling or multiple scaling, all that possible options you have with the Kubernetes version, what version you wanted to deploy within the Microsoft Azure service as one of the Kubernetes cluster. And this is where you normally create the Kubernetes services. You have option to increase or decrease your node size and the number of counts, but if you increase more, it would actually throw an error as the node couldn't support. So you might make sure that your subscription is supported, all that to be verified and checked. Let's take one of the business case that or one of the business example when we use the Kubernetes or Docker services. Suppose you have a work for online clothing retailer, a company that is planning to deploy a handful of internal applications, but hasn't decided it how it's going to host them and what kind of hosting model you're going to choose it. But they are looking for maximum compatibility as a first option, and second one is the apps may be hosted on premises or maybe in Azure or any other cloud provider for that matter. But some of the applications might share infrastructure as a service model. In that cases, the company requires the apps isolated from each other. That means the apps can share the same hardware resources, but they don't want to be able to interfere with other files and memory and other resources that are used by other applications altogether. So the company values the efficiency of its resources and wants something with the compelling application development story. So then the Docker seems to be an ideal solution. What exactly Microsoft Azure Functions? Azure Functions is an event-triggered or event-driven or compute-on-demand experience that extends your existing Azure applications platform with compatibilities or capabilities to implement a code triggered by events occurring in Azure or third-party services, as well as on-premises systems. So it's not just limited to the Microsoft Azure. You can also extend this to happen on your on-premises systems too. And Azure Functions allows developers to take action by connecting to the data source or messaging solutions that's though making it easy to process and react to the events. Developers basically can leverage Azure Functions to build HTTP-based API endpoints accessibility by wide range of different applications, mobiles or IoT devices. Azure Function is a scale based on demand, so you would be paying for only the resources that you actually consume, or when it actually triggers the time it has taken, only for that only you would be paying for that. So let's jump into the pricing, and you can check out the pricing side. If I just go to the calculator here, within the calculator you have functions. Within the within the Azure Functions calculator, if I just open up this calculator, the first 400 terabytes of executions, as well as close to this is 1 million executions are free per month basis, and post to that you would be charged the first time. It's almost free for you. Post to that you may have to pay by based on the execution, like for example, if you go to the pricing, you would be knowing that what exactly it's going to charge. And for basically, this is basically used mostly for the IoT and other devices. So this is a kind of booming technology now on functions or serverless technology. So this is the charges page you can check out, which I'm going to attach this as one of the resources for this lecture. I hope this is useful for you. I will wrap up this lecture for now, and I'll see you in the next lecture. Thank you for watching this. Hello and welcome back. In this lecture, we will be learning about networking. There are almost close to 31 different networking components which are available within Microsoft Azure. If you go back to Microsoft Azure portal and go to all services here, in this you have the networking. So this is where a lot of other components are available. So let's say for anything to do is here, the first and core basics things we would start learning within this course. To begin with that, the first one would be the virtual network, which we are going to learn as a first. Just to begin with that, this is one more slide which I wanted to show you. Most of these things are very core if you're trying to learn, or if you're trying to work within the networking section. These are the core things that might you need to work on them. It's not mandatory that you're going to work on all these things, but at least on these things you would be touching up, either in this course or the next higher courses. And coming back to the designing the things to explain, sometimes we also call this virtual network, or sometimes we also call as the VNet. So whatever you have, you're able to see here virtual network, it is represented with these icons. So with this icon, it is representing as a virtual network. So this virtual network sometimes we also call as the VNet. So you see here in this diagram, the dots are mentioned, and somewhere here the icon is there. So this is the virtual network. Similarly, here also you can see here one more VNet is there. So let's talk on more about VNet now. Adding or creating any of the virtual networks like this is a really network within your Azure stack or within your Azure that allows us to have resources can be placed within this network or VNet or virtual network, and they can communicate with each other, or you can set in a policies to restrict or permit those resources within the network from talking to other resources over the internet, or maybe within Azure. Let's see, here you have one VNet and one more VNet is here. So if we both wanted to communicate this VNet with this VNet, we can enable that. Or by default, from one VNet to another VNet will be disable the communication. You can do the VNet to VNet peering so that it can communicate within your Azure. It means that the way, or it's a way to isolate your resources within certain networks to open up or close off communication. We can even have a communication between Azure virtual network to another virtual network, or we can open the communication to happen to our on-premises servers or to our network with the help of VPN. So when I say VPN, it's a virtual private network. Or we can open up within the VNet to public, that's the internet. So all the possible options you have within the virtual networks or VNets. So every VNet will have some of the subnets. So that's the another layer of within your VNet. So let me show you in the portal. I'm in networking with all services. I can go back to virtual networks. Here I can create one of the VNet. For example, this has been already created and has its subnets. So one of the subnet is there, which is a default subnet with the 10 series. So let's go back and create a subnet for us. So I'm just within the virtual networks. I can click on add. So that would actually gives me this information. So this is where I need to create. So I'm just giving this is for demo example, demo for AZ-900 example. So this is the subnet which is going to creating for me within this VNet. So the VNet is this. I'm going to create here a new resource group like AZ-900, and within this I can have one subnet, and this will automatically prevent my DDoS protection in case if anything is trying to perform. If you want standard plans, you can go for the standard plans. That would again a different plan and it would charge a little bit, but let's create that. The deployment is submitted and it's going to take a minute or so to complete this. So once I've done, I should be able to see here my new deployment which I just did as one of the VNet. Now this deployment is completed successfully. If I just refresh, I should be able to see here. So within this demo AZ-900 series, this is the first thing what you would be doing in Microsoft Azure. As a first step, you always will be creating your networking. Post to that, you would add your resources and you would protect it with your network security groups, and other things will come into the picture. So the first thing itself to do anything in the Microsoft Azure, it would be mostly networking, because that's your identity, that's where your resources will be putting into it. So here within the Azure, now you have the subnet. One of the subnet has been already created by default, which is 10 series. You see here 10.1 class 24. You can create one more subnet if you want, so which is going to be subnet 2 example. So you see here this is another subnet which is going to create for me. So it's not allowing me to create another numbers. The name must not have a space or like numbers, such things. So it should have only the name, not the number. So that's okay. So I'm gonna actually create here. So and also while creating, you would be able to get it if you have any of the network security groups, because we don't have anything in the network security group, which is network security group is a firewall thing, that it's a firewall for this network or for that specific subnet, which we have not yet talked. So for this entire virtual network, there's a firewall. So that firewall here, it will be placed, that's called network security group, so which we have not yet discussed at this point of time. So ignore that, and you can choose whatever the things you want to do here for the services, all those things. But let's just click OK, accept the defaults. That's going to create for us adding one more subnet. So what happened now is, let me explain the same thing with the animation. What we have done so far is we just created one big network, or maybe take it as a one VNet. So that's the icon, that's a VNet what we have created. And then what we have done is here we created one big subnet. So within this subnet, we gave the subnet ID as 10.1 with class C subnet, and we also added some of the VMs or maybe web application, whatever the resources you wanted to put it, you can put it there. So that's where the networking is very important, and the first point always would comes into the networking. And then one more subnet we created, and we place all the servers. So that concludes how we created a VNet and how it looks like as a presentation side. Also, you need to remember with the Azure virtual networks, we have the ability to control the traffic flow by using predefined routes and other tools like that. Let's talk about VPN gateways. Now, within the VPN gateway, VPN stands for here Virtual Private Network. Like many of the folks, they connect from home to office or from airport when they wanted to work to office, they try to connect with a service called VPN service. So that's similar technology what we are talking about, and same thing what we talk about here. But to talk more about by technically practically what exactly how it looks like, so if I go back to my all services within Microsoft Azure portal, once I logged in, I should be able to see here a networking. Under that you have an option for, we are currently talking about virtual network gateways, right? So VPN. So you just click on that virtual network gateways and it's going to talk about to create some gateway. So what would happen is technically in the back end, this actually creates some of the virtual machines, but you don't have those access for the virtual machines, technically speaking, because this is fully isolated in the Microsoft Azure. In the backend you can't see what would happen when you create a virtual network gateway. It's going to create a couple of VMs, and whatever the settings you're going to put it as an input, that's going to configure within that VM, and that would allow you to communicate with your on-premises site or maybe within other virtual networks within your Azure services. So just to speaking that, if I just click on add, it's going to ask me some of the input. So these are the inputs are required to create in the back end, not in front. You can't see those VMs how they are going to create it for us. So all we have is we have a service will be visible once it is created, but in the background it's going to create a VPNs, and that VPN name I can give here, like this can be my site to site to my Delhi VPN. So it's going to talk about I can give this kind of naming standard. So it's going to accept that naming standard. We must have to follow those naming standard. Now, once we have given site to site to Delhi VPN on premises, this is my on premises. Then what I'm going to do is I need to choose a right region. If I start using a wrong region, what would happen is you won't get it here. The VNets is not going to show you here. See, you don't have a VNet because my VNets were created in West US, if I'm correct. US2. So now I should be able to see here my demo AZ-900 VM or VNet, which we have just created in the as part of this demo. So here what it's going to do is it's going to create one more subnet. Within that it's going to place this specific service. And now the most important point here within this would be, let me show you within the PPT. So within this PPT we talked about now so far only for virtual networks, but we didn't talk about many things here, but we just started a VPN gateway. When we are trying to create here VPN gateway, you also you will be getting an option to connect express route option also. Let me show you that what I'm trying to talk here. So here within the Azure portal you have an option for express route. So what would happen is when we talk about express route, so Express Route is an additional service which would extend your on-premises networking into Microsoft Cloud over a private connection facilitated by a connectivity provider, would be mostly your ISPs. So you need to contact your ISPs for Express Route, and they would actually establish a dedicated connection from your on-premises data center to Microsoft Cloud service provider. So the communication, whatever it is going to happen, that's going to be purely private. It's not going to be on any of the public networks, so it's highly secure compared to any of the public network communication over the VPN. Now let's have a look on it. Actually, a normal standard VPN. So what would happen is with the standard VPN, it's going to communicate with your ISP's network, that is the public network, to your on-premises data center. Later point, you would be giving some of the IP information. Once you created here the virtual network gateways, it's going to actually ask us to asking for the IP address and the user ID and password, as well as the authentication key, all that with your on-premises data center. And later point, it's going to be establish the connection between your on-premises data center to Azure Cloud. So that's where the virtual network gateway come into the picture. So virtual network gateway is to make you more easy. It has a facility that whatever the servers or the network, actually you're extending your network of which is in Azure Cloud to your on-premises can be done with the help of virtual network gateway. Just to summarize this, the VPN gateways, we get the ability to connect Azure and non-Azure networks together securely and privately also possible. This is also sometimes we call it as the backend connectivity because it's gonna connect to our on-premises and other networks. That's a backend which is coming up. And if you start working on the front-end activities or front-end networking concepts, then it would be your load balancer. Such things comes into the picture. Let's take a minute to talk about ExpressRoute. So that would actually talks more about ExpressRoute. So you see here the diagram of ExpressRoute here. This is your on-premises customer network, and you have a partner edge. That means your ISPs providing a connectivity with a private connection that would actually establish with Microsoft data center. It can be your Azure cloud. So whatever the communication you want to establish, and that actually directly comes from the Microsoft data center. Let's say you have Office 365 subscription that actually coming from direct Microsoft service, not from the over the internet. So that's added advantage for you. And also you also have an option for peering with your networks. That's what we have said earlier in the virtual network gateway concept. So that's where it's going to peer with your VNets. In that demo, we talked about a demo VNet. In this case, so whatever the VNet you have, with that it can establish a connection. So this connection is going to be a purely on a express route, which is a private connectivity from your ISP to direct your Microsoft data center. So that way it gives you more value and more security in terms of extending your on-premises data center to cloud. Now let's have a look on about what exactly this express route. Express route lets you actually extend your on-premises network to Microsoft Cloud over a private connection facilitated by your ISPs. And you need to talk with ISP as well as you need to talk with ISP, and you have to raise a ticket and communicate with Microsoft to get it established, this express route, which takes a day or so. But once the cabling and other things are properly provided, it takes an easy way. Now express route also connects connections do not go over public internet. That means whatever we're talking about the public cloud all the time, it's not the case in that situation. The communication would go over a dedicated line which is provided by your ISP to connect with Microsoft data center. So it's more secure, it's highly secure in other way. That's what and also you get the more reliability and faster speed and consistent latency. As I said, higher security typical connections over the internet compared. And this communication would actually happens on a layer 3 connectivity. That means more secured and your on-premises network to your cloud. And also here, if you can look at here, all regions are supported, and you can you can make connectivity with all regions, geopolitical regions also. And global connectivity to Microsoft servers across the regions with ExpressRoute premium add-on that needs to be additional licensing. In a minute maybe we can have a licensing also to understand better. Dynamic routing is between your networks and Microsoft big IPs also possible, and built-in redundancy in every peering location for higher reliability. And connections SLA is more uptime, you get it actually, and QoS support for your Skype for Business. So all these are the additional benefits you get it when you go for the express route. Let's have a look on pricing front for application gateway, virtual networks, and express route for now. This is our Azure pricing calculator. Everything is plain. When you go for it, it will show you. I'm just adding here virtual networks, and also I'm adding here VPN gateway and express route. Now let's click on view to see all the components that we have added so far. So normally you don't get a charge for the virtual networks unless if the traffic is going out outbound and transfer and the inbound transfer rate across Zone 1, Zone 2, or Zone 3. Otherwise, it's not going to charge for you. So by creating VNet doesn't charge you. You can create up to 50 virtual networks automatically. Nobody stops you to have. But when the traffic goes higher and higher, you might have to pay based on the cost on the data transfer. Let's have a look on it here, pricing details. If I just click on it, so it's going to take to the specific to the VNet pricing. You see here, it's going to charge 0.01 cents per GB for inbound and outbound. So it's going to charge when VNet peering. VNet peering is like within your one VNet to another VNet can be peered, so that both the virtual machines in or both the services or both the servers or both the applications in each of these VNets can communicate. So by default it doesn't communicate. So to enable that communication, you need to do the VNet peering. So that's called VNet peering. So for that also you're going to pay for it. VPN gateways. So all these are the payment options you can check out here, like a Zone 1, Zone 2, Zone 3, Zone 4. Let's put the values meaningfully, like within the same region, you're not going to charge anything. It's almost close to $2 for 100 GB of the data. But if the region is changed, data might, charges might vary because of the pricing. But if you choose here the type of across regions, it's going to charge almost 10 times or close to, you have the inbound and outbound traffic. So across the different regions, you're going to charge almost for 100 GB copying $12. So that's the important for virtual network pricing side. Coming back to the VPN gateways. So here you have the ties, different ties are available. So if I just click on the pricing details, that will show me the different VPN types and the maximum bandwidth that I get it with each of this gateway type. So make sure that if you're looking for more bandwidth piped or pipeline, then you might have to go for higher bandwidth, but that again includes the more tunneling cost, because it's gonna give you almost maximum 10 different site-to-site tunnels, and the speed would increase to 10 Gbps. So you need to consider these based on the speeds and other things, and that way it's going to charge. Again, this is where also outbound zones like Zone 1, Zone 2, Zone 3, you might have to cost additionally. Here with the VPN gateways cost within the availability zones, when you configure or when you put your VPN gateways in a different availability zones, that's going to charge additional cost for that. So you can check out what are the region 1 and region 2 or the Zone 1, Zone 2, Zone 3. Here you have, these are the standard zones what Microsoft says. So except CDN following are the Zone 1 and Zone 2. So let's put here from my East US to a basic VPN which I wanted, for example, and then I can go for my inter VPN or just the VPN. So I can choose here the inter VPN is within your VNet to VNet, but this is a VPN additional one, so it's going to charge for us almost close to $0. But when the data hours we increase here, it's going to charge. For example, I'm going to use maybe 50 hours of my VPN gateway per month. So let's see, it's a costing as 1.80, so less when compared. But as you move here the ties, it's going to cost you a lot. You see here it's going to be the same price has been close to 200 times it's increased. Now coming back to the Azure Express route, which is very costly, and when you go for the premium add-on, it would be more again costly compared with the normal Express route. So have a look on pricing details. When you click on the pricing details, you will have the better understanding of almost all possible configurations with the pricing will be given here. In this you can check out here a meter data plan. So that means it's going to be meter how much per month you're going to price for the 50 Mbps as a $55, and the premium price would be if you enable that add-on, it's going to be $130, and the inbound data would be unlimited, and outbound is not applicable here because the data is out would be in a charge for us. Anything comes to Microsoft inside data centers, which is almost free in most of the Azure services, but when it goes out they start charging you. So these are the pricing side. You can go for premium circuit, which gives the higher uptime and uh, higher latencies. You don't expect the much latencies there. So such things would be possible here. So let's have a look on it and just configure here. It's going to be a meter or unlimited plan. So unlimited is going to charge here $375 if you're choosing with a premium add-on with a 50 Mbps line. And if you increase that line, it's going to charge you more per month basis. And also for all these services, when you're actually calculating, you must have to choose here whether what kind of support you wanted. If you don't need any support, that's fine. But if you are looking for some support like standard support or professional support, that means the people who's gonna support you from direct Microsoft would be supported you with their plans. So if you don't have any of the technical support team, you can go for this. Let's have a look on load balancing options. So when we say load balancing, it's not just the NLB, you also have other services which are coming from Microsoft Azure. So let's have a look on what are those other services which can help us in terms of the load sharing or load balancing. We can say that load balancing refers to an efficiently distributing your load or incoming network traffic across a group of backend resources or maybe a service. So these load balancing aims to optimize your resources use, maximize through output, and minimize your response time, and to avoid any overloading kind of issues on a single resource that can be avoided or can be eliminated by using the load balancing techniques or the services. It can also improve availability by sharing and workload across redundant computing resources. Let's have a look on it. What are those types or what are the options you have? So actually this load balancing can set at a global level. One is and other one would be the regional level. So when we say the global, it means that anything, if you want to do a load balancing services to distribute traffic across regional backends or clouds or hybrid on your premises. So in that situation, these services route end users traffic to the closest available backend. That's where the global traffic comes into the picture, and or the global services you can refer another way. So it can be HTTP or HTTPS services. They also react to the change in the service ability, performance, or alter to maximize availability and performance. So you can think of them as a systems that load balance between application stamps and endpoints and scale out hosts across the different regions and geographies. So let's have a look on it. What are those? For example, you can use here Azure Front Door HTTPS is one of the technology that can be used. Other one would be the again Traffic Manager. So either Traffic Manager or Azure Front Door. These are the things that can that can send the traffic, whatever it is coming globally, to the closest one. But both works for a different purpose. So let's have a look on it. What exactly the Azure Front Door? A front door is an application delivery network that basically provides a global load balancing. As I said, we are looking into the global, so anything is a global load balancing. We are going to talk about these two. So Azure Front Door, what it does is actually it accelerates services for web applications by working at the layer 7 capabilities. And your applications like SSL offload or path-based routing or fast failover or caching, all these mechanisms can be used within the Azure Front Door, and that would actually improve performance and high availability of your applications. Now it's time for checking for the Traffic Manager. So the Traffic Manager is mostly widely used one, which is a DNS-based traffic load balancer that enables you to distribute your traffic optimally to the services across the global regions. As I said, that's why it falls the global. That's why we divided one services as a global, other one is the regional. So what it does is actually it provides high availability and responsiveness because Traffic Manager is a DNS-based load balancing services. it loads it actually load balances only at the domain level, not for the other HTTP or other things. So it actually looks at the domain level. That means if you're talking about any changes to the domain, that might take some time in order to caching or systems to be updated. So make sure that when you work with the traffic manager, make sure that the proper DNS names and other things are already up to date. Otherwise it might take and it might not work properly. Now let's jump into the regional one. So the regional one comes into the picture with the application gateway. Either you can use these applications gateway like application delivery center, in short we also call it as ADC, as a service, which is going to offer again layer 7 based load balancing capabilities to optimize your web form, and by productivity offering or offloading your CPU or intensive SSL termination on the gateway layer. So this can work HTTP and HTTPS also. Now other one would be the under regional, it would be Azure load balancer, which is normally we use it. So it acts for your TCP and UDP based on the layer 4 load balancing can happen. So it can be geo-redundant, or it can be high availability across your availability zones by putting into the front end of this, and it can also work as a natting also can be enabled within the load balancing. So what it does is it is a front end. Let's say let's take this itself, one of the services. If you think that if you place here as a load balancer, so what it does is it can route either to this region or to this region or to this availability zone or to this availability zone based on the request which is coming up. And it also can work as a round robin. That means first user goes to user 1, second user goes to user 3, third user goes to user third. That means every input which is coming will be properly shared so that your services will be used properly, and you'll not get overloaded any point of time. And you can configure all these kind of things within the load balancing options. So what we have with the Azure load balancing services, we have close to 4 different options. So when it comes to the decision, you can check out when we are going to use what kind of options. So let's see, you are actually trying to develop or use an application called web application with the HTTP or HTTP. In that situation, is this application is gonna is a web application? If that's the case, it's actually going to here if it is an internet facing application. If it is non-internet facing application, then it can go here, and that's where you can think about it. Do you want to directly place the load balancer to route the traffic, either TCP or UDP based or port based mechanism, or if it is actually facing internet facing, then do you want a global deployment in a multiple region? If that's the case, you need to know combination of products to be used. Here if you can see traffic manager with the load balancer, because if you remember traffic manager would works into the global, so that's where it's actually working. So you can put as the traffic manager in front as well as the load balancer. So now when it comes to if it's an internet facing application, and you can simply go for, if it is not internet facing, you can simply go for the application gateway model also, which we talked about here, because it just works on HTTP or HTTPS within the region if it is not on the non-region one. Now if it is a global one, definitely global, when we say global, either any of these should be used. So if it is a global deployment in multiple regions, since we are talking about the multiple, if that's the case, yes, then do you require SSL? So if you see here SSL, so you have the front door, so that's where it says that if it is SSL, go to the front door with a combination of application gateway, because application gateway does that kind of routing within the regions. Now if it is no SSL, then you can host as a platform as a service or infrastructure as a service or Kubernetes services based on any of that, and any of that model, and you can provision within that with the help of Azure Front Door, or here AKS. If that's the case AKS, then you would be ending up with two different tools like Front Door as well as the application gateway integration. And now if it is an infrastructure as a service, as a VM, in that situation you can just go for a VM with along with that Front Door and also the load balancer as a combination. Now do you if you're just looking for the non-global, that means we are coming to the regional. So let's see if it is a no. Did you require a performance acceleration? If no, then simple application gateway would help us. So if you see, most of the places we are actually setting the application gateway, because that's where the application gateway knows much about how the application controlling as a service, which is running on the layer 7 capabilities. So let's take about that specific role. If you see here, this is the application gateway layer. What would happen is actually your browser, when you're actually hitting to one of the gateway IP, front-end IP, that actually goes whether HTTP or HTTPS listener, here it's going to design or verify the rules whether this is going to be where it should go in the backend pool. So that's how it's going to work. Similarly, you can also set another when we use more of the products with along with the application gateway, you see here you have the WAF also here included, which is a firewall based firewall for the application layer, web application firewall. We call it as in a short WAF, which is a service provider for centralized protection of your web application from common exploits or vulnerabilities. So let's understand this specific design. If you can see here, you're trying to open up the console.com, so the traffic is going to application gateway. So what would happen is it's going to actually securing here with the SSL TLS termination policies, and it can also set your auto scaling whatever the pool, because we are talking about the pools here, and it can also be zone redundant. It will have a static virtual IP. All these features built in within the application layer or application gateway, so that would actually helps us to route traffic properly. That's why you can check out here it's more about the regional, and it falls into the load balancing services for the regional wing. But either way, this would actually covers all the possible options within the load balancing services within Microsoft Azure Cloud as in January 2020, these services. Let's have a look on it, how best we can create these things at the higher level, or what are the inputs when we try to create. So all you have to do is go to all services within the Azure and go to networking, and you have all these 31 as in date, the services into the networking. So what would we do is we would go to the load balancing. If I just click on the load balancing, this is where you're going to create the normal load balancer. So it actually needs the front end and the back end of the services. Or when you create, even if you're trying to create for a virtual machine, when you try to create it for a single VM, also we can talk about for example, let me show you here. If I try to create here VM, it will also prompt me to put it into the load balancing information in the networking tab. So you have here the option. So when you configure here for the load balancing as yes, it's going to place the solution into the behind the load balancing in the backend, and that would actually create while you're creating the VM itself. And let's go back to the normal load balancer of what we are trying to do here, and this is where it's going to ask for the resource name as we talked, everything under subscription. You have the resource manager as a container, that's where all these specific services will be placed into that. And now you can give the load balancer name, all that information. Once you are okay, the public IP information, you can choose here choose the one of the public IP information used or existing, any of this public IP. That's gonna actually should be a free one when you're trying to creating a new public IP, and then the load balancer will be available, and then you are gonna assign this load balancer to attach to one of your VM. That's how you're gonna do it. If not the VM, you will be attaching to other services wherever it is applicable for your load balancing options. Now let's jump into the all services and have a look on traffic manager profile. This is where it's going to ask for the traffic manager, how you want to configure this traffic manager. So let's create one of the rule to have our traffic manager to be created. So this is actually creating a traffic manager.net with a name. For example, here if I give my name as Paddy Maddy, so it's going to actually ask me to choose one of the performance based or weight based or priority based. So these are the metrics or routing methods which would be used on all these options. Let's say when you use these options like weight based, means it's going to actually go and checks for the how much load is actually applicable on that specific machine, and based on that it's going to route it. Same as for the geographic. So if it is if the users are directed to your specific endpoints like a Azure external or maybe a nested, then it's going to be a which geographical location their DNS queries to their originates from. This imposes actually traffic manager customers to enable scenarios where unknowing a user geographic region and routing them to a based on that. It's important. For example, examples including compiling and data and mandates, localization and content of user experience, and measuring traffic from different regions. Let's say you try to open google.com, sometimes it just goes to google.co.in or maybe to your localized website. That all happens with the help of traffic manager, because it analyzes and it sends that services to be offered to the localized altogether. So that's a kind of traffic manager. This is how you're going to create. And let's go back to other services. Under all Within this all services, you have here a CDN option. So let's talk about the CDN a bit more. So CDN stands for Content Delivery Network. So Azure Content Delivery Network is a global CDN solution for delivering high bandwidth content. It can be hosted in Azure or any other location. With Azure CDN, you can cache static objects loads from Azure Blob storage and web applications or any public accessible web server by using the closest point of presence, that is a POP we call it. So it's not a POP service, but it's a POP server, so that's called point of presence server. So that's the Azure CDN can also accelerate your dynamic content, which cannot be cached by leveraging various different network and routing optimization solutions. So CDN, when you try to do CDN, it's mostly used for the web servers, web content or video content, so that it will be available in that point of corner from where the user is coming. So user never feels that there is a latency when he's trying to browse that web application, or when he's trying to browse that or watch that specific lengthy video. So to make that cached, so Azure will take care of that kind of profile or that kind of job by creating Azure CDN profiles. So when you click on create profile, so this is where it's going to ask for that, and you need to choose the all available pricing models. It's premium or whatever the model, standard Microsoft or standard Verizon. All these are the vendor specific, but they are gonna, because these people have the content delivery servers throughout the globe. So it's gonna choose based on the pricing model. You can choose like I go for Microsoft. In that case, it's gonna creating a CDN for you, and you can choose what kind of a CDN. It's going to be a web or custom version or cloud services or storage specific. Let's say you have a blob storage that want to be available as a content delivery network. So your users, when they're trying to browse within that blob, it's gonna available for them all the time and a cached. So the nearest point they can pull up. For example, if I'm in India and I'm trying to download or trying to access a file which is a bigger file or a larger file, then I would put it into CDN. So what happens is when I try to browse if I'm from south, so it's gonna actually pulls from me, or it's gonna locates the content from South India, so that I can easily access that without much latency. So that's how it's gonna CDN work. Now let's jump into other services which are related to the networking again. Maybe you might be wondering that how actually routing tables works. So by default, routing tables, all the routes which is within your network, whatever the traffic is flowing between your Azure subnets to your virtual networks or maybe to your on-premises networks, Microsoft Azure automatically creates the required routings or routing paths automatically. In case if you are trying to customize that one of the routing path based on your own requirement, in that situation you may have to create your system route by creating the routing table from here, or like adding one of the routing table to one of your subnets within your resource. Like here I'm going to enable my virtual network gateway routing propagation, and then I can create for maybe virtual network, or maybe for internet, or maybe optional routes also can be configured based on my requirement, like maybe for the purpose of VNet peering, or maybe for virtual network gateway to route this specific subnet traffic to that specific VPN network gateway. Such things can be done with the help of custom routes. Hello and welcome back. In this lesson, we will be looking at storage products and services and how they can be used and how they are different from each other. Also, we will be looking at storage account and other things, how they can create at the high level. To begin with this, now we can see that within this cloud models, you have infrastructure as a service as well as the platform as a service model. So within the Microsoft, you have all these possible cloud storage options. When we say disk, file, blobs, and queues and tables, all these are the options you have. Let's have a look on the disks. So the disk type, when we use is, if we have a virtual machine, if we want to attach the hard disk, so definitely it would be a disk type of the storage we would be using. So that means the virtual machine's images will be used or stored for disk type of the storage. And there is a storage type also. We have a premium storage. When we say premium storage, it means that you have the space is coming from your SSDs. So as you know, solid state drives is the higher IOPS, that means input output operations per second, can be done in the SSDs. That means you're getting really higher performance compared with your normal disk. So that's where disk comes into the picture. Now when you compare with the files, the only difference is that Azure Files goes a little bit above disk. That means it's not only just for the scaling purpose, it can also store the files as well as the disks. So with Azure Disk, we really are limited towards to the virtual machines, and that's especially for the disk images. But with Azure Files, we could store disk images or any kind of file and folders that we wanted to store. We can store within the Azure Files. It's a full-scale system, and along with that, Azure File Storage supports SMB protocol, which is just a protocol to connect your files and like a share folders across your computers. And it gives you an REST API that can use to access our data in a programmatical way also. And that means the Azure Files is a really great option for any legacy applications that you wanted to lift and shift as it is to migrate to your cloud. It's a best option because it's very common for legacy applications to rely on writing things to file systems or file shares. Instead of using or having to update your applications as you move into the cloud to have it write everywhere or somewhere, you can have it to continue to write files and shares just to use Azure Files to make that file shares available in the cloud. We have disks and file shares which are coming from infrastructure as a service option, and these provides a kind of framework for very low level data operations like saving and mounting virtual machines and the disks, and implementing full file systems within Microsoft Azure cloud. Now we also have these three different platform as a service options, as well as we have storage blobs within this. This is called the storage blobs, and also tables and the queues. Now when we talk about the blobs, a blob is one of the more commonly used storage service, and this blob service or blob storage is mostly optimized for storing massive amount of unstructured data. For example, a text data, it can be, or binary data. So it's ideal for serving some kind of images or documents directly to a browser, or maybe storing files and distributed access, or streaming videos, audio files, or even storing files or data for backup and restore in case of disaster recovery or archiving purpose. Even storing data for analyzing by an on-premises or Azure hosted services, the blobs are the best suitable things. If you're a developer, you know that you wanted to store some files as the input output mechanism. That means a JSON file kind of programmatical structures also can be stored in your blobs. That might be a text file, that might be aggregated reports from other systems. So that's where you would be choosing blob as one of the type that you wanted to store. Whatever your data is, you can store in your Azure blobs. That's what we can as a conclude for a blob. But this is different from database when you compare with the database, because in a database you can do a search against to your databases. Since we can't do a search because it's a completely unstructured data against to the blob, you can't do. That's why it's different. You can't compare a blob with its storage. Blob storage with SQL database storage. That's what I wanted to convey here. And it's better for other types of data other than the database, and that's really good at is storing, for example, metadata, images, PDF files that we just talked about in a minute or so. If you want a little bit more granular control over your data that you wanted to serving, will move into Azure Tables. Basically, because the Azure Tables, you can go for a structure kind of thing, a little bit of structure. Why I'm saying is a little bit of structure, because it's a little bit more granular. You have the control over your data that you are saving, and you can move it into Azure Tables. And this is within NoSQL database, and actually more closely resembles a real database than your Azure blobs. Let's have a look on it. If you see in this slide, we have a table. The table is a normal row kind of thing where you can actually kind of in a query can be, you can do a kind of in a query, but it's very similar to your relational database in the backend, but it uses a different type of technology, and it's called NoSQL, which represents non-relational database. And with Azure Tables, because of this different way of handling data versus how you do it in your SQL database would do it, we get a massive auto scaling capabilities within Azure Tables, because we can query for a larger number of data, whatever it is coming out of in a non-structured data. For example, if I take it up a Twitter feeds, which comes as a non-structural, so if something happens in the event, we don't know where to put it in a SQL database, because for a SQL, again, you need to have some of the columns in a proper way, because it's a structure way we call it. But here with a no structure, it doesn't matter what kind of a structure it is coming. We simply put it there, and we can query any point of time from the Azure Tables. That's where Azure Tables with the new NoSQL database. So that means there's no relationship for the data which is coming, so it can be easily analysis, and it's massively dynamically you can scale up based on the load, and you don't have to worry with any of these files solutions about managing servers or auto scaling of any of that. It's all handled by Microsoft from the Azure side, and our data is always available as quickly as possible to us. Now with Azure Tables, we can also support for petabytes of data, and petabytes in a layer about a layer above also, altogether like a terabytes, so that you can think of this in terms of scaling of thousands of terabytes of data or millions of gigabytes of data. There's a lot of room to grow within Azure Table. Just to again conclude with the Azure Tables, we get more structured data to save our data. And with the blobs, we could have only unstructured data. We could have some images, some PDF files, or some text files. All different sort of things can be stored into the blobs. But with the tables, there's a little bit more structured data can be stored. We define some columns. It gives us an ability to query our data. Unlike blobs, we can actually query any of the columns inside of your storage tables. With the capacity act, it does really act more like a database than your blob storage. Now, finally, we have Azure queries to be discussed. So let's talk into the queries. So queries is the first time out as a FIFO kind of product. To understand about Azure Queues, actually it provides a cloud messaging between your applications and components. In designing applications for scale, application components are often decoupled so that they can scale independently. Azure Queue Storage delivers asynchronous messaging for communication between your application components, whether they are using in cloud or on the desktop or on your on-premises server or maybe on your mobile devices. Queue Storages also supports a similar flow. For example, anything to do with your storage here, whatever we talk about in Microsoft Azure Cloud, you take as a storage that actually stores something called an account. So every storage is related and it will be on top or inside in a storage account. So let's take, you have a big computer normally and you have all the hard disk. So if you ask where's your data is stored, you will say that I have it in my hard disk, which is in this machine. Similarly, whatever the things are you're trying to store, that all goes under a storage account. So the storage account will have different types. For example, here disks, files, blobs, tables, queues, all that are possible with the storage account. Let me show you what I'm trying to talk. So this is one of my storage account which was created. I'm going to show you in a minute or so, or maybe in upcoming videos. But if you see here, this is my storage account. Inside this you have the under containers. A container is like a folder kind of thing, which is you can create. Inside that you will be storing VHD files maybe, and that's where blobs will comes into the picture. And this is the SMB services or file services which we just talked about it. And we also talked about the tables, like in the tables you can create a demo or AZ-900 table and just give it to your developers, and they would actually feed the tables in a right way. And let's also talk about other one, which is we are talking about. The last one is a queues. So when we talk about the queues, actually you would be talking about to store the queue services. Let's take an example. Before we jump into example, let's understand this process flow. So everything is related or inside your storage account. That's you got it, and inside that you have disks, files, blobs, tables, queues. So now we are talking about the queues. So within the queues, what it's going to do is it's actually can be used to store and retrieve messages, and the queues messages can be up to 64 KB in size maximum, and a queue can contain millions of messages. It's not one or two. It can have you can have millions of messages. Queues are generally used to store list of messages to be processed asynchronously. That means let's take an example. Let's say you want your customers to be able to upload pictures and you wanted to create thumbnails for each picture. You could have your customer wait for you to create thumbnails while uploading the pictures. And the alternative would be to use a queue, because when a customer finishes their upload, write a message to the queue in a programmatical way and say that, hey, now we have an Azure function retrieves that message and says that, hey, queue is now created and create a thumbnail within this. So now what would happen is each of the parts of the processing can be scaled separately. That gives you more control when it is actually tuning your users. So here, for example, the same thing, like you ordered maybe a customer orders something in his restaurant, and or maybe he's getting some thing that must be on top of it to be printed a label. In that situation, whatever the first comes, it goes to the queues, and then it would printed that label one by one in a right order, and you would be getting that messages can be printed with such kind of numbering, which as a label. So queues are very useful when it comes to the developers, because developers use mostly on the queues, and the when I say developer, DevOps guys definitely use the queues. That's where it's going to used in cloud. That concludes the queues. Now we'll just jump into the storage types. So what exactly the storage types and type of the storage types what you have. So now with the storage type, that means you're paying some kind of premium if you use those types. So you have hot type, cold type, and archive type. That means when you're trying to access, actually the storage tile means when you try to access your tile, which will allow you to store in your blob, or maybe in your data, whatever you're trying to store in the blob. So you can choose a cost effective manner. It's not that you just dump it as it is, because you will get more benefited when you actually store in a right way. So that's where you have the hot tile and the cool tile and archive. So what it means actually, hot tile means, let's understand hot tile. Hot tile means it is basically optimized for storing data that is accessed very frequently. So you uploaded the data and you would be retrieving from the blob all the time, very frequently. In that situation, we would consider as hot tile, so that it's not going to charge much. But let's say you have a cold tile. That means optimized for storing data in a frequently accessed and stored for at least 30 days. That means every 30 days you would be maybe retrieving within 30 days tile. That's called cool tile. Then it would be costing lesser. But if just going for archiving, what would happen is options, it is basically optimized for storing data that is rarely accessed. Maybe let's take for your HIPAA compliant policies, whether that machinery data is stored and is available years of time. So what you would do is instead of you stored on your on premises, you simply move it to HIPAA compliant archiving tile. So it just goes there within your Azure cloud, and there you can retrieve whenever the auditing comes. You can show them that this data is available in the archive tile. So when I say archive tab, it is optimized for storing data that is really accessed and stored at least for 180 days with a flexible latency requirements. That means when you in order to retrieve, actually when you're trying to retrieve archive data, it doesn't come immediately. What would happen is they takes at least 2-3 hours or 4 hours of time to make it available, the data. Because what would happen is in the Microsoft, in the background, they put it into the archive in a different storage. To retrieve that, it takes some time. So it's a planned information. If you're trying to retrieve it, you can put it into the archive tab. It's very cheap, in fact. But when you try to retrieve, it's going to charge the cost. So whatever you put it there, it might not be charged much, but when you try to retrieve, it's going to charge you. Now you understood hot, cool, archive methods. Now, as I said earlier, all these storage methods are associated with one account. So it's not your it's the account, means it's like thing that is a one box. We call it as the account. So that's called storage account. So that means when you log into Azure portal, that's your normal account. Inside that, when you go into the storage, that means the storage account will be there, where this kind of data can be stored. So now let's talk about where we can enable this cool and hot tile. So only hot and cool access tiles can be set at the account level. The archive access tile isn't available at the account level. Hot, cool, archive tiles can be set up on a blob level. So you can set it at the blob levels. And data in the cool access tile can be tolerate slightly lower availability, but still requires high durability, retrieval latency, or throughout characteristic similarity to hot data. For cool data, a slightly lower availability service level agreement and higher access cost compared to hot data, and acceptable trade-offs for low storage cost. So this when it comes to the storage, for the archive storage, it actually stores the data offline and offers the lowest storage cost, but also the highest data rehydrate or access cost. So you should know all this kind of pricing. If you put it into the archive and you frequently retrieve it, it's gonna cost you higher than actually hot tire, because a hot tire is which is useful for data that is in active use or expected to be accessed, read from, or write into very frequently, whereas the even the data that is staged for the processing eventually migrating to cool access tab. That means whatever the data is there, it is slowly can be migrated to the cool tab if you're not actually using. So let's understand a little bit more about the cool access tab. The cool access tab has lower storage cost because you are going to access a little bit uh, not frequently. That means it's going to charge you lower but higher access cost when you try to access compared with the hot tile. And this tile is intended for data that will remain in the cool tile for at least 30 days, because you might be think that you have example scenarios where cool tile can be used, for example short-term backup and disaster recovery data sets, or maybe older media content not viewed very frequently. Any more data is expected to be available immediately when accessed, actually, or large data sets that needs to be stored cost effectively while more data is being gathered for faster processing. For example, let's take long-term storage of scientific data, or maybe uh, telemetry data from the manufacturing facility unit altogether. So then you would be using the cool tile. And let's understand a little bit more about the archiving data. Archiving tile has the lowest storage cost compared with any of these three, but it is the highest when it actually retrieving the data compared with either cool or maybe hot tile, as we talked. And data in the archiver tile can be several hours to retrieve the data. Data must be remain in the archive tile for at least 180 days or subject to an early deletion charge. While a blob is in archive storage, the blob data is offline. That means it can't be read or written or modified, whatever your data stored in archive tile. And to read or maybe to download a blob into a blob in archive, you must first actually rehydrate into an online tile, and then you can't take a snapshot of your blobs in archive storage even. However, the blob metadata remains online and available, allowing us to list the blob and its properties. For blobs in archive, the only valid operations are you can get the blob properties, you can get the blob metadata, or list your whatever the data is there in the blobs, or maybe you can set the tile, blob tile, or copy blob, or delete blobs. These are the hydrated blobs data. You can do it on archiving. Example uses would be long-term data, which we talked about, like HIPAA compliant or whatever the data tile. So long-term backup and secondary backup or archival data sheets. Such situations you would be using the archive tile, or maybe original raw data that must be preserved for a longer time, even after it has been processed into final usable form. And you have some kind of a compliance or archival data that needs to be stored for a longer time, and it should be hardly ever access this kind of data. That's what storage tiles. So when it comes to accessing that specific data, either from hot to cold, because you need to convert to retrieve that data, or you can move data from hot to cold, or hot to archive, or cool to archive. So what would happen is when you try to move the data, because if you want to move, that means you need to retrieve that data, or maybe you have to write or read. So in that situation, there would be charges would be applied. So let's talk on that. When actually a blob is moved to cooler tile, that means hot to cool, or maybe hot to archive, or cool to archive. In this operation, it is going to build as a write operation. Okay, that means you're thinking that it has to be write operation, whatever the size of the data is that would be charged. And with the write operations per 10,000 and write per GB charges of destination tier would be applied. So if you're moving to destination to cool charges will be applied. Here, if you're moving from cold to archive charges will be applied for the write operation, not for the read operation. And when you move this blob directly moving from a warmer, this is called warmer tile, that is from archive to cool or archive to hot or maybe cool to hot, the operation is built as a read from a source. That means from here you're reading. So this is where actually the cost will higher, because these are you're retrieving from the archival. That means it's a costly, but the storing data is cheaper, but retrieving is a costly. So it's going to charge for you in terms of the source is in this case cool, archive and cool. So these charges would apply as similar as the read operation of per 10,000 and data retrieval per GB based. So two additional charges you need to calculate when you're trying to retrieve. Okay, let's jump into these replication. We talked about the cool hot archive, but that's gonna store somewhere in some physical location of Microsoft data center, right? What happens if that data center, how it is secure? I'm not talking about this physical security. In case of disaster or in case of something goes wrong, to be really able to get that data, or our company gonna impact. So that's where the replication comes into the picture. So this data can be sent to a different location, like we learn in the beginning of resilience and have a high availability purpose, like different two regions, availability zones, all that can be applied for this storage. Yes, you can apply that. That's called the replication side. So we're going to talk about that specific replication here. So you do have here, as we talked about the premium, it's not just the storage, you also have the replication premiums options. Like again on top of your storage account, you can set it to some kind of premium options, and you do have actually a replication mechanism, something called LRS and ZRS, GRS, and read RA means read only GRS, and GZRS and RA-GRS. So you have this option. So we are going to talk in detail this so that you would be understanding this table end of the replication. So let's understand and let's go back to this table. Also, this table also a little bit tricky table, and this is my table, which I actually call it as a cheat sheet. If you're trying to do something related to the replication of your storage account, this cheat sheet can be used, or this would definitely address a lot of questions that comes in your exam also. That's why I call it as a cheat sheet. And this is very similar to this, but it has more information. But let's also have a look on actually the replication side. So now when we look at the storage replication redundancy options, what are they? So the first one would be when we talk about the storage redundancy, what exactly is this? So Azure storage account is always replicated to ensure you have the durability. Let's understand Azure storage redundancy. So what exactly this? So Azure, as you know that Azure storage account is always replicates to ensure the durability and high availability purpose of the data which you are going to store in that storage account. The storage account, what would happen is the storage would copy your data to that is protected from a planned or unplanned events, including chances of hardware failures, maybe a network, or maybe power outage, or massive natural disasters in that case. So it's gonna store into different places so that you can choose or replicate your data within the same data center, or maybe to your journal, or maybe you can store the data within the same regional, or maybe across geographically separate regions. Let's say south to north, or north to west, or completely different altogether continental. So you can do that with the help of storage redundancy option. So this is very critical. That's why to understand about storage replication redundancy, and you have multiple options so that you can meet your SLAs in case if you face a unfortunate situation. So there are total 6 different redundancy options. Let's talk on each of them. The first one would be the LRS, we shortly call locally redundant storage, which is shortly LRS. So this is one option. So let's talk on more about the LRS, and then we can jump into the second option here, like GZRS, and then we can go for geo redundant, and we can go for read access geo redundant, and we can jump into geo zone redundant. And again here, this would be the last option, which is a read access geo zone redundant storage. So as you move from here to this side, it is gonna give you higher redundancy options. Let's move to the LRS. So this LRS is the low cost data redundancy. Why I call it as a low? Because it would be the locally, so it's not gonna take your data to other data centers, definitely. So it's going to be locally redundant, and that means it's going to actually store 3 times your data within the single data center. So when you create by default, if it would be normally, LRS would be the normal default one, but when you create your storage account with the default settings, that means the data you create or you store, it's actually storing in 3 different data centers. And you are going to get the higher percentage, that means 99.119 of durability of the objects in a given year. And also this can be used in an example scenario, like if a data center, I'm going to talk on these upcoming 6 or whatever the slides, we are going to talk about in unfortunate situation what you're going to do, and how the data is impacted, and what would be the best solution for that, so that you would better understand what exactly either LRS or maybe zone redundant or geo redundant or geo zone redundant, whatever the redundancy options you have. So now in this example scenario, there could be a fire or maybe a flood affected, so that data center itself gone. That means you don't have a storage which can't be recoverable. In that situation, your data is gone. So you should be know this fact actually. This is the same case, right? If you have on-premises also, you lost your data center completely because of an flood. It's gone. Your business is down actually. So you need to think for other options. So with the cloud also the same way, because you are getting LRS as a cheap, and that when you're trying to store the data in LRS, you should be awareing that, hey, I'm okay for 11 nines in a given year, and also the data center itself, it goes down, I'm okay to accept my data lost. So that's what the agreement you are making with Microsoft. That's why what Microsoft says is, hey, if you're choosing LRS, hey, just try to mitigate this kind of risk by choosing any of these possible options. Again, for every possible option, there is a risk associated, but again, the risk when we say risk, actually, we are talking about 11s also, will increase these 9s also. So let's have a look on how and when data actually writes. So when a write request happens, that means you're saving a text file or whatever the file in your storage. Actually, it's going to write to LRS account, then returns successfully only after data is read 3 times within a single data center, because LRS means it's a single data center, but it's gonna actually write in 3 different places. Now, also you need to know use cases to be understand, because as I said, why and the kind of risk, and also use cases we would be understanding about LRS and upcoming all kind of redundant storages. So the use case is, if your application stores the data that can be easily reconstructed if data lost occur, you may be opt LRS, otherwise don't go for this LRS model. Now some applications are restricted to replicate data. Even in that situation also we can use, like maybe you can't choose geo, or the data must not go from that region or from that country due to governance requirements. In some cases you can choose this kind of situations, this LRS option. Again, you can pay regions across with data that is replicated for GRS account, maybe in another region, if at all your governance allows. Otherwise, Otherwise, you can simply choose this LRS model. The next one would be the zone redundant storage. So what happens is with the zone redundant, it's going to actually copy to 3 different clusters in a single region. So if one goes down, like north, east, south, within one region, if you have 3 different clusters, it's gonna you have more redundancy in terms of within that region. So failing a region is highly not possible, but it is possible, yes, definitely. But you have the high redundancy compare with LRS. When you compare with LRS, GZRS or zone redundant storage is more redundancy. So what would happen is each storage cluster is physically separated, because we're talking about 3 different. So these 3 different clusters are separated, and there is another one would be the availability zone, AZs. So it's availability zones and GZRS clusters within it. So it is autonomous, includes separate utilizers and networking features. So it's not easy that it can go down. Now, if you think about how it's going to write, the writing would be happens actually on 3 of them. Then only it gets replicated to the 3 different clusters. So once it is written, it's going to give us a confirmation as, hey, I have written the data to 3 different clusters. So when you actually store your data in the storage account using GZRS replication, you can continue to access and manage your data files if any availability zone becomes unavailable. So because we have 3 different clusters, and each of them placed into different availability zones, so it's not so easy to go down. GZRS provides excellent performance and low latency. GZRS offers the same scalability targets to the LRS. You may have to understand what happens when a zone redundant becomes as unavailable. So when GRS or GZRS goes down, what are the situations you can say that GZRS is not replicating, or maybe you don't have unavailability. So let's understand that. So the data is still accessible for both read and write operations when if a zone becomes unavailable. Or within the zone, if it becomes as unavailable, still it is available for read and write operations. Microsoft recommends that you to continue to the with the best practices for transist fault handling. These practices includes implementing retry policies within your application, so that if one goes down, automatically it would take the it would actually there would be a latency which will say that, hey, it's not available. So within your code there should be a retry mechanism, so that it's gonna actually retry, because we're talking about a zone is becoming is unavailable. That means the zone undertakes the networking updates. So that means there is a DNS which is involved in the background. If one zone goes down, or one becomes as unavailable, another zone should take over in the between, in the milliseconds, or maybe in that seconds of time. Your DNS within the Azure DNS might have to be replaced or do reporting properly. So your code might have to say that, hey, you have to give it a retry. So that's how the DevOps or the developers has to consider to develop their code. But these updates may take your applications, if you are accessing your data before the updates have actually completed. But it is high luckily it can not happen actually, these kind of situations. But GZRS may not protect your data against regional disaster when multiple zones are permanently affected. Let's say for that entire region there's a huge cutover of internet, or maybe power, or maybe resources are down due to greatest flood that was never affected. In that scene, that entire region becomes as unavailable. In that situation, you might have to look for other recommendations, especially GRS, which is nothing but a zone redundant storage. So for protecting against any of the regional disasters, Microsoft recommends to use for the use, or you may have to go for the geo-redundant storage. That's what about the zone redundant. Let's move to other one, which is the geo-redundant storage. So GRS, we talked about the GRS is a recommended method. So let's look at a geo-redundant storage. So what would happen is geo-redundant is designed to provide you 16 nines durability of a given period of time within that year. So replicating your data to your secondary regions is a hundreds of miles away. So we're talking about within the same region, but here now it's going to be cross regional. That means hundreds of miles away from your primary location. So if your storage account has GRS enabled, then your data is actually durable even in case of a complete region outage happens of that entire disaster. Let's say there was all of a sudden there was an attack on one of the country, even though that entire region data is available for your customers, so it's not going to affect the entire region. So that's where you can go for geo redundant storage. So this is kind of in a situation where I would recommend, if it's required, in fact, if you're choosing for the complicated and critical data. But there could be situations, we never know the geopolitical issues, and then they kind of war kind of situations. The best option would be the GRS, because if something goes wrong, also you have other data center which is already available, and it's gonna service your customers, so there's no business down. So if your storage account has a GRS enabled, then your data is durable even in case of a complete regional outage or disaster in the primary region isn't recoverable situation. So if you opt for the GRS, you have the two related options to choose. One is here GRS replicates your data to another data center in a secondary region, but the data is going to be available to read only if Microsoft initiates a failover from the primary to secondary region. That means it's the action taken by the Microsoft, not by you. So because Microsoft also have an SLAs for that entire region, since that entire region is down, they can push the data to take it from the secondary region. In that situation, you can get the data. But here there is another option, which is you have your read access geo-redundant storage. This is another type of GRS, which is read access. So what would happen is GRS in this situation, read-only access GRS replicated your data to another data center and its secondary region. So that means it's going to provide you with the option to read from a secondary region. You can read from a secondary region regardless whether Microsoft initiates failover from your primary location to your secondary region. So there's no dependency on the Microsoft. It's automatically the data is available. So this is more costly compared with normal GRS, definitely. So let's go back to other options, which is again the building high available Azure storage applications with your zone redundant storage, which is a geographical based zone redundance. So in this, it actually goes for the high available compared with the GZRS, because in the GZRS what we talked is here zone redundant is just the normal one, but here you have an option to actually go for geo redundant, which also contains your storage account would be replicated with Azure availability zones in the primary region, also replicated to the secondary geographical region for protecting from your regional disaster. Each of these Azure region is paired with another region within the same geography, so together, so that you get higher availability with this kind of things, with this kind of pairing. Actually, geo zone redundant storage account, you can continue to read and write. Operations can be continuously can be done if availability zone becomes unavailable also, or maybe if it goes even unrecoverable situation also you will have, because it's coming from other zone altogether, and it is paid all these geo redundants to another geo also. So additionally, your data is also durable in case of complete region outage or disaster. This is very similar to the previous one if you see here, GRS. So if that goes on also, you have this option. And also you're going to get the same kind of 69's durability of the objects in a given year, and it offers more scalability comparatively LRS or ZRS or GRS or read-only GRS. So you can optionally enable read access to data in the secondary region with read access geo zone redundant storage. So this is the highest level. And you can, Microsoft, what they are recommending is this is the highest level what they are recommending for any kind of applications which you need a consistency and durability, high availability, excellent performance. Then it comes to the resilience of your disaster recovery. This is the best option. If you're looking for how the data is actually when the data is getting replicated or once it is written. So here you have the three availability zones. Once it is actually written into the first place, then it's gonna replicate to the secondary regions or secondary regions which is in hundreds of miles away. When data is written to the secondary region, it's further replicated synchronously to 3 times within that region locally redundant storage. So you have multiple times the data in a multiple places you have the data. So it's highly impossible to lose the data. I hope this makes easy for you about the storage and the storage redundancy options and storing the data in a different places. So let's go back and check for our sheet which we talked so far in a cheat sheet. So let me jump into that slide. So if you can look at here, this sheet actually talks about how and what kind of replication options you would get it when you try to create a storage account. So let me go back to Microsoft Azure portal and show you here how this sheet would help you out to better understand. So as we said earlier, once you have created the storage account, you have an option for your kind of data you wanted to store within any of these formats. That's true. That's the option you have for almost with every possible storage account. But let's create a storage account. I know what kind of options it's going to ask you. So I'm just clicking on my all services here and going back to storage. In the storage, you have an option called storage account. So this is where all the storage specific information so far we learned it's gonna create and store. So here I'm gonna give my resource group as AZ-900. Now I'm going to create a storage account here, AZ-900. You see here, as I give here, it says that the right field is coming up, and it says that you can't give as a capital letters, and only lowercase letters and numbers are available or should be used. And this is also, you can't use a space, all those, because this is actually AZ-900. I'm going to give here in a short. This is the unique things has to be there. So you see here somebody has already taken AZ-900. Now I can go for AZ-901. So let's see, the hyphen is not taken here. So I've just taken out that, and now it's taken. So this is accessible uniquely in the background with a fully qualified name in the background. So you need to give a unique name of your storage account. So I'm just giving here as AZ-900 demo. Okay, and this should be available. Oh, it's also taken by somebody. So I'm going to give demo 1. So that should be available. Yes, it's available. So I'm gonna my storage should go for any of these regions. So I can choose here my data shouldn't go from my Southeast Asia or maybe from US West to something like that. You can choose it based on your compliance policies and governance policies. You can choose it. So I'm gonna actually choose here as West US 2, and this is where I'm gonna talk actually about storage type is a standard or a premium. We talked about the standard and premium. Standard means it's a normal SATA. When you choose a premium, actually you're getting a higher chances of data read and write. That means IOPS, you're going to get it higher IOPS. So you see here, when I choose your premium, not all the options are available, or whatever the options which are coming in a standard, which are not available here with the premium. And same case when you choose even cool and hot also, like if I choose premium, I don't have an option to choose a cool or hot mechanism. So now here, I just wanted to show you here the replication. What we have talked about, all this LRS, ZRS, or whatever the zone replication, all that geo, all that has actually talked within this specific one. You see here with the premium you don't have all of that, so you have only LRS. So if you are maybe that's interesting to learn but all of these to implement, but you have an option only for LRS, not for the zone or geo redundant level. So when you choose a standard, you are actually getting almost everything, or every possible information, or every possible type of redundancy. But with the premium you have only LRS. So that's one other point you may have to take a note on that. Now this is where the account kind. So we talked about the storage types. If you can remember, disk, files, blobs, tables, and queues. So we talked all these things, but with this what happens is with the kind of account means, so what kind of account you're going to use. Are you going to use only for the blob purpose, or file storage? And this is where the storage v2 is the latest one, version 2. So this is where it's gonna, so we use the storage v2 normally in general. So let's go ahead and create this. It's gonna create if you're looking for the replication for other things, so you might have to compromise on the standard one for the performance, and then you can choose whatever the mechanism you wanted here. So I'm going to actually choose the LRS because it's cheaper, and I'm okay to accept that 99 point whatever the nines we talked in the previous slides. So let's review and create. It's going to actually create for me an account. Once I have the account created, I should be able to go back and check for this specific storage account. So I can go back to all services again. To view it, my storage account, I can simply click on storage accounts. Those that would actually list me all my available storage accounts within my subscription. So if you see here, the filter is already applied here for my subscriptions. If you have more than one subscription, make sure that you are working in the right subscription, otherwise you are going to create that specific resources in other subscriptions. So in this case, I'm in the right subscription, and I can see here the new account type has been created, which is the storage account here, AZ-900 demo 1, and simply click on that. So you have all these information. So when you go to the containers, this is where you have the blob services. If you see here, this is where you can create a container is a level of the top level, like in a folder. So you can say VHDs. So this is for just the VHDs. So you need to again mention in the small letters only, and then click OK. That would actually creates here one of the VHD, and inside this you can move whatever the files you wanted to move. You can upload directly from here, but people will use anything to do with the storage account. They actually use something called a storage explorer. You see here, this is the one which is comes from the Microsoft. This is a tool actually. Storage explorer also comes as a tool for you, and this is where you can use as a tool. But now they are actually integrating this tool to within your Azure portal also. But let's actually download the tool and have tested storage account specific one. Storage explorer is a tool which should available from Microsoft site. You see here storage explorer, which is a cloud management tool, and you can download directly from Microsoft Docs. This is where it says that this is a tool. It looks like this, and once you have installed that, you can download directly from here by going this. It's Windows, not only just for the Windows, it's also available for Mac and Linux and different other operating systems, because we're talking about cloud, and it's most compatible with almost all possible operating systems. Now once it's done, I should be able to install this tool in a quickly without any issues. Since it's just installed, I'm just launching the tool, so that I can show you how it actually looks like. So this is the tool. So you have this one, and this is where you can access with your storage icons, like you want Azure China government or used government, or a new environment which is a private isolated environment you can choose. So now it's just the public cloud, so I can choose an account. This is where I can add my account. So in my case, I can add here the account which I use. Once it is connected, it will actually pull all your storage accounts, and you can actually, I'm just applying my subscriptions. That's a filter and the layer of filter. So within this tool, you see here all your storage accounts has been listed here. So within this, my storage account is AZ-900 for this demo, and I can see here my containers. So within this, I just created as VHDs in Microsoft Azure, and from here I can actually straightforward upload the required files, or maybe a folder if I want to I can upload, and I can play with my tables or queues. For example, I can create a new table and say demo example, and I can add here import the specific values, or you can add the information like primary key is this value, maybe a test, or this would be a demo, something like that, and you can insert this information, and within this, whatever the data is coming up, that can be added here. The values, add another property, and then insert that value. So this is if you're trying to work manually for the tables. And similarly the queues also, if put any of the queue inside this, and you can play with that queues and you can work. Similarly, file storage. So within this, you can actually create a different type of storage files, like you can share any of the files. And let me close these things. It comes as a option here. You see here there's nothing is there. You can create a shape folder, like folder. There's no restriction. It's like your own SMB server or file server. So folder, this is one of the folder which has created. So it must be lowercase. So let me give you that format. Then later point, within this you pull any of the data, or you can upload. Like I want to upload one of the folder, maybe I just go to my upload my disable one of the registry key information. So I can simply now upload this entire folder of selected folder. So all the contents within that, for example, there's 2 files which is going to upload it in this. So you can check out it's just comes that. So this is the interface if you want to work for a larger files to be updated. Otherwise, you can use the Powershell. Also, you can use the browser-based mechanism also. But most of the people, 90% of Azure admins, they use this method with the Storage Explorer. And also for the HDD VHD files, also the same case. You would be normally converting all that stuff would be doing from here, and you can upload from here. When you start uploading from here, you can directly upload like the similar file method what we have tried, and also you can copy it as a direct file so that it can directly share that file, so that any of the admin directly can open, like I can open up in a browser that would redirect to my storage account. Such things can be done directly within the Storage Explorer. And also within the Storage Explorer, you also have Saas, which I'm going to talk in a minute, directly from the Azure portal. That also can be done. So all the things which are possible or not possible from the browser also is possible now with the Storage Explorer. That's the greatness of the tool. I hope this tool you will be definitely using it. Let's move and understand about the Saas. Saas is the shared access signature. It means, for example, you wanted to grant explicitly some kind of permission against to your blob, for example. So what you wanted to do is in the blob you wanted to allow for only read-only permission, for example. So what you can do is you can simply select on what date to what time you wanted that specific permissions to be granted for that specific user. Let's say from 11 p.m. to 11 a.m. That's wrong. Maybe you can give as the a.m. to p.m. That might work. Yeah. So here you can give such kind of configuration, so that what would happen is actually this would actually sets the permission, so that from this specific key only, like key 1 and key 2 in combination, so you can grant the permission. So in my services I wanted to know access for the grant for the object level permission I wanted. So if I just click on that, it's going to generate this lengthy of the connection string. This can be used by the programmers, or maybe even Storage Explorer for that matter, which we have tested. If you can remember, we try to upload here the content, and all that has been done. So here also you can go ahead and connect. From here you can start connecting with the Saas based URI if you want, or storage account key and the key based. Like when I say key, actually it's gonna ask for a key also. So this is for the token. Let's continue with the connection string and the token, and for the single URL. So this is the direct URL kind of thing, and you can actually access the services, but when you try to access it, it says that hey, it's not going to work, and it's going to only work from that time to that time, specific time, not now. And also on top of it, XML format, so you can't do it from here. But at the end you can actually access it from Storage Explorer or from a connection. If you use this connection string, any of the developers, they know that how to connect this, and they can write the data into that blob by using the connection string. And if they wanted just the explicitly access token, this is a token. Even in fact, this token also will be part of here in the somewhere in the lengthy of this. And if you see here somewhere here, it would be there. But you see here, this is the value is which is coming up, and this can be used actually. But the problem is connection string will be easy for the sometimes for the programmers, sometimes only for the Saas is useful. So this is how you give the permissions explicitly on type of the storage that you wanted to grant the permission, and type of the object you wanted to do it. And also there's something called the keys. There are two types of keys, would be the primary key and the key 1 and key 2 we would call it actually. So whenever the key 1 is there, if it is compromised, for example, now I make it as available, you're able to see. So in case if I don't delete this account, you should be able to upload anything by using this key, as much as data you wanted, and I would be paying for that. So in that situation it would be a costly, cost effective. So these keys will not be shared with all the people. Instead what they do is we would actually change it. So if you just do it key 1, it's going to actually regenerating the key. So it's just regenerated. Once you regenerate it and replace the code, before you regenerate, actually you try to put this key, if you used somewhere as a key 1, replace that in your programs with the key 2, and once a regeneration is happened, you can replace with the new code within your programming or program, so that you are actually securing and you will not be seeing any loss of connectivity just because of the key has not working or something like that. So this is very important in terms of securing key. This is heart of your data locked with some kind of key. So if somebody, or if it is compromised, it's we're gonna pay a lot because of that. So we need to make sure that you regenerate. Before regenerate, either replace with the key 1 or key 2, vice versa, so that your applications will be in sync and it will be continue to serve for the business. And later point you can change with the new key. So in case if new admins comes up and old admin leaves the company, make sure that you replace or change these keys, so that and also make sure that it's document wherever you use these keys. And that's how it's going to work on the storage access side. And the replication side, we talked about the geo-replicant. In case if I want because it's just the LRS, so I can view very clearly here it is just for this this is where my data located. But if I want if I have somewhere else also, I can actually configure to replicate to other regions, so that way data can be replicated and I can easily visualize where is my data. And these are the things which are important. And in case if I just go for GRS based replication and save it my account, so it's gonna actually updating my entire account to GRS specific, and I'm not changing anything else. But if I just go here, I can see here now it's a new secondary location has been added, which is in a West Central. So whatever the data I'm putting here, it's going to actually put it there also. So these are the values for storage account endpoints which are configured with this name. So every time if the blob, it will represent as a blob, and then this name if it is a file.co.windows.net. So these name co.windows.net is remains same for everyone, including here if it represents as a blob, this is a blob, this is for file, this is for queue, and similarly table and DFS represent the ADLS of file systems, and static website would be this. So if you're trying to or remember, this is at least one of the question definitely in the AZ-900 series, or the higher level series. At least one of the question would normally comes based on how do identify. So we can say that blob or file or queue, and it will end up with code.windows.net. That's it. That's the answer that they might be looking into it. So this is my secondary location. It has automatically configured. So now you know how it's gonna happen. So if you're integrating your identity services with Azure AD, you can configure that, and this is going to be read-only access for geo-redundant. That makes more sense for me to configure it if I just want it for a read-only access purpose. So this is where you are going to configure a hot, a cold, all that specific options which we talked again on top of your storage account. And also you have here, instead of paying to somebody to host, you can also host your storage based websites directly from here. That's a static website, and I'm not going to save that. So these are the again the direct URLs or the Saas or whatever the URLs, so that you can directly connect. And I hope I made it easy. And this is where the lifecycle management, you can create a rule when your data will be moved to which location, when you want to delete that blob, and when you want to delete the snapshot. This is where you do the actions against to your first set and second set, and then you can review it based on your life cycle of your data management, so that you can save the cost. And on top of it, there's something called advisory. So this is advisory is a service which is almost freely you will be getting from the Microsoft. In case of any of the security issues, they would actually tell us there's some improvement areas, this is where you can do, or something like that. You would be always getting it. So in my case, there is recommendations are been added. It is inactive. The following recommendations will be available. If I just go to entire my subscription level, I should be able to get the improvement area. So these are the things I can do it. If not, what I can do is I can postpone these recommendations. If not, I can just go ahead and implement all these best recommendations which are useful as the entire Azure improvements and recommendations for the entire Azure specific. Now I think I should be able to conclude here by stopping on the storage specific, and I'll see you in the next lesson. Thank you for watching this. Hello and welcome back. In this lecture we will be looking at database products that are offering from Microsoft Azure portal, and the options that we can use of each of the product. We will be looking to it. Now if I go back to Microsoft Azure portal and go to all services, and then I do have your databases. So I have 19 different products which are available. Or if I go here and choose all, and if I search as database, so I would be able to see here some of the products. So you see here there are products are listed like Cosmos DB and SQL database. So such things are very important, and we are going to look into it. So to begin with that, as a first one, we would like to have a look on Cosmos DB. Now, Cosmos DB is the newest offering in the list from the Microsoft Azure, and its most popular one, isn't it? And it is nothing but there's no SQL database service. When I say no SQL database, it means that no SQL means that exactly it does not use the relational database model like other products do, like SQL Server in your maybe on-premises, or if we talk about in cloud as your SQL services do. Instead, it's more like a document database. Perhaps you might have heard something called MongoDB or other databases that uses no SQL. That means there is no relationship. So let's jump into what are the bullet points and how we can connect. So if you look at here, Customer DB can connect with these three of different mechanisms. So we'll talk on that in a minute. Azure Customer DB is a globally distributed and multi-model. It means that it's a platform as a service offer from Microsoft Azure. This is Cosmo DB, and will automatically handle whatever the scaling you wanted, even across multiple regions. That's why we call it as the globally distributed, and this is one of the main nice feature of Cosmo DB. Well, your data is replicated across many regions in the world, and because of that you should almost never run into a case where you lost the data, because even if your old data center goes down, your data still exists in at least one or two different regions, and that are still up, and because of that you never lose your actual data. So that could be a big benefit for mission critical data or applications to get this kind of built-in scalability across multiple regions. Now, when we say multi-model, it means that Cosmo DB supports multiple APIs or multiple ways to you can query your data, and you can get into use that's a familiar like SQL or structured query language syntax that most of the people who worked with relational data are familiar with. You can use similar kind of APIs that use the Azure storage or your Azure tables uses. For those who are familiar with the MongoDB database, that's nothing but a document database, you can write queries the exact same way as you would use a MongoDB with Cosmo DB. So it's almost the similar way you can write up, and you can call the Gremlin API, which is based off your graph data. And in fact, the Facebook uses the same thing. And also you can use the table storage, as I said, MongoDB. All these are the APIs which are supported. And we also talked about the PaaS model, and it is capable of auto scaling across multiple regions. These all are the multi-model. It means multiple different ways of querying your data, which is helpful because you might have people with a different skill set on your team. Maybe some people are familiar with SQL, maybe with MongoDB also. Maybe also some of them are Azure Storage, and they can also call Cosmo DB by picking up APIs that they wanted to use it. Now, in addition to all these, Azure Cosmo DB also supports analytics by using Apache Spark, and we'll have a look on it, Spark, in a little bit more in the upcoming videos. But Apache Spark, just to tell you that it will let you connect to the data source, in this case Cosmo DB, and run big queries that can do against huge data sets of getting analytics and reports, other kind of data mining information out of your data. And having natural ability to write these Apache Spark on top of Cosmo DB makes it more helpful before those analytics kind of thing or comes into your scenarios where you can use the Cosmo DB to pretty well for the features database. And it doesn't use their relational model to non-SQL or no SQL. So just if you want to summarize about the Cosmo DB, so what exactly Cosmo DB? Cosmo DB is a non-relational database model, so there's no SQL, and it is globally distributed, auto-scalable across many regions, and it supports many different APIs and analytics via Apache Spark. Overall, a great choice for a new development in the cloud, for migrating older apps to less expensive option like Azure Cosmo DB is a less expensive compared to your some of your SQL options that we'll look into it in the next. So now with the SQL database, you have the two offerings Microsoft SQL offers. One would be the infrastructure as a service. That means you go ahead and you would install in a VM the SQL server. Like if I just open up this um, uh, portal or Azure portal, I can go here and search for the computing. Here maybe a SQL. Oh, like if I just search with a SQL, so you see here Azure virtual machine, which is coming with the SQL. So that means the SQL also will be already available within that. So I can choose in such a way. So that would actually create me a new virtual machine with the SQL option. Let me show you what I'm trying to say. If I just go to virtual machines and try to create a new virtual machine here, simply I choose my whatever the resource group, and I can browse here all the available images. Within these images, I do have here database section. So that means all these databases also available, but these are some of them are third party. But what I'm talking is here, I can talk about the SQL here. So if I just search for the SQL, I can have a SQL server with the 2012 configured with the enterprise edition, for example, on a 2012 server. So such kind of configuration or SQL 2019, 2017, all that are the possible options I can choose it. So you see here on a Red Hat Enterprise Linux, we're gonna install the SQL. So or maybe standard Red Hat. All these are the options that are available on my SQL server. I can configure as an infrastructure as a service. So that's what we talked. So on a VM, you can have VM along with the that's the operating system along with the SQL is already installed, pre-configured for you. Or you can install, you can spin up, think about it in this way, you can spin up a VM and you can install SQL Server. So nothing stops in that way also. So you can have that option also. Now, other one would be the platform as a service model. So it means that you can go ahead and spin up the SQL database engine with the more elastic pool options and other options you can configure. So let me show you what I'm talking here. So if I just go to the platform as a service model or to have the databases like a SQL database, I can just go here and check for my SQL database. That means it's going to be a PaaS model. So I simply have add a server. That's gonna adding a server in the cloud in Azure, and inside that I can have multiple databases. Think that you have a server and you can have multiple databases. Similar thing can be done. Like I'm just creating here like demo GB for AZ-900. So that should be unique. Again, the name, so it's there, and I can spin up here like with the giving the name. In this case, I'm just giving here a admin logon name and create. So that's gonna actually create a database for me, and validation is failed. If I just go back here, Asia specific, this location is not available for me to subscribe. I can go back and check out my VSUS, which is I should have the permissions in that. So it's going to ask me all other options like the networking and other options. So it's going to create for me a database, and I can connect from my machine by simply connecting to a PaaS model. You see here it's completed the deployment, and then the next step would be I can connect to this server directly if I have SQL Studio Management is already available. So in this case, I have already SQL Studio Management. I can simply go to the resource and check on this. So you see here the SQL Server is configured within this, but there is no databases, so I need to create one database. So this is where I'm going to create within that server one database. I'm going to create, like, think that you have one dedicated server. Within that you're creating a databases, like you can have multiple databases. So I'm just creating here demo DB for my app1, maybe application 1 purpose. So it's going to be a blank database, and this is into my demo AZ-900 server, which is going to host this. And if you want elastic pool, so it's going to actually charge some additional charges with the elastic pool. Like if you just configure here, this is what I'm talking about, the codes and other things you can customize. You see here, if I just go to the my elastic configuration pool for the new pool, and it says that the basic would be the two virtual cores or 32 GB. If you want more CPUs, you can expand like this, and the GB of the RAM also going high-end. You can configure, actually this is your memory for data max use can be configured on the local storage space. And as you configure here, it's actually getting configured as per the elastic pool configurations, and the charges would be applied according to that. So you see here, you can go for 20 cores, 40 cores, whatever the cores you wanted, and it would be charged based on the V core. For example, just for the cores, you can simply configure based on the 40 cores. So that's going to configure for me 40 cores with the 340 GB of data maximum can be configured with the log space allocated 91 GB. So this is the pool capacity of what you can configure, but this is just the general. If you're looking for the business critical, again, you have the generation configurations, what you can configure here. So these are the FSV2 or M series, a general 5, generation 5, generation 4. All these are the possible options where you can choose your configuration. So based on that, you can configure, but some of them are, it's not immediately available. So in that situation, you need to raise a case to make it available with the Microsoft, or you can talk with Microsoft if that's really available in your region. So I'm just selecting generation 4, and now with generation 4 I want maybe with this, so it's going to charge me this many INR, but if you try to do it, it's going to tell you in the USD also. If your database, if you're getting charged with the USD, it's going to charge. So this is the pricing information, which we can talk at a later point maybe, but the pricing is based on a DTUs. So DTU is again a dynamic method which would talk about like database transaction unit based. Like you see here, when you increase the computing performance, it actually comes into either DTU model or core model. So within these two models, you can configure based on your requirements. So in my case, I'm actually configuring very little less because I don't have much balance here. So I'm just say I don't want these many cores, so I just wanted here very less with the general, maybe because it's heavy. The pricing, so it's going to be, this is the pricing what I'm going to charge. That's okay. I can click on apply. That's gonna charge, and I can give here name as this is Gen 5, which I'm using with the 2 V cores, vCPUs. That's a power. And then click select. That's gonna create for me. And collation, you can choose here the collation model, and simply click OK. So in my case, I've chosen that. It's gonna spin up a database in my server. So the server is, in this case, it's the under resources, right? Everything is categorized or under that resource group. So in this resource group, you have the server which was created by us for the SQL. This is the SQL server name, and within this, the database is getting created. So if I just go here, somewhere here, the databases, so I should be able to see that database which is getting created. So in this case, I'm just going to the database, SQL database, and this is where it's gonna spin up in a minute as soon as it has been spinned up. So here is still going up the database. Once it is created, I should be able to connect by giving here the required connection credentials by clicking and connect to the database. This is where I can give the whatever the connection details it's gonna give us, that we can use and get it connected. So this is the PaaS model. You see here that the database is created, so I simply have to close this, and if I just go back to the database once again, I should be able to see here one database, that's a DemoDB application 1 specific, and this is the database. I know that I can currently, it is not used. This is 32 GB and 16 MB. All this information I can simply configure, and I can configure even geo redundant also. Let's say currently it is into West US. I wanted to configure for Australia example. I like maybe this region also to be configured. So Canada, this is going to be configured in the Canada Central. So I can configure here and spin up one more. So it's going to create a secondary database in that location. So that might not take much time. Let's see, I can create here in Canada demo AZ-900. So it's going to be create here, and for the login credentials, I'm just giving here password, all that information. So it's gonna create in that location. So it's just creating the server there in that location, and the readable in this case, and target server, and same one, same kind of configuration. I just click on OK. So it's going to spin up. So what would happen is, you see here from Canada till to the Canada, it is actually making a relation. Now similarly, if I just go to maybe here in the Australia location, like Australia South, so this is going to be again a configure. It's going to configure in that location. This location is not available for my subscription, but otherwise I should be able to do it. So if I just go to the Brazil location, so one more it's going to create in that location as a readable. So that's where it's going to create one more readable one. So if and something goes wrong, you will have the database in that location too. So these are the highest availability regions and other things you can configure. In this case, you see here now the data is also getting to replicated to all these locations. So you see here it's coming to Brazil as well as the Canada. So two locations, the same data is getting replicated in a geographical a replication which is happening. And if I want to connect from my PC, so what would happen is, actually I didn't told actually about the pool option. So let me talk about the pool option. So if I just go to my databases, my Azure, so you see here I have the database here. So this is the database server. Within this I have only one database, so I can configure multiple databases here within this. So this is a database which is connected or which is available on the SQL server which we hosted. Now within this database, within this you can have the two quotas can be set, or you can configure your required databases so that it can automatically take care of this processing power. So in this case it's just the SQL database one. So this is what exactly my SQL database server. Within this I have one database, so I can have multiple databases, and I can elastically say that, hey, if my one of the database is needs more DTU power or processing power for that specific query or that specific database execution, you can elastically share that configuration, share that power of your CPUs, share that power of your RAM. All that can be shared within these databases. So it's a pool supported, right? So that's why we call it as elastic pool. Now I just go to my database, and if I want to connect to this, you see here connection string is available. So if I just click on here, so this is the SQL connection. If I try to connect from any way of my password with my ADO Connect, but if I just use the JDBC or ODBC, all these are available here. Or if I just go to my PHP, I can use this code. So it is readily available for you. And also I can connect, this is my server. For example, you see here, this is the server name. So I just take this and open up my here I can see server name, I can enter, and now I wanted to enter my SQL authentication specific logon and password. So in this case the user ID is this, so I'll simply say, and I would give my password here, so that would actually connect to that SQL server. So it's saying that, hey, you need to sign in. It is identified that, hey, you are actually trying to connect from Microsoft Azure portal. You need to sign up. So I can simply sign in. So that's going to sign for me. Enter my user ID and password. I have to just enter my password, so that would actually connect. It is authenticating with all that information. Click on OK. That would actually connect my SQL server automatically. Now I'm actually connected to my SQL, and the connection you can see here, it's gonna pop up in a minute or so. And the icon is, if you see here, it's a blue database. That's nothing but your Azure database. So I have connected to this database, and I can query whatever the data I want to do it. So this makes it so easy to connect to your PaaS model, and you can start using with your connection models that are available within the Microsoft Azure database connectivity. And you see here the replication also gonna happen, all that. It's so easy for the PaaS model. Now if you see here the geographical replication was completed. That's why you have this option. So if something goes wrong, you can readable from this location. I can change if I really wanted to. You can force to failover. I can do that simply. So it's going to actually failing over to that location. So in this case, Canada is going to fail over. So this becomes as a primary, and these two becomes as the secondary, just for the read only. So this is how you can in a minutes of time you can play with your databases. You can create, you can configure, you can give that complete power of Elastic, and you can do the replication. I'll just wait for a second to complete this and show you. After waiting for some minutes, you can see here it doesn't take much, like 2-3 minutes, because the database is nothing much. Here you see here the Canada become as a primary. Now other two regions become as a secondary databases. So these are the readable, and this is online. That means you can write and read. But our connection was still there, and there's nothing you're gonna lose. So you can get all the information, like I can go for and view all the querying to the entire database and get the information and the structure. So this is so easy when we talk about the database in a PaaS model. And similarly, what we have talked, let's have a review on it. We talked on Azure SQL database, like you have the model infrastructure as a service model. That means you will spin up a VM and you install SQL Server. So you can use your existing licenses also within that SQL. So you get the benefit. So if you try to spin up a VM which has the SQL, if you own that license already, you can choose that option that I already own that license, so it's not going to charge you much, so you are only paid for VM specific. And similarly, you can spin up your VM and download your SQL Server from your Microsoft MSDN licensing or whatever the licensing you have, and then apply that key. So in that situation, you will be completely responsible for the server performancing, auto scaling, all that. But here with the PaaS model, you have Elastic Pool. So Elastic Pool contains your databases, your managed instances, all that, and that power you can give it to your databases. So if any one of the database also needs the more power, it would automatically adjust with the from the Elastic Pool with the DTU power, like a CPU or memory power, and that makes more easy. So these are the advantages when you go with the SQL databases. Now let's have a look on Azure SQL Database, which is another topic. So within Microsoft Azure portal, you do have here the databases. So when you go to the databases, you have the SQL database warehouse. So formerly it was SQL database warehouse, but now it's called Synapse Analytics. So if you look at here, Synapse Analytics is formerly, it has been renamed the name, but in your exam might be getting as a SQL data warehouse, but you need to look at Azure Synapse. So what exactly this is, it's similar to your TSQL analytics, and you have the SQL pool, you have on-demand services for your database, and you are going to pay for terabytes of the data. You also have here integration for the hybrid integration can be possible. You can check with Spark and Studio. If you are looking at this diagram talks about how it actually manages your databases and other things as an architecture side. So this shows the distributed tables and all that information, how you can analysis with the SQL analytics information with the hash functioning and other options. You can also do the replication, other things. So if you are looking for Azure Synapse Analytics, it's currently into the preview. You can start filling up this, and you would be able to get connected. But in the future, it's directly available, like we have here now. Directly it is available, and you can simply go ahead and spin up that data warehousing option. You can simply create data warehouse. This option, it's going to actually create similar fashion that the way we create the SQL Server and then the SQL database. Similarly here, the first SQL Server, and that's a data warehouse server here, and then the databases which is gonna come up here. So that all gonna happen in a minute or so if we start creating it. And this is the limitations of the pooling and other database links. I'm gonna link up these things within the this video. So let's jump into the actual session of the Azure SQL data warehouse. So what exactly this is a very large amount of the data that is designed to hold just little bit differently than your regular database. And the idea with the data warehouse is that you're going to have a huge amount of data, and that's you are going to always to keep adding to that same data as well as. So you might have a variety of data sources like your applications and some of internal application like CRM or ERP kind of stuff. And if you see the data wherever it is coming, like maybe a social media or from your devices, all that, or maybe for that matter Internet of Things also, the data may be coming up, and you are actually adding to that data into your database. I mean, you might have lots of different sources of data, and the idea with the big data solutions is that you take in all this data and store it somewhere that's really set up well for storing large amount of unrestricted or unstructured data and different types of data. So this unstructured data would be stored into something like Azure Data Lake Store. So now that you do from this to run analytics services, a variety of queries, even machine learning against your data, so that you get the a kind of an output that you are looking for it. And where the data warehouse comes into the right here at the end, once you have taken all this different data and stored it somewhere as is a staging area, and then performing some kind of operations on top of your data, usually left with the results and with these queries, and that's what the data warehouse service can do for you. It's basically a cloud-based data warehouse. So you can have when you actually run or when you get from different sources the data, when you wanted to run some kind of query, it actually runs a parallel processing. So each process takes a simple processing time, and the data would come for you later point by joining the results. So it's a very quick, and complex queries also can be run across petabytes of data, and you get the output in the easiest way. So this is very useful for the big data solutions, and artificial intelligence on top of it you can run, and you can get some kind of proper information if you're actually looking for data warehousing solutions. And that concludes about the Azure SQL data warehouse, and let's jump into the Azure Database Migration Services. So database migration services are easy, and it enables for you seamless integration, seamless migration from multiple databases, or its source you can choose as a database, and then it can migrate to Azure data platforms with a minimal downtime. This can be done in an offline migration plan or maybe online migration. So when you look for the offline application, definitely goes for the downtime when the migration starts. Actually, when you talk about the online migration, the downtime is very limited. When you actually cut over, time only would take over, otherwise it would normally work. So now let's have a look on how the services works. So if you just go to the all services type for migration, you have under databases Azure Database Migration Services. So this is where you can create your migration services, lift and shift kind of thing, where you can migrate the services. Like I can choose here, and this is, if I look at was US2 and I wanted some kind of service name like migration service demo example, choose the resource group and create, and this is where it's gonna ask me for the networking. So I can choose here the available network name demo and create. That's gonna create a network name, and once I validate it, it's gonna start the deployment, and that would actually take a minute or so to complete this migration services to be added to our dashboard or maybe to our services. So this is where it's going to come up, and then we can do whatever the services we wanted. So if you look at here, you also have the hybrid. So that means you can also do these services can be run from the on-premises machine, and this is from the Azure service mode. So you can configure the number of premium or maybe standard. It all depends on the pricing. Like you see here, the 4 cores or 5 cores. You can choose what core is right. If you just go here, it's going to talk about the core specific services. So if you have a more cores, it actually gives you more processing power. And you see here, if it is a SQL or RDS SQL, Azure SQL DB target, or if you're trying to migrate from MySQL to Azure DB for MySQL, then these are the targets are supported. And you can check out here the premium, all that options, and once you have chosen here that specific service, you can right click and create by giving here the name. So in our case, we just created a service with the demo which we just created, and it is actually on the way. It's gonna execute in a minute or so. So that would actually create a migration service under this in a minute or so. The services are still provisioning. In the meantime, I can go and show you a good website which can guide you very well. If you can open datamigration.microsoft.com, which is a Microsoft site, and you can choose here any kind of database as a source. Let's say I wanted to migrate to Azure SQL database from Oracle, then simply have to choose this, and it's going to give me step-by-step instructions within the 3 or 4 different phases. You see here, these are the steps I need to migrate. I need to work on it, and then I'm gonna do this way. These are the steps which talks about all these step-by-step instructions, and then you can simply go ahead and migrate it. So the actual migration would start here from the synchronizing all that. So it's so easy if you're actually looking for a migration services and you want to run it directly. So let me show you other one we shown for the Oracle. Now for the SQL to SQL, that's Microsoft, then I can simply choose here Azure, then what are supported, what not supported, and you need to look at the steps, each of them, and once you follow these steps, then go to the pre-migration, access and assessment, convert, then go to migration step. So this is where DME and other migration activities you would be looking into it, then sync it and cut over. As a post-migration steps, you can perform it. So it's so easy. If you're actually looking for any kind of migration services, just go back to this specific URL, that's datamigration.microsoft.com. It would really helps you, including the Cosmos DB and other all the databases, including the access to SQL also made it easy, and SAP to SQL, all that options you have here. I hope this is useful for you. And if I see here, yeah, it's just provisioned. So let me, DMS is provisioned. Now if I just refresh, yeah, I got this, and this is where the migration services are there. I can configure my migration services, and I can enable here and then start migrating the required services, like new migration project. And I wanted to migrate from here. The source is the SQL. If you have the SQL database, or you have a SQL or AWS, RDS, whatever the database as a source, you can choose that. Let's say I wanted to choose here AWS, then it's going to choose for the target is Microsoft SQL database, and I need to fill the online as a create a project, and then I can do here either project automatically, or premium SKU is to be created, but I have not created as premium, so this is not this service is not available. So I can choose here SQL to SQL, and then I can simply run this by giving a project name SQL to SQL. So you need to go to this website and whether this is really supported, what is the path, and then I need to go to this specific service and SQL to SQL, and then I can type here. So it's going to actually create that specific service in a minute. What's going on? Sorry. It's going to run that. So SQL to Azure SQL database, it can migrate. So it's going to be a new project, and I onboard once the project, then it might ask me to build a portfolio kind of thing. What's that SQL server is, where it is the source is available, and whether you're going to authenticate with the SQL or Windows authentication and the target, and you can map the database, and you can complete the migration. So this is how you're going to actually use the migration services which are available on the database migration specific. I hope this is useful for you. Thank you for watching this. Hello and welcome back. In this short lecture, we will be learning about Azure Marketplace. A marketplace is very similar to your Google Play Store, or you take it App Store on your iPhone or Mac specific. So what exactly Azure Marketplace is. This is where they are gonna, the vendors are not just the vendors, even Microsoft also uploads the developed applications or maybe services which are available in the marketplace. So you can simply go ahead and use them. For example, if you see here, if you just go and open Azure Marketplace.microsoft.com, this talks about your infrastructure as a service specific firewall. For example, what it's going to do is it's going to actually create the threat protection for your entire services. So the firewall which is you use normally on your on premises like Checkpoint, now the same service or the same appliance also available within the marketplace. So you can configure that kind of configuration so that you can use it. For example, Sophos firewall, so this can be used to configure on your marketplace so that you can use them. Similarly, we try to use some of other products like SQL Server or some other things. You can always use these marketplace. So if you see here this video, all the close to thousands of applications, maybe if I'm correct, the number close to 10,000 plus or 8,000 plus different products are available within the marketplace. So all these products can be used here. You can give a try and you can try them. Some of them give you as a test basis, some of them are available on a free trial, some of them are you're gonna buy it. So like that, you can use those products and you can configure the way you want it. Let's say I can search for the SQL example, simply SQL specific. So you see here SQLite is available from Microsoft and SQL Gate is available. So all these are the options that you can check out. Now you can check out here, see if I search it, Azure SQL Analysis Service is available, and this is the Redgate SQL Monitor is a third party from Redgate software which will monitor my SQL Server which is available. So if I want, I can use it, and this is how you just simply buy it from marketplace, and then you can integrate with your services. So that way it would be very useful when you're looking for any of the services you want to extend and introduce into your cloud services. So if you are the developer, you can also create your own application and you can upload to marketplace so that people can buy it. So you have here the categories, you can choose it. For example, we had a look on most of them are the security specific like Checkpoint, other things, but if you are looking for some other space specific to computing, you have these services which are available like SQL on SQL on Ubuntu 1.6.0 build. So this is not not by default. So Microsoft is offering this build, and this is the similarly Scale Arc from for SQL Server is available for free of cost, and they might give you as a free, but later point they might ask you to pay if you are trying to use their premium services. So you have many options. So for example, if you are the developer, if you have some kind of or developing thought process, you can develop specific to any of these Microsoft specific products and can be hosted. But this entire course is specific to what is available and you can use it. Let's say you can use a DHCL specific one and you can integrate with Azure AD to access DHCL services and then get it benefited. Similarly, SAP, all that. I hope this is useful for you to learn more about Azure Marketplace, and you can filter all these options are available. You can give a try on this. Hello and welcome back. In this lecture, we will be creating our first virtual machine by using step-by-step guide which was provided in this lab. So in this lecture, I did created a step-by-step instruction how you can use it to create a first virtual machine. But before if you have already created, well and good, you can skip this. But if you have not yet created, let me explain this and let's proceed further so that you can create on yourself. the first thing is how this virtual machine is working. So the virtual machine is Microsoft data center. That means you are in using internet either with SSH or maybe RDP you use here, and you would connect to virtual machine. To connect to the virtual machine, you need to have a public IP. So we need to create a public IP, and all these resources or all these objects will be inside the resource group. So the first thing we need to create is a resource group. Once we created a resource group, we would be creating the virtual machine. But virtual machine, definitely it needs to have one of the subnet and vnet, and also the disk and the image, and also definitely NSG, that is network security group. So network security group is a firewall. It's not the inside of the machine's firewall. You see here in the diagram, it is outside of the firewall. That means whatever the traffic is, it is coming from either from public IP or from the internet to the machine. It is the firewall which will filter based on the inbound rules and outbound rules, and it will allow and disallow the traffic either inside or outside of the traffic. So the NSG is a key here, if you can look at in this entire diagram. So what we're going to try is, now I will be opening this link which we have already been trying to talk about this step by step so that we can do it. So the objective of this would be to create your virtual machine first, and after completing this, you should be able to know how to create your first VM. So all I have to do is I have to sign up with portal.azure.com. Once I logged in, I should be able to see here resource group. If you're not able to see here, just click on this three dots or three lines. You would be finding here resource group. Click on the resource group and click on add button. That would actually create a resource group. Give a resource group name as Azure AZ-900 v2. In this case, I can create here and choose a proper region that you wanted to choose. So in my case, West US 2, click and create. So either I can create in this way, or if you look at the documentation, what I said is create a virtual machine. So simply click on virtual machine and you can choose here the add button. So what I'm going to do is I'll just go here, click on here virtual machine. If you don't find, go to all services and look at here under computing, virtual machine, add, and you can create here any of the resource group we just created as a dedicated resource group. If you are if you want to create another resource group, like maybe a v3 example, simply create this and enter the value so that it's gonna actually enter that resource group. Now you see here under resource group, if it is already pre-provisioned, that's fine. If you don't have, you need to create like that. And virtual machine, coming back to the virtual machine, you can see here, give a meaningful virtual machine name. Like I can give here the name as AZ-900 VM demo. That's a name I wanted to give. And I can choose here the region which I wanted to place. So in my case, if I'm comfortable, I can go for US West, US 2. And you can choose your region where you wanted to have. And the image, I can choose here as Windows 10 Pro 1809. And you can check out here standard D2V2 version of the virtual machine which is going to create. So if you are interested, you can change other purpose of the VMs based on your requirement, like VMs purpose, for example, is a standard or basic or family. If you can see general purpose of the VMs, these are, some of them are memory optimized, high performance. So if anything is grayed out, it means that it's not available in that specific region, and you can check on the required VMs and you can create it. So in our case, the default one, D2V2, I'm gonna take it. So D2V2 standard with the 2 virtual CPUs and 7 GB of the RAM, I'm going to charge around $5,000 per month. And then I'm going to give as the username here as Udemy admin. I'm going to enter the password here. So which is a password as here 123456 and shift 1 as a demo. So now if you can see here in this virtual machine, you can check the public inbound ports to allow. That means you are able to allow the network ports as per our PPT. If you can see here, so in this NSG, you're opening port 3389, which is the RDP port you're opening. That means any request comes to this public IP, it will forward to this machine, which is a private IP within this network, within this subnet. But here there is a rule gets created. So I'm going to show you that in a minute. And if I click on next, it's going back to the disks. So here I can choose here the disks which are a standard HDD I can choose, or a premium one. So when I choose a premium, it's gonna actually, whether it is supported or not, you need to find out. So in my case, this basic VM does not support it. That specific D2V2 specific one is not supported this premium. So I need to change to only standard HDD. So then it is supported. And click on OK, which is next, which is the networking. This is where it's going to create your virtual network, also your subnet and your public IP. So it's going to create all these things. So if you can locate this PPT here, it's going to create this VNet, and within that there is a subnet is going to create it. And also you see here, this is the VNet virtual network, and this is a subnet it's going to create, and also public IP it's going to create. So that's why these three things are getting created automatically. That means from here, subnet, VNet, public IP, which is going to create it here. And also you are enabling 3389 port for accessing from your internet to inside your machine. And click next, which is a management. So your subscription is fine, and you can locate the boot diagnostics and other things if you're interested. And also you can schedule for auto shutdown of this VM. Let's say you wanted this VM to be automatically turned off based on UTC time zone or any other time zone which you prefer. Based on the time zone, it automatically shut down that VM so that you can save your cost. Now, before shutdown or before deallocating, it can also send a notification to your email ID if you are interested. And click on Advanced. You can create here generation of the VMs, either generation 2 or generation 1 based on it. So when you choose a generation 2, it's gonna have more security that is based on the UEFI mode. So that's all. And you can add the tags. Tags will be useful when you are looking in terms of the billing purpose. You can easily analyze what kind of tag was assigned to this resource, so that you know that this specific resource from this business, and you can easily understand the billing happen against to that specific business unit. And you can simply review and create. That's gonna create automatically this VM. So I'm gonna click on create. Here it's gonna validate everything. Now create. I need to wait for a minute or so to automatically create this VM. I'll wait for a second. The deployment is completed. Now I can go back to the resources, which is that specific VM, and you can see here the performance count has been already started. That means the VM is completely up and running. And also you can check out here the public IP of that specific machine and the private IP. And if I want to connect, I can simply have to click on connect and simply download that RDP file and press Ctrl G if you want, or simply click on this file. It's going to ask for the username and password. So I need to here enter the password that was given on this machine. So I'm going to enter here the password which I have shared, which is Azure123, and the user ID. That's going to ask me a normal certificate specific. I can click on yes or no, that's fine. And it's going to connecting to that specific VM in a minute. Now the VM is connected. It's just started with the networking settings. That's okay. I can ignore those specific settings. And you can check out here the Windows 10 1809 mission has started and it is available for us. ipconfig. You see here it's 1809. And the IP address is this. So if I just go back to the portal, and you can check out here the private IP is same. Before we actually shut down this virtual machine, that means we can do the shutdown from here, or we can do the stop. That means it's going to shut down and then it's going to be deallocate. So when you deallocate, the processor power is not with you. That means you will be only paying for storage, not for the CPU or memory power. So minimal charges would be applied if you click on stop button. That means if you shut down here, like say if I just go back here and shut down, it doesn't mean that it is not deallocated. Let's see, if I just shut down here, it's not yet deallocated. That means it will just go off, but the virtual machine will be in a still dedicated the CPU power and the memory power to you. So that means it's not deallocated. So you need to deallocate the specific resource. It will still show you as a running only status. So you might have to change the machine to stop state. That's how it's going to actually stop completely, and that CPU power and the memory power can be assigned for someone, so you don't need to pay for that. So if you see here, still it is the stop state now, but it's not a deallocated. You see the VM is in stop state but not deallocated. So if I just click on stop, you see here it's gonna the reserve also IP also gonna change it. That's okay, because I don't want to stick that public IP. So it's gonna actually stopping the VM, which would actually deallocate in a minute or so. And if you see, it is successfully stopped and the status has changed to stopped and deallocated. And that means we are not gonna build for the machine. That means the virtual machine is CPU, and whatever the static IP, if you have not assigned the static IP, it's not gonna released and it will be with somebody else. So the public IP also it's gone and it is not with us because we have not reserved. So let me show you, talk about the network security groups. So under networking, if you see here, these are the rules that were created for network security group. And you see here, this is a priority, and the lowest priority was created for the port 3389. If I have deleted this or modified, that port will not be available. So if I want to create any of the inbound ports, I would be saying explicitly, and from this IP to this IP only the ports are allowed. For example, let's say on that machine, if I have a HTTP port wants to access or the web services is installed, I would give here destination port is IT and the priority, and I would say here port IT specific, and I would simply from any source, any destination, and the destination should be only the port IP range with the IT. So if I just click on this, so it's going to actually create a rule so that the virtual machine can be accessed if that machine has any of the public IP and that has any of the web services. Over that public IP, I can access that web services. That's how it's going to work for creating. So that's the advantage of the network security group. So within this network security group, you have the inbound security rules as well as the outbound security rules. So in my case, outbound is completely allowed. That means the traffic from virtual machine to internet is fully allowed. If you want to block, you can restrict even not to have the internet. And similarly, if you have just the one network card, you can have. If you want to have multiple network cards, you can create here some more virtual some more network cards and can be assigned to this virtual machine. And these are the subnets and other information. And if I don't want this machine to be not to be deleted, this entire virtual machine, I can set up a lock. So when I configure a resource group level lock, or here a lock which is going to be just the read only, that means it's going to be only set for the read only, and click OK, that means I can't delete this objects, anything have specific to virtual machine. In that way I can do it. So we have deleted, we have deallocated. Now we are gonna delete this machine so that I'm not going to be charged for this machine. Make sure that if you delete, that means the resources completely goes off and you don't need to pay for anything. So once you have completed, you can delete the resource, or if you want to keep it, you want to keep it, but make sure that you deallocate it so that it's not going to charge maximum charges. It will be very limited for your storage, charges only will be applied. I hope this lab is useful for you. Thank you for Hello and welcome back. In this demo, we would be trying out the lab which I have given to you to try out in the previous lecture. In this lecture, we try to create virtual networks, and we also add some of the subnets and also create the network security group with an exception adding port 3389. And that concludes our lab. So let me explain here within this diagram. So as a first step, we would be creating a resource group if it is not existing already. Inside the resource group, we would be creating a VNet, which is nothing but a virtual network. So within the virtual network, you would have your subnet. So in my case, the virtual network, I'm going to create 192.168.0.0 by class C, that is a 24 address. And within this, I'm gonna create a subnets as two of the subnets, each one ending with 26 and 28 subnet. And these two subnets I'm going to associate it with network security group called NSG. So this NSG will protect if anybody is trying to access these resources within the network, it will block. So to make an exception for either SSH port or maybe for the port called 3389, we would create a rule so that the exception will be allowed to access from outside to inside, and it can access that specific resource, or within that subnet access is granted. So that's the high level of the plan. Now I'm going to open up my portal. If you have already not opened your portal, you can sign in by going to portal.azure.com here and enter your user ID password and click on three dots, and you have here all services. Within this you have networking, and click on virtual network, that's VNet in short. So you have here already existing few of them. So I'm going to create here new virtual network. Click on add button. That would actually populate a new blade for you. Now you can enter here, give the meaningful name. So in my case, as per the documentation, I'm going to give as a VNet1, and then this is the information which is already populated. In your case, it might be populating 10.0.0.0, but in my case, I have already subnet with a 10 series. It's not populating. So what I'm going to do is, in the lab, I have given you as 192 series, so you can use other series which is 192 series. So simply 192.168.0.0 and then class 24. So here it's going to create 256 IP addresses. That means within that network you can have 256 machines can be provisioned. Now do you want to create any of the resource group like this? So within this you have 256 machines can be there, or any of the objects that can assign 256. Now this is a resource group, so you want to create any of the resource group so that it can associate it. So that's what I'm trying to say here. I can say that here I wanted to create a resource group here, like create new, and I wanted to create here as a demo resource group. If you have already a group already, you can use it, but in my case I'm just creating so that later point I can easily delete that specific resource group so that it makes easy for me to clean up. Now as a next step, I need to choose the subnet, definitely. So within this, what is the subnet you want to choose it? So you can check out here, it says that I need to give within this range. So that's why in the documentation I did mention to give as 192.168.0.0 by class 26. So now within this there are 64 computers can be connected, or maybe 64 different objects can assign the IP addresses. Now you can leave all this firewall and other things and click on create. That would actually create a VNet1 for us. Once it's created, it's going to populate for us so that we can check out within the virtual networks. At this point of time, if you see here, virtual networks are only demo and NSVNet1. Now it's going to populate VNet1 also in a minute once this is submitted. So in my case, still the deployment is in progress, so it takes a few minutes here. The deployment is progressed, so I can simply refresh here so that I can able to see here the page. Let me refresh the entire page. It should come up. VNet1 was created under resource group, demo resource AZ-900. Now as a next step, I would be clicking on Hello and welcome back. In this short lecture, we will be trying our lab to create a blob, that's a storage account. Within the blob, we will be uploading some of the files. So to begin with that, you need to open Azure portal. Within the Azure portal, once you signed in, click on All Services. From All Services, you can look for Storage and click on the Storage account. So when you click on plus add button, that's going to create, it's going to populate the values to create a storage account. If you already have a resource group, you can select it. In my case, I have already resource group called demo resource AZ-900. If you don't have, click on create new and create it and click OK. Now I'm gonna enter here the capital letters are not allowed to take the Azure storage account name, so I need to enter here only the capitals. Let me show you here by entering the capitals. It says that a lower cases only will be allowed, including the numbers, and these text must be a unique because it will be accessed over the internet. So let me give you AZ-900 demo. It's already taken by someone else, so I'm going to give as the adding 2 more characters here like PA, and that would actually be should be a unique. Yeah, it's a unique, and I have a tick mark here. Now I need to choose the right location of my storage account, because in that storage account the data would be copied. So we need to choose the right storage account, and the performance specific, we did talk all that like a standard and premium with the SATA as well as the SSD performance specific things we talked in the previous demos or previous lectures, especially into the storage account specific section. And also we talked about the access tier like cold and hot and the pricing models also. So we would leave as a default here, and we click on the networking, or we can click on review and create. But I'm going back to the networking, and you have an options there, public and private, and choosing the default options here. Also the security transfer required and tags, all that I'm going to take it as the default. You can review the configuration. If you're interested, you can read these kind of text. It talks about the SMB 2.0 and 3.0 specific, which talks about the without the encryption. If you want to allow, you can allow the radio button, and here you can enter the tags. The tags are specific to the building specific, but we are not entering any kind of tag information. So I'm gonna review and creating, and click on create button. That would actually validation is passed. Click on create. That would create the storage account. So it takes the process. If you see here, the deployment is already submitted. This might take some time to complete the deployment progress. You see here there's nothing now. The dots are moving like your deployment is underway. Now in a minute or second, you see here the progress was changing to the refresh button, and now the deployment is completed. Now go to resource, or you can go back to the all services, again storage, or if you don't find in the storage, you can click on all services and storage. If not, go back to storage all, and then choose here not the computing, not the networking, just the storage. So you can choose as a storage. So you see here in the left side also available, and now within this is the account. It has just created AZ-900 demo PA. Now under settings, you can see here containers and the amount and also the account type, all that has been there. Now I'm going back to the blob services. Let me go to the blob services and click on containers. That would actually open up my container information, which does not have any information. So I need to create a container by clicking on plus container and give the name as container1 as per the documentation provided to you. I'll leave as the default settings because I don't want to allow private access with anonymous. So container1 is created. Now within this, you can check out the sample files, or your own computer files can be uploaded into this. So click on there the files and simply upload the AZ-900 sample files.zip, which contains 2 files, one PDF, one text file. I can choose even hot tier or cold tier. So it's just uploaded, and this window would automatically close, or if not, I can close it. And now let's go to the how to access section. So to view the files in the blob container, you can if you think that it can be accessed over the HTTPS, it's not possible. So simply copy it and give it a try. Let me copy that and open in a new tab. If I try to open, it says that XML file does not appear to have any style information. But when I actually click on the above download button, it's going to download for me, and I can double click and open the files and see what is there inside. And I have my files inside, like text file and PDF file. So that concludes this lab. You have successfully completed hands-on lab. I hope this is useful for you. Thank you. Hello and welcome back. In this section, we will be learning about Azure solutions. You may be wondering what's the difference between Azure solutions and Azure products and Azure services. Well, if you can think of Azure solutions in two different ways, like one would be there's quite a few of the solutions that are made up of different Azure products and services, and they are just bundled in such a way that it's a lot easier for us to consume them as a single unit or one unit rather than a multiple individual products. Now, other way you can think of Azure solutions are in a case, for example, let's take one example as a serverless computing. And when you take the serverless computing, where we will be looking at functions, logical apps, or logical gaps, and even grades, these all are individual products. And but the concept out of the Azure products and the services are even it can work with the third-party services in that capacity. It becomes as a gap between whatever the gap is there for that, it becomes as a bridge, and it helps us a much simpler way, simpler interface to manage and consume, and you can actually manage without our own products to have, so we can extend that services as an individually if we want to take it. So we can think of Azure solutions as these pre-packaged, usually multiple different products that are made up in such a way that they are much easier for us to consume as a service model. Now we can think about Azure solutions. So let me talk what are those solutions we can talk about. So we can talk about around close to 5 different concepts that we're going to exploring in this section, and the more depth over the upcoming lectures. So we will start beginning with Internet of Things, IoT. So within the IoT, we will because the IoT will have the two different things within this solutions. One would be the IoT Hub, which is a messaging backbone of the IoT offerings, and this messaging services let us send two-way or bidirectional messages both to and from our individual devices that make up our Internet of Things. Then we will take a look at IoT Central solution, which is actually built on top of IoT Hub, and IoT Central is the software as a service servicing offering that provides us an even lower management and administration for our IoT solutions. Then we will look at the big data specific and the big data analytics, and we will look at solutions like Azure SQL Data Warehouse, which gives us a relational database model on which to build out a big data storage and mining and analytics can be run on it. We'll also take a look at HD insights within this Hadoop, which is a Hadoop based one, and the open source based systems, which we can use various languages and tools to use within the big data analysis to analytical purpose. And finally, we will take a look at Azure Data Lake Analytics, which is a proprietary of Microsoft offerings. And we'll also look at Azure Insight. Data Lake Analytics works off of any Hadoop based file systems like Azure Blobs, Azure Files, or maybe Azure Data Lake Storage, and Data Lake Analytics gives us one simple SQL like interface to use to make our analytics jobs easier. And we'll also take a look at artificial intelligence solutions, that is AI in short, sometimes we call it. And we will first start by looking at the various Azure machine learning services Hello and welcome back. In this lecture, we will be looking at Internet of Things a little bit more. What exactly Internet of Things? To understand better, we can go with this definition. It's a solution that's made of one or more devices and they all are connected with one or more backend services running in the cloud and everything communicates with each other. So in other way, these all the devices are outlying pieces around the cloud and they could be, for example, appliances in your house, or they could be lighting in your house, or video games, or cameras and recording equipment. They could be even be in aeroplanes and automobiles. There could be tools or equipment or fans or air conditioning units or security cameras. I mean, there's a really huge range of devices that we could be talking about here. And what all these things have in a common is they all communicate, and not just communicate to backend services, but they also do two-way communication. So the backend and the services can also talk to each of these devices. Let's actually go to the Microsoft page and better understand by taking some of the examples here. You can have, if you can read, these are the examples, backend services, some of the examples, and all that has been clearly documented here. Let's take one of the example and try to understand a live example. For example, on a remote oil pump, there might be pressure sensors along with all sections of equipment, so they could be monitoring of any increase within the pressure. And also we talked about two-way communication. So if the back end service monitoring all these pressure sensors notice that the pressure is too high, they could send a command to the device to actually shut down a section of pipe. For example, with that two-way communication, it actually facilitates a lot of actions that can do on a remote device just through messaging. And also common in sometimes, in fact, the entire businesses are built around the model of putting sensors on air conditioning and heating and refrigeration units, so they can be monitored and the staff can be alerted in the buildings before it's actually noticed that the air conditioner might go out or a refrigerator might go out. In fact, a lot of restaurants do that in the real world. They have sensors on their refrigerators and their air conditions and things like that, because if your refrigerator goes out, all of a sudden it's a bit odd for them, or it's a lot more expensive to close down the entire restaurant versus noticing that there's a problem beforehand and getting it fixed before it makes the whole restaurant goes down. And you might look at the security equipments like rooms, like cameras, motion sensors, or floor sensors, things like that, if you need to protect facilities. And likewise, with the two-way communications between the devices and backend systems. If the device picks up an intruder in the room, the backend services might decide to tell the sensors to lock down the room, and that command might be sent to the motion sensor that picked up a person in the room, or it might be sent to a different device that has a capability to actually lock down complete room. So you can see just in few examples what we could do, or what could we can build out of Internet of Things solutions, how the devices in the backend services can communicate two-way of each other. And we have defined what exactly the Internet of Things as of now. I hope this is useful in terms of the defining Internet of Things. Now let's have a look on actually Internet of Things in Microsoft Azure more detailed. The first one would be to we need to now look at the IoT Central. So this IoT Central is a fully managed software as a service solution, and so we can easily connect our devices to monitor them and manage them. We can configure where to save all data that our device is sending to us. So that's where the IoT Central comes into the picture. And now we can also configure to act on that data and how to communicate back to devices when we can do all these kind of things in a visual workspace. In fact, it's a web page that we can do it through within the Microsoft Azure portal. So this IOC Central is within the Microsoft Azure portal, and it provides us the drag and drop visible or visual experience where you can build and test the deploying all of that IoT solutions without writing any code whatsoever. And it's IoT Central is a fully managed software, as I said. It's a managed service as a service solution, and that enables you quickly and easily connect to all of your devices that runs out into field and configure how to monitor manage all these data into so that we can collecting that data, or we are collecting that now. And underlying IoT Central is actually a second solution that we're looking to add called IoT Hub. So IoT Hub comes under IOC Central, and we would be now looking into the IoT Hub now. And this IoT Hub, let's talk on that. So when we talk about the devices and the backend services communicating with each other, IoT Hub is usually one core Azure messaging service that's being used behind the sense of IoT Central. And our devices will send the messages to the IoT Hub that the IoT Central solutions will then manage for us. And likewise, when IoT Central decides to send a message to device, it's sending that message through IoT Hub back. And IoT Hub is the core messaging service that's used by IoT Central. Or if we wanted to take more hands-on approach, we are able to also directly use the IoT Hub and configure our devices to send their messages there. And we can configure our backend services to read all the data that's being sent through IoT Hub. So this IoT Hub is allows us for the bi-directional communication that we talked about earlier, being able to send and receive the messages to the devices, and it does in a secure manner, and it extensively extremely scalable as well, and it auto scales for us as a PaaS solution, a platform as a service model. That's we know now what kind of model we can opt it, and we can scale to millions and millions of IoT devices very easily. And there are other Azure products and services around the Internet of Things, but IoT Central and IoT Hub is the core as far as the examination, or as far as the exam concern, or the most used services from the Microsoft Azure IoT things. And you can look at here the device support. All these are the devices are supported, and also the IoT specific IoT Hub and IoT Edge. You have a Azure Time Series Insights, Azure Spare, and Azure Digital Twins, Azure Maps, IoT Hub devices, provisioning services. All these all falls into IoT, and also you can go for the data analysis, analytic, and visualization and integration with the help of Microsoft Flow or Logic apps like functions and other things can be used, so that it becomes as a PaaS model. At the end, this is the chart for the IoT technologies and the solution specific. I hope this is useful for you. Thank you for watching this. I'll see you in the next lesson. Hello and welcome back. In the short lecture, we will be learning about big data and analytics products that we use within Microsoft Azure. And we will be taking a look at big data and what exactly it is, and what's the difference between these various solutions within the big data products that are available within Microsoft Azure. So let's jump into it. What exactly the big data? If you're maybe wondering what exactly the big data. Well, to answer this question, in this slide I will be explaining in detail how data is growing from megabytes to terabytes and petabytes even, and which explains about the big data a little bit more. In the real point would be the real point would be the using the term big data. We have a lot of data that is growing up from the last 15 to 20 years, and it's becoming cheaper to store huge amount of data, and lots of companies are using and realizing that the more data they collect and store, more information they have, more getting to know about their customers, buying habits, and things like that, the more money they could make it out of it. And that's a trend nowadays. It is for almost any company to store as much as possible information they would like to store it, so they can look over it later point to try capitalize on it some way. Let's understand, how they're going to capitalize in some or other way. At a very simple level, if we took this data that we are storing for the company, example in this section, you see that some data based in the company that they wanted to store it, for example, for payroll and our inventory levels, or maybe for the sales contracts and the sales pipelines and things like that. And they generally doesn't get to be too huge of any amount of the data unless you require a big company. But even then, it's a pretty manageable size for any of the company. But on top of it, the companies also started looking at storing data related to all aspects of their e-commerce websites, looking at all the pages for a user visiting before purchasing a product. So the company eventually determines if what is going on their sales, and what page makes more happy for the customer, what page maybe customers have a challenge to fulfill their inputs or something like that, and they can query later point, so that would helps them to dig that data to see if there is any trends to be found within the user activities, how they correlate to purchase, and so forth. That explains they wanted to store lots of data for their sorting purpose. For example, in our last session, we talked about a sensor-based data which is coming in Internet of Things. It may be commonplace in a lot of places now to retain all the sensor information that's being sent continuously and save it for permanent basis. Audio video companies, for example, audio video specific media based business, for example, they might be saving data and video files, and those can be add up a huge size very quickly as well. And some folks may even be looking at say market conditions like weather data and weather conditions and things like that ongoing basis, to try later eventually figuring out if maybe weather or stock market or maybe things like that had any impact on their business or maybe on their sales. And so what exactly the big data really represent is ability to store megabytes or gigabytes or terabytes or even petabytes of the data, and ability to query to get the results back in somewhat reasonable amount of time. Now, it may be if we are trying to search against millions or millions of gigabytes, but we would expect some response back within a reasonable amount of time. And so that the big data really is it's a platform for us to store this massive amount of data, as well as to query it and get the results back to gain insights of what exactly inside of these data. For example, we might have some line of business applications like a shopping cart. We might have some internal applications too that are sending us data that we need to save, like CRM systems. So we might have even maybe census data or maybe social media data that we wanted to save, data from various devices in our Internet of Things solutions. And so all of these different applications and the data sources produce different type of data. And this data at the end we wanted to either save it, or sometimes we wanted to just classify it and run against of that data immediately, like by doing the preparation or maybe analytics, doing that, and we wanted to get the visualization information, or we might to save the data temporarily or permanently. It all depends on our business case, but just to give you an idea, these are all the possible options what we wanted to do it in the big data design side. Sometimes is to store this data temporarily or perform some kind of operations on it, or kind of consolidate the data when you wanted to store permanently somewhere else. Maybe we can talk about the storage, the main Azure products that we can use for storing within the big data solutions or within that design. The best candidate would be the data lake storage, but we can also use the SQL data warehouse and the blob storage. But these kind of data, the best case would be the data lake storage. That would be definitely easily it can match, and it can be very useful when you're trying to do some kind of analysis on top of that specific data. Millions of IoT devices sending the data, like weather data or maybe forecasting or flights information, or maybe IoT devices sending a lot of data. Think that in that way you might want it to aggregate a lot of that data together and make some metrics. For example, you might want to take maybe 100,000 records that came in one day from IoT devices and just keep a single record at the end of the day to various count of certain things that might be happened, because we don't want to save all the things, except just wanted to trigger that specific event and that wanted to store it. So also you might wanted to apply machine learning and analysis within against to your data and get back some kind of results that machine learning can predict, and that is the way to say that you wanted to run machine learning. So you can anticipate what future behavior will be based on current existing data that we have today. Really, there is a whole swell of things we can do our data once we have stored it. In some cases, this is not always the case, but in some cases, once we have run our analysis and queries, sometimes the folks wanted to set up data warehouse which will save the results for our analytics and queries and save them to a relational SQL data warehouse where we can eventually serve those to some internal applications. For example, just to show as a dashboard, all the data is consolidated or aggregated away. This kind of generalization diagram, not every solution will follow this flow, but this is a kind of gives an idea how big data flow might work and how we would take it in a gigabytes and terabytes and petabytes of the data that within the analysis and capacity of a kind of data mine and to learn about trends that are within the data. This is not a mandatory architecture that would flow, but it all depends on our business case and our current design. But it gives a kind of an idea how the big data flow might work and how we could take in gigabytes or terabytes or petabytes of data and use within our analytic capacity to kind of data mine and learn more about the current trend and future trend based on our analysis from machine learning and other products. SQL data warehouse is a relational database of way of approach for the big data and analysis, and it uses massively parallel processing. Exactly, it means that if we move to the HD inside here, Hadoop or HD inside, what it does is it will do the parallel processing. It does the parallel processing. So HD Insight is actually an implementation of open source framework called Hadoop, and Hadoop is the distributed processing program that we can use for analysis of the big data, and it works on a cluster of servers, works by using multiple different nodes to perform the same work against a subset of total data, and that's a kind of heart of massive parallel processing power. And so let's think that if we had 10,000 math problems to do, would it be more effective for one person to go through each of the 1,000 math problems to do them one by one, or would it be faster if we can give that 1,000 different persons these 1,000 problems and they record their answers? Well, The second one is a really highlights how massively parallel processing works by splitting up the problem into multiple different workers, and we can have all the workers running the same time and perform the entire operations against of all of that data in much quicker way. And that's exactly how Azure HD Insight works. And that's exactly how SQL Data Warehouse Analysis Engine works as well. What they do is, since we have so much data, even petabytes of data, if we need to run a query on within our Azure HD Insight, we can tell how many machines we want to have running this kind of data or this kind of query, and each of those different machines will be running in the same work. They will just be targeting only a portion of total data, and when all of these workers are done running on this cluster of services, some management layer of HD Insight will then aggregate all the results together and present it to the end user as a unified result over the entire data set. And by doing this, it gives a very easy and fast and cost effective way to process massive amount of data, especially if you think in terms of if we had a one time job to run, and we could quite easily just run up 100 or 10,000 or maybe uh, more of the processes their own portion of work, and within a minutes or hours we could have even some gain jobs finished, because we have used a conquer and divided method of splitting out all the work to variety of nodes and working within a single cluster. And so that's kind of how Azure HD Inside works. That's based on open source of Hadoop. Hadoop is the open source tool that we would be using for analysis of this kind of mechanism, and lets create a big data analysis job in a quite easy way to give you ability to work against a massive amount of data. And similarly, Azure Data Lake Solutions does that as well. Now, Azure Data Lake actually represents two different products. There's a storage product which we talked about earlier about Azure Data Lake Analytics, which we can operate in much same way as Azure HD Insight. Now the difference is with Azure Data Lakes is that it's more managed service. It does not have to configure our HD Insight or Hadoop clusters. All we have to do is to easy web portal to create our jobs within Azure Data Lakes and run them, and then we can view the reports directly. It's definitely more managed service, and it's on-demand job analysis service that we can run against our big data. And it's just like HD Insight, and it also helps, and it also makes our to develop and run massively parallel data transformation and processing programs over petabytes of data. And since it's more managed service, the benefit for us is that we can process the data on demand, we can scale instantly, or and end of the day we only have to pay for that specific job we are going to run, or we have run that specific job. And both of this Azure HD Insight and Data Lake Analytics is a great options for you to query your big data store and get the results in a cost-effective way. The choice is yours, as you if you want a less managed and more customizable platform, as well as that works with the variety of open sources tools and frameworks like Azure HD Insight, or if you want a more managed approach that gives you simpler mechanism for querying and doing analytic jobs or petabytes of data, which is Azure Data Lake Analysis, can be used. And the choice is yours, but I hope this lesson helped you to clarify about the big data and how analytics play into big data and various Azure solutions we can use to facilitate big data and analytics solutions like SQL Data Warehouse and HD Insight and Azure Data Lakes. Thank you for watching this. I hope this is useful.
Hello and welcome back. In this lecture, we will be looking at artificial intelligence and machine learning. Machine learning
has become very popular lately, and for good reason. It can provide a lot of insights into your data that you would otherwise miss if you are looking over it yourself. And a large portion of what is called artificial intelligence, and it's really just based on a machine learning. Let's understand what exactly the machine learning is really. It's a data science technique that allows computers to use existing data. For example, here you see here data would be collected, and it would be use this existing data, and then it can be predicted what would happen in the near future based on the inputs which you feed for the machine. That's why we call it as a machine learning. So we feed the data and we make the machine to learn here, and based on the patterns it would give you in near future what would happen. For example, if we take it example as what would happen for our weather forecast, or maybe future sales for a company, or future customer patterns, things like that. But it's using existing data and finding the trends in that data to predict what might happen in the near future. And one of the key differences on machine learning is that computers learn without being explicitly you need to program it. So for example, in traditional programming, you write what would happen if case, else case, where case, like if days it's coming so much of hot of that weather, then switch on this and go for trigger this event. All that has been no more. It's just predicts based on the current existing data, and you can easily program it like a drag and drop, which I'm going to talk in a bit, where you have two different mechanisms which can be used within the machine learning, which I'm going to talk in the maybe upcoming third or fourth slide it would be. And one of the key skill for the machine learning would be, instead of us to making a bunch of rules to say, hey, sales go up when this happens, or when this happens, the machine uses that, or instead of a machine learning programming will do, or it will go through the existing data on its own, and it will find that pattern in the data, even patterns that we ourselves may not even seen without being explicitly told what to look at. It will start and correlating patterns to potentially sales or weather changes or whatever your application is doing, and it can start a kind of learning on its own how to find even more things like that based on your clean data. In addition, the advantage would be we don't have to program with the rules ourselves. We just have to give a good set of input as a data and the output of the data as a sample data, and the machine would start learning on its own based on its program, and will start understanding that those rules and keep the track of them, so it knows how to apply them in the future, and so that it can give some kind of value for us in the near future based on our current data. And in this, when people say that computers can learn without being explicitly programming, that is what we are talking about now. Basically, the programmer does some kind of a program by using a pattern recognition and things like that to kind of gain a better understanding of how to pluralize words without us telling it every single rule. Once we have gotten our machine learning program to be the way we want it, the final output from our machine learning program is going to be what's called a model, we call it. So let me show you that in another way. So what we have done is, here you see here, like we are training the we are actually creating a process flow, like we train based on this data by creating some kind of a package and validation of what we give the inputs and what kind of an output is here it's coming up. And once we validate it, we actually deploy it and we monitor and we retain that package, and again if really needed we can go for one more trial of training of the existing data. In this flow, it would only go to the next time if the output of the data is not coming properly. We would add those changes and we train and we feed there, and so that it would be added to the next layer, and it would knows that what kind of output to be given in case if such kind of data would coming, or such kind of pattern is coming up altogether. And these things, in fact, once you build this, you can actually put it into Azure Marketplace and you can sell them. Let's take one more design and try to understand this. Is one of the machine learning in a production, if you're trying to do, or if you're trying to learn 101, like you have historical data and you want to train against this data within your machine learning, and you have deployed this on a live or in a production, and you can predict what would happen, either the sales or maybe weather or stocks, whatever the business service. Based on this data, it would actually, whatever you feed it as input and the output, expected output, based on that it actually predicts and gives the information. So I hope this makes easy for you to understand about the machine learning services. Now let's understand what are the types we have within the machine learning. I hope this has been clarified the basics of the machine learning for you. There's obviously a lot more to do it, but that's kind of a general flow what we have seen here around 3 different slides. Now we are going to take a look at 2 different solutions that are available from Microsoft Azure, and the first one would be the machine learning service. So what exactly this machine learning service? It's a cloud-based environment that we can use for the preparation of our data to train and our models to test and deploy and manage track of all the machine learning models across within the Microsoft Azure. And also the machine learning services fully supports open source technologies. There are tons of open source machine learning components that are available for us to use it. All we have to know is the Python language, because mostly they are programmed with the Python language. Either way, these are the services offered as a PaaS approach, which is a platform as a service model, in which we can work on top of this platform and with the other open sources technologies to customize our applications and tailor them the way we need to use them with various machine learning components. The machine learning services is a great if you already know the Python, as I said, because the Python is a language that usually used within the machine learning. Or if you want more control over the machine learning algorithms, or maybe you wanted or you need to use other open source machine learning libraries, the machine learning services, which is the PaaS service, is the ideal choice if you're trying to use these kind of scenarios, and if you're trying to customize the ability within our machine learning models are great. And the second solution would be SaaS based solution, which is the again the machine learning studio here, which is the software as a service model. Unlike the machine learning services, there's a just set of components that we are going to use and build our own solutions at the end of the day based on the machine learning studio. And with the machine learning studio, it's as I said, software as a service environment. In fact, it's a web-based workspace where we need to build and test and deploy our own learning solution without writing any code. All you have to do is drag and drop simply, and which we can do it through a kind of collaboration drag and drop web pages. We go to machine learning studio, and then we simply do all that drag and drop from a web page, where we can define our workflows and various different components by dragging and dropping our machine learning programs. Do it all the things for you within the browser based. And the way that machine learning studio does is by using pre-built and pre-configured machine learning algorithms and handling modules which are built in within the machine learning studio. And if this is a kind of similar to the Azure Logic apps, which will work a little bit as well, where you would need to define some kind of flows and just connect to various different components that are really available with us. Within the machine learning studio, there is a tremendous amount of components that Microsoft already built for you, and whether it's it's actually classify the things, or maybe finding names and the locations and within the text, or predict the weather or sales, things like that, already built by Microsoft. And all you have to do is you have to just use the machine learning studio to build your business case out of machine learning studio. And there are hundreds of pre-built forecasting and statistical and other machine learning algorithms that are available, and we can use at disposable within the ML Studio, that is a machine learning studio. Machine learning studio is a great, really great if you want to experiment or start learning about machine learning more quickly and easily, and especially uh, if you want to build the machine learning algorithms that are Microsoft provided or sufficient for your solution. Not every case that would definitely fit. Maybe if you're impressed with the Microsoft Machine Learning Studio, but some of these things might be suitable in the machine learning services model. If you want to get started quicker and you want to get up in and running easier and faster, machine learning studio is the right environment to start learning about machine learning model a little bit more. But a single difference would be, one would be the PaaS option and other one would be the Saas option. No matter what kind of customization you need, one of these two solutions will definitely work very well with your machine learning. I hope this helped you to understand about machine learning. I'll see you in the next lesson. Thank you for watching this. Hello and welcome back. In this lecture, we will be learning about serverless computing products that are available in Microsoft Azure platform. You might be wondering what exactly the serverless, and also on top of it, there's a word called serverless. That means you may be thinking that there are no servers, but that's not the case. There are actually servers involved that run our applications and our code, but what they really mean by serverless is here we don't have to worry about the servers and administrating the servers or any maintenance or anything like that. Let's try to take one of the example and then try to understand, like you have a code and you try to upload the code and we run that code. So we set up our code that to be triggered by either one of the Azure web services or maybe HTTP endpoints or something like that, and that's really making connections between our certain things to happen, and I want the code to be run. That's it. And when that certain things happens, like someone calls maybe a specific HTTP endpoint, for example, if we wanted to set up our code to be triggered when an Azure blob is saved, like some file gets saved in the Azure storage, and then that event triggers automatically, then this code should be executed, something like that we can configure, and it's only going to be charged for us for the resources that we used while it was running our code. Once our code is run, we are no longer paying for any kind of charges for the servers or for anybody. So it's very cost effective model, but also it provides us with a lot of less maintenance and administration on our end, and we provision some of these serverless products, and we don't have to tell what kind of CPU we're going to use or what kind of RAM we wanted to use. We don't have to configure any kind of scaling. All that has to be done from our end. A server is automatically provisioned and when our code needs to be run, and that entire process can be scaled out, and we have lot of triggering events happening, so that all of that our requests are handled in a relatively quick manner. And again, this is all managed for us. We don't have to worry about any of our serverless computing or server specific things. Let's take a look at one of the live example, and before we jump into the live example, what the core components that we have within the serverless is. The first one would be the Azure Functions and Azure Logic Apps and Azure Event Grids. So these are the three things which are made up with the serverless computing within Microsoft Azure, and these are the most used things. You can check out this link about more about the Azure Functions. So exactly Azure Functions does to execute the code. So it can execute the code that you wanted to run by using the functions. So functions are used to execute the code in your interested language. Let's say you wanna run with maybe C# or Java or JavaScript or Python or PowerShell, whatever the language you are familiar. In that you can run your code by just to place that code, and we can run that code to automatically to happen. And also you can do your own dependencies within the functions. And these are the features that are available within the Azure functions. And also with the Azure functions, you can run HTTP or timer, a Cosmos DB specific or blob storage, queue storage, event grid, event hub, service hub queue, service bus topic. All that can be connected, or it can be responded, or it can be integrated within the Azure functions. And it's gonna only paid for only consumption plan based, and also you can go for the premium plan and app service plan also. It all depends what kind of plan we are going to take it. In one word, Azure functions will be used for triggering the code which you are putting into your choice of language. Azure Logic apps are out of the box things like you want to connect with some of the services and do some kind of for each kind of loops, or if else or true case. All that flow kind of things can be used within this logics, and it's all about the drag and drop mechanism. I'm going to demonstrate one of the application that we can use it within the by using logic apps. And event grid is simplifying your events that to be delivered by eliminating that pooling, all that mechanisms with in a cost effective way. So what we're going to do is now I'm going to jump into a live example for making up one of the application based on the serverless computing. So you see here there's an employee onboarding. So this is one of the application we wanted to think about it. Let's say you have an employee who has accepted your offer for your company, and once he has accepted that offer, it's going to be triggered some kind of an email. So what would happen is we would submit we would offer to the new joining with a link, and once he clicked on that link, it's going to actually trigger that function, and it sends to the logic to process. And what would happen is within this logic, as I said, logic apps can be integrated with out of the box things. Like in this case, I'm gonna integrate with Azure Active Directory and Office 365, two things. So at the first part, I'm going to do actually creating an Azure AD account, and also I'm sending that request or the email to send that information saying that, hey, this is the onboarding information, and you have to follow these are the training schedules, or maybe some kind of a welcome note and all that. And also I'm going to mail to my boss on one of the resources going to join or something like that to notify with the help of Azure Logic apps. And also I'm going to invite for other employees to join and onboard and welcome him, something like that. I can do it within the Azure Logic app. So this kind of one simple application can be built without much code to be written, and all this can be done with the serverless computing. And I hope this is useful, and let's jump into the demonstration of Azure Logic apps, where we're gonna demonstrate by taking some of the RSS feeds to filter out and do some kind of logic apps to be integrated, so that you would be getting an email, something like that. Let's take a look on the Azure Logic apps from the demonstration. And these are the logic apps we have created in the production. Now what we can do is we can simply go ahead and create one of the new application as one of the logic application. Here when you try to create here, you would be getting here as a designer. This is where the designer, this designer will have your HTTPS or Twitter feeds, or it can be Outlook, or it can be any other feeds that can be given as the input, and you can do it. So I will start with the blank logic app for this request, and then we can try to filter out. For example, what I would like to do it here is, let's take one of the RSS feed, and whatever the feed has the blog post or some of the information which is coming from the RSS feed, we would try to convert that into a proper English language, and we make as a header information properly with the subject line and the body, and whatever it contains the value keyword called Azure, and then if that keyword is matches, then we would try to send that blog post information or RSS feed information to one of the email IDs. So that's how we would give it a try. That's a high level of the plan to create the Azure Logic apps. Now let's try this. So now what I'm going to do is, you have all these triggers which can use it. For example, you can schedule it or in a recurrence way. So I wanted to do it every 5 minutes or 3 minutes, and simply give here this schedule is going to happen based on my RSS. You have a lot of other triggers, but I'm just choosing here as the RSS, and I can give here some of the proper RSS feed, and I can name this entire RSS feed as a proper naming connection, and then click on the next step. So here I can take the body to be included for each of this. So it's like your for loop. So I can mention here as the within this for loop, for each of this RSS feed has whatever the values it is coming, I'm going to do for each of this RSS item here by adding one of the action item. So it's like for loop, right? So within this I'm going to add one of the within that body I wanted to look for a translation between this entire RSS, whatever the articles are coming up. So we wanted to translate the title and the text of that body also. So I need to here enter the text, because we are still in the for each loop. So here the first one would be the body, and also I wanted to translate that body to a body as well as the feed title to English. And these are the two items which we wanted to translate. Once we have translated that, I'm just giving the proper name as a translate title, translate summary. As a next step, I need to choose other conditions here, an action. So the action would be, I wanted to compose. That means I wanted to send it to somewhere else. So the input is here. I can choose as my JSON file format. So it should looks like my primary feedback and summary and title. All that I'm just trying to convert into the JSON format. So here just need to enter the dynamic content and these the expressions, all that information. Once I have this information, so this is going to be come for me as the translated one. And now as a next step, I need to configure my email. So the action step to be configured as a next step. So just click on that add action. Now I'm doing the performing some action here. I wanted to actually store the above JSON file information into my Cosmos DB. So here Cosmos DB is the DB which we have already discussed in the past. Like you can store any kind of data without any relationship, without any proper structure. So in this case, the data is dynamic data. I don't know what kind of data is coming. So I'm just choosing here my one of the database here, active database, like feed analysis purpose. So I'm just putting into the connection name and choosing my database, and that's where it's going to store the complete data. But I need to choose here my database name, database ID, and the collection. That's a we need to create within the Cosmos DB. These are the fields, or we can put it here in the document format as output, which we are choosing here. So the information is coming back to Cosmos DB and saving as the output into a document format. So I'm going to show you in a minute or so, once the information is pulled out, how it's going to store. Now let's jump into the conditions, like if else or true case kind of condition here. So if this condition is the translation has some kind of value that is a contains like Azure as a keyword, which I wanted anything as a star Azure star. So that means if anything contains the Azure. So what I wanted to do is, if that's the case is true, I wanted to send it to Outlook, and then it should be send me an email. So this is where the key thing which I want to send as an email to the email ID and the subject and the body of that, all that I would fill up, and then once I save and run this specific logic a logic app, then it's gonna give me more information. So here I just translated, and I have to just click on run. That would actually run my logic app, and if it is success, it will be showing in the down as a success and run history and the time. And then if I click on that, it would be actually showing me the logics which are within the submitted with the inputs and outputs. So the input is a feed, and then it has translated this the value was come, and then it was translating here exactly that values, and output was translated to some other language, and then here you see the output is coming up, and now we are actually that contains some kind of value as Azure. We're storing into the Cosmos DB. So let's go back to Cosmos DB and check out this information is there or not. This is our Cosmos DB Data Explorer feeds, so you can check out. It's gonna actually in the documents. It's actually saved all this information automatically. So this is where we also use the Cosmos DB. Now, since we have the Azure keyword, we got one of the email saying so this is how you can use the logic apps. This is one example that what we can talk about it. In the previous demo, we also we played with the logical apps, and also if you think that within the logical apps, take one more example as if it gets sent out that has a certain hashtag in that, and that could actually trigger our logical apps to perform some kind of work. And because it works with both Microsoft Azure as well as the third-party services, this logical apps it makes our logical apps a very great way to integrate various different applications and data and systems together for our B2B or business to business integrations as well. So again, when functions in the logical apps is a really best when we deal with workflows and complicated process that we wanted to run. And Azure Functions is a better in sort of microservices environment where we have more simpler workloads to perform, and we just wanted our code to run based on the events that are triggering by some other application or something like that. Another last solution within the Azure serverless computing would be the Azure Event Grid. It's basically event routing services. We call it. You see here, the events would be routed within the event grid. So it's really along with the line of Azure messaging services like Service Bus, Event Hub, things like that. It's going to work by integrating with that, and all of these messaging and event services really represents applications and systems to communicate with each other. And in the past, typically applications could directly call other applications, but the better approach for the best practices approach towards the kind of inner system communication nowadays is to have all your systems send messaging and events to central hub communication or central place or central hub like Azure Event Grid, and read messages only when they need to perform certain actions. We mentioned in the previous lessons, for example, e-commerce shopping cart application sending a message that an order was made to be messaging hub so that the shipping application could really take that message and it can read off that hub from the hub and make shipping label. And in that way, both applications don't have to talk with each other, both the messaging hub. And so Azure Event Grid is a really serverless computing portion of the messaging services that with the event grid, and we have fully automated serverless event routing services within the event grid. So it's not that events are coming into the event grid just from the consumer. It can also come from other ways, and that event grid would automatically handle immediately with our messaging services. We have to wait till the application's read from the messaging queue to see if there are any work to perform. But with the event grid, we wire up what we need to happen when an event happens automatically, and so that when that event does come in our serverless function or logical app, or whatever the trigger it happened that we have for event grid, message automatically kicks off as a message comes, they are immediately processed. And so you can think about event grid as this way to immediately process events the second the application sends out on through. And it does all that again using the serverless technology, so we don't have to manage the infrastructure or scale it at all, and it's managed by Azure for us. So I hope this entire lesson is helpful for you to get an idea about Azure functions and Azure logic applications and Azure event grid. I'll see you in the next lesson. Thank you for watching this. Hello and welcome back. We will be looking at benefits of using Azure solutions that we have covered so far in the previous lectures. Now, within the last few lessons, we looked at things like Internet of Things, big data, analytics, artificial intelligence, and machine learning. Also, lastly, serverless computing. And we have seen how we can use this pre-built or pre-packaged solutions within the Microsoft offerings, so that we can get them a little bit faster and a little bit cheaper instead of we actually build them in our infrastructure. With the Internet of Things, we saw the solutions like IoT Central and Managers with IoT Hub and all the messaging services for us. Likewise, we have talked about the big data analytics. We saw tools like Azure Data Lake Store and Data Lake Analytics that manages complexity of those massive parallel processing nodes for us, and within the machine learning. And also we have seen how we could use the machine learning studio to provide a managed solutions for writing machine learning training codes and within the serverless computing. And also we saw Azure functions and logic apps in the previous lecture for the event grids to provide us the fully managed serverless platform. So these are the things we have seen in the previous lessons. In this lesson, we can look at all these 5 different points that we can validate for the Azure solutions. The first one being the reliability and security. We can get increased reliability and security because the solutions and all the underlying infrastructure is managed by Microsoft, and they are going to be responsible for maintaining all the resources and securing with the help by doing all the patching and all the maintenance, and at the end they are going to give us an up-to-date patched machines or the infrastructure to us. Because of that, we have the upper hand and not having to manage our underlying resources, but getting the most reliability out of them and making sure that they are all completely patched and up to date automatically for us. So this helps in terms of even the lowering the cost, and also we will be making in a competitive way to make it fast provisioning all these things like bigger things like big data or such things would it takes a lot of time for us to set it up in our on premises, so we can set these things on cloud and we can provision as fast as we can do, and we can concentrate on the solutions instead of concentrating on the resources. So that way we would be bringing our services faster to the market, and we can charge only low cost because the resources that Microsoft is offering for us in almost all the possible ways. So that would definitely help us. My recommendation is to you, anytime you have business need or a programming need to stand up certain type of applications or systems or solutions, check around Microsoft Azure and see if they have any pre-built or pre-packaged solutions that are already available in the marketplace or from their solutions. and chances are there might be one at least exist, so that you can save a good chunk of time and money upfront by choosing to go down and a route for using the solutions versus connecting various Azure products and services together yourself. I hope this is useful for you, and thank you for watching this lesson.
Hello and welcome back. In this new module, we will be looking at Azure management tools. When I say management tools, the tools which are used to work with Microsoft Azure Cloud. So there are three different tools that can be used to manage Microsoft Azure Cloud. So the first one would be the mostly used, the Azure Portal, followed by PowerShell or CLI if you're a fan of Linux. So you have three different tools which are used. So let's talk about each of them very little bit. So to talk on that, we have the Azure portal. This is the normal portal which you normally use for any kind of managing the Azure. So this is a portal we use. So this is the interface, or this we can call as one of the tool to manage Microsoft Azure. And other one would be the CLI. CLI is nothing but a cloud shell which is coming from the browser base. If you click here, it's going to actually create here for you a complete shell, and from here you can run the commands to create either any of the Azure services. So you don't need to go to the Azure portal directly, you can run from this shell. So that's the advantage of having a PowerShell, very similar to the Bash. And also you have the PowerShell also you can change. So it's going to change to the PowerShell. So you have two options to configure or work directly from the Cloud Shell. And the other one would be the normal PowerShell. From your start button, you can open a PowerShell and get it connected with the Microsoft Azure subscriptions, and then you can manage any of the Microsoft Azure cloud services. So these are the three tools which we are going to work on it. I hope this is an introduction lecture, so you would be more working on that tools in the upcoming lectures. Thank you for watching this.
Hello and welcome back. In this lecture, we will be working with Azure CLI, and we will be learning what exactly Azure CLI and how best we can install on any of the operating systems. And then we will try to create a virtual machine with the help of Azure CLI commands. So as we talked about in the previous introduction of this overview lecture, we talked about Azure CLI is one of the management tool. With this, we can use and we can create, we can work with any of the Azure resources or Azure services. So what exactly is Azure CLI? Azure CLI is a command line tool providing a great experience for managing Azure resources. So the CLI is designed to make your scripting easier, and you can query data, you can support long-running operations and more with the CLI. So this CLI can be installed on Windows operating systems or literally on your Mac OS or Linux Windows. So it is going to support almost all the operating systems. So what we'll do is we will start with installing Azure CLI on one of the Windows box, and then we will start connecting, and we will be trying to create the virtual machine with the given command lines. You can go back to this one of the page and try to install this binaries on one of your Windows machine. So in my case, I'm gonna actually install on this PC. So you can click here to download the MSI installer. This would take a minute to get it downloaded. The installation is very straightforward. You can double click on that MSI and it's going to install the required components automatically. The installation is finished and you can click on finish button. That would actually conclude the installation. Either you can open PowerShell or you can open the command prompt to run the Azure CLI. So I'm just opening command prompt. This is a normal command prompt. This is where you need to use the commands to log in and perform your Azure tasks. I will be using these are the commands to create the virtual machine for the demonstration purpose. So as a first step, I need to log in. So to log into Azure portal by using Azure CLI, I need to enter some of the commands. So the first command I need to enter, the first command would be the AZ login. So I just enter AZ login. It's going to actually open up my Azure portal to login. So in my case, I need to use any of the browser as a default. So I'm just using the Chrome to log in. Just going to that resource. So here I need to enter the logon credentials. Now if you see here, this has been logged in and it's going to redirect within the 10 seconds to the Azure CLI documents page. So now this has been signed in, and you can check out here the subscription details and all that would automatically come up here. Now before I do anything on the Azure CLI, I wanted to show you that the current resource groups that I have here. So if you just go to the resource groups, I have the resource groups as only these are the 6 different resource groups are there. So I'm going to actually use Azure CLI commands to create one of the resource group. To do that, I'll simply press here as a command called AZ group and create, and the name of the resource group is here. I'm entering my resource group. So here if you see here, there's no group called my resource group, and the location of this is yours. So that's a command. So it just created that, it has executed perfectly. So if I just refresh, I should be able to see here that specific resource group. Let me refresh, and if you see here, my resource group is already populated here, and the location is ECS as we mentioned. Now as a next step, I wanted to execute the other commands also. Like I want to create a command, completely a VM. So for that, what I can do is I can type here AZ VM, that's Azure VM, and then create. Let's try to execute the AZ VM create is one of the CLI command line to create the resource group, hyphen resource group, and a hyphen name. My VM and image is the 2016 data center edition, and I'm going to create in the Azure user account and also the password as the admin dollar. That's not going to work because the password required a complexity. So let me put the complex password there. That would actually work this time. So once I have this complex password, it should actually work. Let's change that password to something a complex one, really complex one, and that should actually create for me a VM within the my resource group. And if you see here in the my resource group is just there, but inside that there's nothing is there. So it's gonna create in a minute or so. If I just double click the my resource group, at this point of time there's no objects got created, but in a minute or so it's going to create for me all the required objects like your NSGs and network that's a everything is gonna get created. So you have here the public IP as given as output and the private IP, so that you know what's the IP and you can connect it. So these are the resource groups has been already created, and simply I can connect to this with by using, if I want, with the public IP, but I'm not going to do that. But before that, I want to add one more command line just to add in NSG one of the RDP firewall rule to be enabled. So to do that, I'll just go to networking, and then you see here there's no port for exception for port IT. So I will be adding here another command for exception, like open port is the command VM open port. I'm gonna actually open port and give the port number and the resource group with my VM as the name. That's it. It's gonna actually create with an exception with the port IT, and that's how you're gonna create your NSGs if really needed. And these are the commands you can go through the documentation to learn more if you're really interested. And if you want to delete your resource group, you can simply use a command line AZ group delete. That's a command, and then give the name of your resource group. So if I just refresh here, I should be able to see my port IT specific one. Yeah, it's there. So as a next step, I'm going to actually delete the specific group which was created. Now I need to enter a command line which is AZ group delete hyphen name, and it's going to ask me all the confirmation. So in my case, that's a resource group, so all these objects, which are 6 different objects, gonna delete it, and you can go to the resource group and see my resource group is there, which is going to delete if I confirm as yes. So hit enter as Y, that's going to actually delete that specific VM. It's not just VM, it's also all the contents of your resource group. So you see it's completed, and if I just refresh, it will go off. So it's just done. And the same things also you can do it from Azure CLI, which I'm going to show you from the browser based one.
The same commands also can be executed from direct Cloud Shell. So the Cloud Shell is the direct portal. You don't need to install and configure like this what we have done on this machine. Instead, you can directly use the Cloud Shell, and here you can choose the either you want to use the CLI or the PowerShell. So if I just switch to CLI, I can do the same commands can be executed. For example, I can simply create a resource group, for example, AZ group. So the same commands, there's no difference. I can use here like simply hit enter. That would actually create me resource group with the same name. So I can duplicate this and I can refresh here, because if I try to refresh here, I will be losing this shell. So instead I can simply check out here. You see here demo resource group has been created. That is a my resource group with the ECUs. So this is how you can use the CLI. I hope this is useful for you. Thank you for watching this. Hello and welcome back. In this lecture, we will be looking at Azure PowerShell. Azure PowerShell is a set of commandlets for managing Azure resources directly from PowerShell command line. So whatever the resources you want to manage directly, you can manage with the PowerShell like we did with the Azure CLI. Same way, you can also do it with the PowerShell. So PowerShell is designed to make it easy to learn and get started with PowerShell, and it also provides powerful features for your automation. Let's have a look on it, what kind of things we can have to do it for the setting up this PowerShell. The first thing is it works with PowerShell 5.1 or higher on the Windows platforms. Also PowerShell released PowerShell Core 6.x. So starting from here, it can also work on Linux and Unix environments. It's not just the Windows anymore, unlike the 5.1. So now the 7.0 is getting released. PowerShell code, you can check out my course. I did release a PowerShell and PowerShell course. And coming back to the, if you want to learn about the PowerShell version, what's the current version of the PowerShell, you can check out the PS version table.ps version. So this would list the current PowerShell version. It would list whether it is a 5.1 or 6 plus or whatever the version it is. And coming back to if you are running on Windows 10, most likely you are on, so you have already 5.1, so you don't need to install anything additional for installing the PowerShell. However, you need to install the modules. So let's go ahead and install with this command. You can install for the module, and that would actually tells the installation should happen on for all users. If you don't want that to happen for all users, you can scope it for current user here. And coming back to the next one, you can also install if you have not connected to internet. From internet connected machine, you can download for the offline and then get it installed later point. And also you can log in with the PowerShell. So the way would be when you actually wanted to log in, you need to use a PowerShell commandlet called connect-az account. So AZ account would pop up a username and password that to be entered in a browser. Once you enter, that goes redirects to your PowerShell. So you would be connected to your subscription, and from there you should be able to manage and create the required resources. What if you're already using the PowerShell but you want to update that specific module, because every day, or maybe I would say not exactly every day, but very frequently Microsoft updates all the PowerShell commands because they are introducing new features, new products, new services. So the PowerShell commandlets will be changing. So new will come up and new options are available. So if you want to get that module to be updated, you need to go for this command line to install the module, like install -module. Name of that would start with the AZ, and that's Azure, and the LO Clobber _ -force. So that concludes the PowerShell one, and let's jump into the demo. Hello and welcome back. In this lecture, we will be installing PowerShell module, and we will work with that module. So in the previous lecture, we were explaining all these options. So let's give it a try with all these manually doing all these steps. So to do that, at the first point, I'm actually copy pasting this text for you in the notepad so that I can do it one by one. So this can work with the PowerShell version 5.1 or 6.x X as a core. So in our case, to find out the PowerShell version, I'll just open PowerShell, run as administrator. That's a good practice so that you know what we are trying to do. This is a command line we wanted to use. And this says that its a major is 5 and the minor version is 1. That means it's a 5.1. And now if I just look at Win version, this is a Windows 10 machine. That means by default 5.1 is already coming up. So I don't need to install anything. Now all I have to do is, if I have internet access, see you have here I have internet access. That means I should be able to install with this simple command Azure module. This is going to AZ module from PowerShell Gallery. So there's a website called PowerShell Gallery. If I just wanted to show you, I just execute it here. It's going here. In the meantime, if I just open PowerShell Gallery, so this is a website runs by Microsoft, and all the packages, all the information would be uploaded here, so that people will go here and download the required things. And also the command which we just entered, it is actually connecting to PowerShellGallery.com. Since it is actually installing from the PowerShell Gallery, it says that, hey, do you want to install from a different repository altogether, because this was not trusted, or it's not from a local, because this specific Azure module is coming from this PowerShellGallery.com website. So what I can do is I can press here Y, so that it's going to install. It's connecting and it's downloading that files, and it gets installed. So I can trust that PS Gallery. It is showing very clearly that it's going to connect with the PowerShell Gallery. So I can simply press as yes, yay for all. So instead of again prompting yes, I would allow to give here as A. It got just installed from the module, and now I can check out by using git-install module to see any of the Azure module which start with AZ or available. So I can see here AZ 3.3 is available, and that's a version of my Azure module it has installed. It doesn't mean that it is actually readily available for use. So I need to import that specific module to work, which we are gonna get some errors in the upcoming commands that I'm gonna show you. If I try to connect with the connect-az account, it says that the module was installed, but it was not loaded, because not all the modules will be all the time will not be loaded, because it will crash the machine, because unwanted all the modules will, if it is loaded. It's a security risk. At the same time, we never know that the shell is ready for what kind of operation. So whenever we need it, the required modules to be loaded. So in my case, import-module, as the account is not loaded, so I'm just loading here. That would actually install the module. Since the execution policy is not set, I'm going to set it to either undefined or remote signed. So in my case, I think the better policy should be the all signed, because I wanted to be trusted all the scripts. So I'm just entering all signed, and then whatever it is asking, for example here, if I try to import, also it's saying that once I enter the all signed, it's asking for me to import the module. So when I try and go for the import module, it says that, hey, you want to trust this specific module, because it was not trusted, or it was not signed, or it is signed with specific certificate or the publisher which is showing that. So I'm saying that, yeah, I'm okay, good to go to sign that by pressing always run. That would actually enter to load the module for me. Now I need to connect by using the connect-az connect. So this is a command which uses to connect by giving the user ID and password. So I'll just enter that, and I need to enter here my user ID, which I use it to log into my PowerShell, to my Azure portal, and that ID would take me to the connecting to this shell. So now it has entered into the subscription. Now I can play with any other AZ commands. For example, if I want to create a new resource group, what I'll do is I'll just enter this command, new AZ resource group -name and tutorial
called tutorial resources. Location is here. So in my Azure portal, if I just go here and go to my resource groups, I should be able to see here. If I just refresh, it just populated this tutorial resources. So that's how you're going to create a resource group. Next, if you want to create some kind of admin credentials to create the VM, say let's say example, you want to enter the user ID and password. So what we'll do is we actually put a value called $credential. So that's actually going to be ask us for entering the credentials. So let's see here, the credentials are going to store in this variable by typing this command called get-credentials. So whenever I use this variable, again whatever the entered credentials are there, that will be populated here. So I'll simply press enter. So I'm just entering here. So it will ask for enter the user ID and password for the virtual machine, which we have given here the text. So I'm just going to enter here like Udemy admin is the user ID and the password as some random password which I wanted to set it. Entering here the password, and now if I just go and type my credentials, it's actually showing me this user ID is this and the password was converted, and it can't show you. So as a next step, I need to check if I'm able to do the VM creation further, let's say I wanted to run some kind of additional commands to get the VM to be created. Let me type here the other commands. You see here, I'm gonna type here VM parameters or resource group is tutorial resource group, and the name would be the VM would be the tutorial VM1, and location is East US, and the image name is 2016 data center, and the public IP is tutorial public IP. That's a name, and the credentials which we stored here, that's the credentials, and the ports should be open 3389. And now if I'm okay, I can say that new VM, just the PowerShell command to create is a new VM. That's a new -AZ VM that's gonna create, and these all or the parameters has been stored. These all values are stored into this variable called VM parameters. So it says a new VM, that's the new VM. It's gonna store all these values. What is the command? Command is the new AZVM as well as the parameters. So these all the values are gonna store here. If I hit here, it's gonna store and create that specific VM1, which is new VM1 with the above resource group name and the location and MIH name, all that information. So the percentage is going quickly and it has 100% completed, and now the VM has been created successfully. Now as the next step, I can see the properties of the VM by typing that variable like a new VM1 which is stored into the $new VM1. So simply take that and paste it so that you can see that it's what is the resource group it has been created, the VM name and the location, and provision is successed, and the fully qualified domain name which is into the cloudapp.azure.com. If I just go back here to my all resource groups and check out here the tutorial resource group which has created, and all that objects are able to see within this console, which is Azure Portal console, and that's a public IP which we have renamed to come back as the tutorial public IP, and the disk, everything has been attached and the VM is working fine. Now as a next step, if I want really, I can connect to that VM also. I just go to the VM, and you can check out here the NSG, one of the port called 3389 has been already created as an exception. Now I can check out with this PowerShell command, the command which will talks about new VM OS profile, that would tell about the operating system profile information, and the object which is logged into the computer logon user ID for the admin, which is in this case the Udemy admin. So that account as well as the password information should be available. So these are the information from the properties, and I should be able to see here redeploy reset password. So that's the information it's going to populate here. So simply you see when I type that new VM.os profile, it's going to actually telling the computer name and the admin user ID, so that I can use that ID to log in
to the machines. So it's so easy. And let's see, if I want to know about the network card information of the private IP, I can type from the Powershell to get that as the new VM properties by filtering to the AZ network interface, and I can select the object that's expanding the property of IP configuration, which is for the name and the IP private IP information. So I get it as the IPS 1.4 for that specific machine. Now I can even connect to the machine by typing mstsc/v, or just type your mstsc from your run and take the public IP information from the portal, or you can get that information similarly private IP. You can type for the public IP information and then connect it. So here I need to give the user ID. If you remember, the user ID for the computer is admin, username is Udemy admin. That's a copy that user ID information and give that complex password which I have given from the password when I was trying to create the VM, which was stored under credentials, $credentials, user ID. So that's a password. So click OK. That's gonna actually connect by clicking on yes. That's a simple certificate warning. So that would connect to the VM successfully. So post to this, you should be able to see the VM logon screen, and I'm gonna actually create one more VM within the same subnet. Before we jump into that, let's log in here. So we are able to log in. Let's go back to the shell and try to create another VM with the VM2 parameters with a similar one within the same subnet. So here the subnet name we are giving here, that's it, and that would actually create, and I'm executing that command. So it's gonna actually show me the progress of the new VM creation in the percentage there, and you see here it's like 20 to 100%. Fast forwarding that, and then the VM gets created. If I want to view in my properties from the PowerShell, I can input as the $new VM2, that's a resource name, and the success provisioning, all that information I can see. And if I just refresh here, I should be able to see here the new VM2 which has been created here within the same resource group with a different subnet, and that looks good. And if I want to clean up these resources, what I can do is I can use another command line, but you see here that everything has been created, looks good. And now as a next step, I can simply remove Azure resource group, and the group name I can give it that's running as a job in the background, and I can check out here the job is currently running states. That concludes how to create a VM with the PowerShell and resource groups and other resources, and then also deleting that resources. I hope this is useful for you. Thank you for watching this.
Hello and welcome back. In this short lecture, we will be learning about Azure Portal as well as the Cloud Shell specific. These are the Cloud Shell. So I'm going to talk starting with the Azure Portal. So this is a portal you would be interacting with the GUI base. So it's a completely web-based and unified console that is providing you as an alternative for your PowerShell management. From the PowerShell, you can create all these commands and can create your Azure resources, right? So if you are looking for an alternative to work with the graphical user interface, this is the best option. That's what you can get it from the Azure Portal. Or maybe even the same case if you're trying to use from the Cloud Shell or from Azure CLI, all that that doesn't provide you a graphical interface, other tools or any other management tools that we talked in this lecture. Only Azure Portal provides you the graphical user interface. So let's jump into that graphical user interface console, and it's a unified console and it's alternative to your command line tools. And with the Azure Portal, you can actually manage entire Azure resources which are with the graphical user interface base. You can manage, you can build, you can create, you can monitor the resources that you wanted. Like you can create your web applications, you can create a complex cloud deployment tools or deployment services can be done, and you can create your dashboard. So when I talk about the dashboard, this is my front screen. As soon as I log in here, I get it here. And if I want to have a dashboard for my specific services, let's say I can create here, like here click on new resource group, and you can set the time zone. You can simply drag and drop. That would actually come up here, so you can give the time zone and the user account, or maybe whatever the resources you want to view in your dashboard. That all can be done from here. Let's say I wanted in this case maybe a logical apps. I can simply add here as the logical apps, and you want a bigger one or smaller one, it can be adjusted based on your requirement. So it just came down. And security metrics I want to add, for example, I can add here, so this security score out of 250, so that I know that something going wrong. And if I want availability zones, I can configure here. So this is my dashboard. Once it is becoming my dashboard, I can see all subscriptions. So for this availability zone, you need to configure what kind of availability zone you wanted to view it. So in my case, I don't have the applications which are having that availability zone specific, so I can't definitely done that, so I can't get the data. But this is my dashboard. So you see here I have 3 different dashboards, and if I just go to any of different dashboard, I get a different view. So you can't get this with the command tools. If you're trying to manage or view the command based tools to view all the resources at one shot as a dashboard, you don't have that option, and you have with the Azure portal. Now within the Azure portal, you can what else you can do is you can do the customizations for your look and view. For example, you want a flyout based or dog based. When I say dog based, so all the time this view will be there like this. If I just use the flyout, it doesn't view that. And also you can adjust your contrast, black or white, all that based on your requirement. These are also sometimes called as accessibility specific specific settings, that we can say that. And top of it, how to work with the dashboard. So to talk about that, you can create any of the resources by going here from the docking three lines, like you can resource, like you want to create a new computer, you can go here and create that specific VM which is running with the operating system called here the Windows 2016 data center, or maybe a CentOS based Linux. You can all fulfill this information and you can do that. So we did in fact tried many of the demos we did created, so I'm not gonna waste here again creating that specific VM, but I just wanted to talk here. For example, you want to add some additional component. For example, here you don't see a specific service. Let's say you want a you want media services to be there. So what you can do is you can simply go here, and when you put your cursor, it's come up here, and just click on that star button. That would actually populate as a favorite. So if I just go back here, the media service is there because I have chosen as the favorite. That's why the star is there. If I taken out this star, it simply goes out from here, you see. And I can drag and drop this also up and down, so that the way you want it, you can adjust the sorting options. And also you have the view, like here you can view, you can filter here the settings that you wanted to choose at portal settings, because if you have multiple subscriptions, that information will automatically come up, and you make sure that you have chosen the proper subscription. Otherwise it's gonna come up with different subscription, and you might be ending up with a different resources and creation in that different subscriptions. And coming back to the if you have already computing, and let's say I wanted to view the virtual machines, I can go and check out here, and whatever I'm clicking here, you see here, for example, I wanted to configure networking. So I just clicked on here, make add incoming rule. So what would happen is if I just go down and see, so this is a first blade, this is a second blade, we call it, this is another blade, this is where you're actually putting the information. So how it works is everything works based on the blades. Let's say if I try to create some something here, so what happened is if I just give here the values, example demo, and it's actually going to create a template, right? So what would happen is here my blades are getting created here. So
the information which I click on here, this is one blade, this is another blade, we call it in Microsoft Azure portal. This is how you call, you want to save it, you can click on create and save, but we call this frame, this entire frame is a one blade. So you have to go to the left to right navigation would happen. Make sure that you need to remember that. And coming back to the cloud shell, so within this lecture I'm also covering not just the Azure portal, also the cloud shell. So what exactly cloud shell? The cloud shell is a feature if you don't have a computer to work and you wanted to run your commands directly instead of executing or clicking on from the browser based Azure portal, then you can run those commands to get it created. Let's say we talked about in the previous lectures or maybe upcoming lectures, we talked about Azure Powershell or Azure CLI. So Azure CLI is basically for the Linux guys who are comfortable. They can use these command lines to execute the commands. But the PowerShell guys normally it's like the Windows guys normally use the PowerShell. But what if they don't have the computer to work on it, but they wanted to execute? So in that situation, let's say they are maybe in an airport or they may be in a beach and they wanted to execute some kind of commands, simple commands that are saved in a maybe in Azure storage, and they want to recall that simple script to execute so that the business availability comes, or the business solution maybe you're resolving that business case. In that situation you can use the cloud shell. So the cloud shell is the additional one which is let me open up that. Actually, this is the cloud shell. This is where you actually click here, you see here little icon. So when you click on this cloud shell, so what would happen is here you are gonna either creating a temporary a kind of small storage account. That's where actually there's commands and other things would be stored. So I can choose here, let's say create that. It's gonna create me a storage account. If you see here, my current storage accounts are very limited here. I don't have anything with the cloud shell based, right? So it's gonna create here another one in a minute. You have no storage accounts are mounted, so it's gonna creating this. Once I just close this, it's gonna create a storage account, and then on top of it I can run the command. So now if you see here, there's another storage account gets created in a minute or so, and I can directly work on this commandlet or as a bash based or PowerShell based. So it all the comfort gives for you, whether you want to use the CLI based commands or you want to use the PowerShell based commands. So if you are looking for the consolidation or summarization of what exactly the cloud shell is basically, with this you can authenticate, you can access right directly from the Azure portal of anything, any resources that you wanted. So you get virtually work from anywhere, and you have the you can choose your preference shell experience, either bash or PowerShell. So I'll say confirm, it's gonna change to that PowerShell. Other one would be the, you see here I'm actually connected in the background. What would happen is actually it spins up a little bit console based VM, which is not going to charge for us. Only it's going to charge for the storage, but you get that console ready for you. And you see here whatever the commands you have executed here, like let's say you wanna create a new resource group here, maybe like this. So simply same command, you simply paste it here, and it's going to create for you the resource group, which is the tutorial resource. So you see here it's just created. If I just go here, before that let me show you here the storage account I didn't show you. So now the cloud shell specific storage account has been created. If you see here, resource group is cloud shell storage account that has been created. Now if I go back to my resource groups, that's what I talked here. So if I just go to resource group here, it should be created by this time, called Azure resource group called a resource trial. try a tutorial resource group. So if I just refresh, I should be able to see here tutorial resource group. So that's how you simply no need to browse and do all the things. Simply if you have the code, you can directly execute here. That's the advantage of the Cloud Shell. And we talked about the PowerShell. Now let's also have a look on the bash. So all we have to do is the bash is a very simple requesting to the Cloud Shell. It's success and it's connected to my right to the my subscription. So within the shell you can use the hash CLI commands from the bash console. So for example, you can look at here help. So let me click here help, and I can use the help to learn more about AZ specific, or that like as AZ help. So that would actually list me all the Azure specific commands and how to use that. And for example, let's take one example as a tutorial resource to be deleted. So the command should be, I should be using AZ group deleting the name of the resource group. So the group is nothing but here the resource. So I would be in a group is the resource group, that is a template deployment. So I simply execute that. So in a minute it's going to ask me for confirmation, so I confirm that and it's going to delete it. So in a minute it's going to delete it, that specific one. If I just refresh in a minute or so, it gets deleted after see, now it's running the job. And I can a little bit go up so that you can see here it's get deleted. Deleting. So you have the flexibility to up and down the options of the console. And also you have here new console. You can upload the files or the script so that it can be saved in your storage account. Also, if you want a new console to be open, simply new session, click on that. So this is the session would automatically open like this, and you're good to go. Actually, using all that specific commands. If you don't like here in a small window, it goes into the bigger window, and you can use the editor. So this would actually tells me what you're trying to do. Like example, within the Azure, whatever the files you are trying to play, all the history, all that can be viewed from here. And this is a web preview you can configure so that you can view it by looking into that what's happening based on that ports directly. Now if I just close this, and the Azure resource group has been already deleted, and if I just go back here and refresh, I should not see here the tutorial point or tutorial resource group. It's just gone. That's how you can play with this Cloud Shell, and this is more advanced concepts you have with the Cloud Shell. And because the connection, if you see, if you just disconnect, it's still the connection will be there, and you can go back and you can work on it the way you want it. I hope this is useful for you. Thank you for watching this.
Hello and welcome back. In this lecture we will be working with Microsoft Azure Advisor. Microsoft Azure Advisor is a personalized cloud consultant that will give you an advice all the time on 5 different pillars, starting from the high availability for your resources, also for the securing your resources and getting the best performance out of Azure services, also the operation excellence, and also saving the cost. So these are the 5 pillars. Based on that, it would be giving you a personalized advice for your resources that are hosted in Microsoft Azure Cloud. It can analyze your resources, configurations, and uses based on the telemetry data that are coming out of your resources, and it can give you the best recommendations for your high availability or security or performance or operational excellence or cost specific. It can be proactive or actionable or personalized for the best practice information. And also you would be getting a benefit out of it, like improving your performance, security, and high availability for your resources as you identify opportunities to reduce your overall Azure spending. And also you would be getting a time to time recommendations from these resources
which are hosted based on these 5 different pillars. And also you have an easy option where you can simply implement the required configurations in a easy to click buttons based. Let's dive into the portal and see what best we can do within this. To navigate to advisor, you can simply go to all services and search for, or you can search here as the advisor, but it normally will be there here for anybody, but you can just search for advisory and that would actually list here, and later point you can actually pin this to your favorites so that it will be there for you. So when you click on advisory, it's gonna immediately analyzing all these 5 pillars which we have talked, like high availability, security, performance, and operational excellence in the cost based. So this data will be coming up out of my telemetry for all the resources. So for the high availability, there are no advisory information available for me to work on that specific one. If I want to know more about the high availability options, I can simply click here. That would open up a new window and it would ensure that these all or the configurations are properly configured. If at all everything is configured, for example, high availability sets and managed disks you are using, you're ensuring that your application gateways are fault tolerance. Such kind of configuration, if you use it, then it gives you as a recommended as a green button. Otherwise, you would be ending up with 3 different categories. You can see here for the security, for that matter. So with the security, you can see here 2 are highly impacted, 2 are medium, and 0 are low impacted. So if I click on security, it's going to tell me what are the 2 immediate priorities that I need to take out. For example, these are the this one is actually talking about 3 different storage accounts that are impacted. And the summary, if you see here, the secure transfer to the storage account should be enabled, but we did not enable that. By default, when you create the storage account, it doesn't enable. And since we created the default settings, it's advising us to, hey, you must have to configure your storage account in such a way to secure all the transfer between your storage account all the time. So what you can do is, you don't need to search for the in Google or somewhere to bring that information. Instead of that, you can simply click here so that it tells you what step to be taken automatically for that. Let's say here these are the 3 different storage accounts. It says that, hey, you don't have this configuration was configured, so you must have to remediate this to simply enable that HTTPS configuration so that it would be securing. So if I just remediate, it's going to affect for that 3 different storage accounts. So it's so easy, and this would actually gives me the points also. If you see here, if I don't remediate, I'm going to lose 6 points. If I remediate, I'm going to gain 6 points out of my 20 points. So these are the scoring also it's going to talk. Now let's go back to the this has been already saved, and let me go back to the Microsoft advisory one more time. So if I just go to advisor, it would again analyze and it would tell us what other things has been wrong. So now that has been done and it's no more. And you see here it says that there are 2 other things also needs to be configured. For example, all network ports should be restricted to the NSGs. Let's say this is my one of the VM. It says that the port has been already configured. For example, here port 8080 was configured, and which if I don't want, I can simply take it out this. It's gonna directly taking to that specific setting which is gonna impacting me. And similarly, secure transfer for storage account, that should be enabled. This is the other one. So you see here this has been already done. So this has been already fixed, so you don't need to perform any kind of action. When it actually reruns, you would be getting information as it automatically goes off this high priority one. And also the other vulnerabilities specific, it says that Visual Studio specific subscription should be assessment should be enabled, so I can do that specific action if I really want it. And these all are such configurations you can do it automatically on your from starting from your security center or from your advisory under security. Now let's go back to one more time for the advisory and look at for the performance specific. So performance specific, there's nothing has been already done. If you are looking for some kind of performance specific, you can check out like these are the recommended options, like configuring disk specific, input output, operation specific, or SQL. All that has been clearly mentioned. If not, it would be actually listing here. So since I follow all my recommendations from the Microsoft, so there's nothing to be no room for improvements. And coming back to overall operational excellence, I have one recommendation. It says that create service health alert. That means if something goes wrong with my resources which are available within that specific regions, I should be able to get some kind of alert saying that, hey, this has been failed because this specific region has down, or some kind of subscription has put onto hold or something like that. If you want, you can simply create an alert and get a alert for that specific service. So let's say you want to take the service health alert, or you want to replacing some kind of tags or such kind of any information, you can configure from here and follow that steps. And let's also check for the from the advisory, the last one would be the cost. So think that if there are any of the VM, let's say you are configuring maybe two of the VMs are in a production, and they are facing your clients, but only one machine is working fine. Other machine, they never gets the data back to that client. So that means the VM is production and it is in live state, but no clients are using. So it tells that based on the telemetry data, hey, this specific VM is no more used, so you should actually deallocate or delete so that you can save the cost. Such information can be automatically popped up so that you would be saving some kind of cost also on the user's front. And also you can save this entire dashboard specific report in terms of PDF or in terms of the Excel, and you can view that in the format of a proper report format. I hope these things would makes you more easy, and you can configure your recommendations based on your settings. And I hope this is useful for you. Thank you for watching this.
Hello and welcome back. In this lecture, we will be learning about Microsoft Azure Firewall. As you know, in any of the company, we will be using the firewalls like Palo Alto or maybe Cisco or Checkpoint, or different firewalls we will be using like Sophos. Different firewalls we'll be using. Similar firewall functionality you can also use within the Microsoft Azure portal, and not just a third party, you also have the Microsoft built-in firewall available. If you use third-party products, firewalls, you can simply go here and check for maybe different firewall like Sophos. So you have the Sophos specific firewall, Sophos next generation firewall. Simply type firewall, so you would be getting, these are the firewalls which are coming up. So these are the which are available. So if I just go to the marketplace, you would be getting more and more actually within the marketplace. Like you do have here for the Checkpoint specific companies, Sophos, as I explained, and you also have threat protection specific, SonicWall, Cisco's, and many of the products you do have here. So out of that, we are looking for the Microsoft one, so Microsoft Firewall. So you can create here the firewall and then configure similar things which we do it on our on-premises firewall. So let's go to the actual PPT and we can talk about it now. So what you would be getting is here with the Azure firewall, you would be getting here a firewall, and your firewall will act as here as a hub, and other resources which will act as a spoke. So spokes is nothing but the hub and the client communication. The way it does similar fashion, any request that must come to Azure firewall, and from there it will process. So it can be on premises server to your cloud, or on premises to on premises. Whatever the request is coming up, you can actually configure in such a way to route the traffic by using the routing tables
and by default whether the traffic should be allowed or denied based on the rules that you wanted to use. So in this case, by default it's gonna deny, and if you don't have any of the rule was configured, you can't reach the resources. It's not that just that, for example, you have the VNet 1 and VNet 2 example. So between these VNet 2 and VNet 1 also any communication should establish. It will actually route to Azure Firewall, and from there Azure Firewall to other VNet it will go up. So that's how you can configure so that you would be controlling the traffic. It's not just a controlling the traffic, you can also filtering the traffic for any kind of threat specific, for example, because Azure Firewall has a Microsoft threat intelligence and also has the similar one which we also call as the malicious IPs and FQDNs. It actually verifies the traffic in an intelligent way, and then if really something going wrong it can block for you. And also you can configure the L3 and L7 layer of user specific policies also with the help of application rules. Now let's understand what exactly the Microsoft Azure Firewall. So this Azure Firewall is managed cloud-based network security service because it's providing complete network layered security, and that's why it's called a network security service that protects your entire virtual network resources within your VNets, whatever the resources are there, that all are protected. It's a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. On top of it, you can also create everything in a centrally, and everything is fully integrated with the Azure monitoring. By doing that, you can also log with the log analytics services, so that whatever the resources or communication is happening, all that will be properly logged and you can easily monitor them. So that's the explanation of Microsoft Azure Firewall. Let's go to the Microsoft Firewall homepage and understand what exactly and how it looks like. So the PPT which we have seen is taken from this page only, which is the Microsoft documentation, which I will be linking into the resource section of this lecture. And you can check out here it's built-in high availability, and it is available zones or configured by default, unrestricted cloud scalability, application FQDN filtering rules can be configured, and network traffic filtering rules can be configured. So it has a threat intelligence so that it can analyze if any malicious IP addresses or domains are known things are available, then it's gonna automatically block it. And these are the advantages side, and there are definitely some of the known issues are there that would be documented here, since it is for almost any of the products. If we have any of the known issues, that would be logged here. So similarly, Microsoft also logged here. And coming back to the pricing side, so Microsoft Azure firewall pricing is very straightforward based on the hourly. So per hour, if you deployed once, per hour they are going to charge $1.25 per hour. That means if you take it for a month or so, it's going to be close to 1300 you would be getting out. So let me show you by adding into the calculator. Just click here as the calculator. That would actually take it, and simply here it's already added that page, and simply give here. So this is based on your per deployment, which is 720 or 730 would be your 24/7 here, so which is 720, and then you can check out the pricing. It's closely coming to 900 in USD, and opposed to that, if anything is going incoming or outgoing, that traffic also will be calculated so within the firewall. So here you see here data processing is close to, if you have 100 GB example, it's gonna charge as the very less, actually $1.60. It's ignorable the price, and you're getting close to 900. I'm sorry, I said 1300 close, but it's coming actually close to 901 USD. So that would be easiest one, but whether you use it or not, you're gonna pay it for that, because it's a per hour basis per deployment. So if you have a more logical firewalls, it's going to cost more and more. So make sure that you design properly so that it's not going to cost you a lot. I hope this is useful for you. Thank you for watching this. I'll catch you later. Hello and welcome back. In this lecture, we will be learning about Microsoft Azure DDoS protection services. The biggest concern these days would be the distributed denial of service, that is DDoS attacks, or some of the largest availability and the security concerns currently customers are facing. That they are moving their applications to the cloud, then they are expecting some kind of DDoS attacks. So their concerns would be to protect from the DDoS protection. So that's where the Microsoft come up with this product called Azure DDoS protection. There are different plans within the DDoS, like a standard plan and the basic plan. I'm going to talk on that, but for now, let's understand what exactly DDoS attack. A DDoS attack attempts to exhaust an application resources and making that specific applications completely unavailable to the legitimate users. DDoS attacks can be targeted for any endpoint which is publicly reachable through the internet. So Microsoft Azure DDoS protection combines with the application designing best practices to provide the defense against your DDoS. That's why DDoS is reliable and scalable and automatic. It's very simple and automatic. I'm going to talk on that in why it's fully automatic, and it's a real-time tunneling. And you can monitor this entire things would happen automated way. So there are actually two plans you have. One would be the basic, other one would be the standard. So basic plan is nothing but automatically it will enable as part of your platform. But the standard one you might have to buy it, otherwise it's not gonna come for you. So now let me show you. If you see here the documentation, we have the two plans as we discussed, like the basic and the standard. And you have the normal differences would come into the metrics and the reporting and some kind of mitigations to be done. Then you would be going to the standard edition. Otherwise the normal protection would be more than enough. However, if you just wanted to understand better in the PPT wise, let's take one of the example called value metric based attack. So what would happen is, don't think that there is nothing provided here as your DDoS protection. So if you don't have a DDoS protection, what would happen here is the normal attacker will try to send a very similar genuine kind of traffic to the access to the applications that are in your network. So what would happen is he would gain the access, he would try to reach the application. So the system thinks that is the genuine user, and the load will increase. Let's say you have an application, web application, and the normal user count is maybe 1,000 per hour, and this attacker, what he does is he would send in maybe maybe within 1 hour, maybe millions of web page traffic would be diverted. So what would happen if you have that server was not configured with the auto scaling, your applications will go down definitely, because it can't handle that kind of huge traffic. Maybe your resources may or may not handle that. But what if you have the auto scaling was enabled, so the resources never goes down? So what would happen is it will scale up, and then at the end you would be paying for the bill for those resources, but they are not genuine legitimate users, right? It's all about the DDoS attack. So to identify this kind of problems or attacks, Azure DDoS protection would come into the picture. Here you see here there are 60 plus different network layer attacks would be automatically identified, and it can resolve all those problems. So DDoS and distributed DOS attacks are really prevalent nowadays, and if you can imagine, they could actually end up costing you quite a bit of money. Let's say you are in a victim in this scenario, you maybe you would have been billed lot. So that's where you need to think about it. These kind of protections is mandatory to fulfill the security side. Let's check for the billing purpose, and the billing is very straightforward. Here it's gonna bill based on the GBs. So The more you use, less you are going to pay actually. You have three different billing options. You can choose, for example, you have a single DDoS protection, a standard plan that was enabled for single subscription, but within that single subscription, if you have a multiple VNets, you're going to build total monthly bill and also plus $50, that is the charges of let's assume these 50 coming up from the data processing charges, and also the monthly subscription bill at maybe you got in a build of maybe $2,944. That plus this 50 would come up as the extra charges for you. Similarly, here are different different licensing models you have, so you should be visiting this page to understand more about the licensing in terms of the payment. And you can just go to the calculator here, and it's added now. This should be added here, and then you should be able to, it's just added, and you can check out here based on the Azure DDoS protection plan. And it's gonna per resource it's gonna charge additional charges would be applied, but includes close to 100 resource is the base for the first 30 days would be the $2,943. Opposed to that, it would be added extra. And also, for example, you have the maybe a 30 resources example, it's gonna cost for the additional cost. So each resource would be charged close to $30, and the data protected, the inflow and outflow, you should be charged based on that in the terms of the gigabyte. This is a pricing model. You can have a look on it. I hope this is useful for you to better understand about the Azure DDoS protection plans. As we talked here, there are two different plans, standard and the basic. These are the two different plans you have, and this is a quite common attack, and you should be securing your all kind of applications. It's not just the traffic, you can also, or you should be protected at the protocol level and resource level. That's a key here, and that's the summary for understanding of the DDoS attacks.
Hello and welcome back. In this lecture, we will be learning about network security group. In short, we also called as NSG. A network security group contains a list of security rules that can allow or deny your network traffic to resources connected to within your virtual networks. As you see here, if this is a public network and if a resource is coming from outside to inside, network security group will protect at the virtual network layer or at the your subnet layer, and that would actually stops all the traffic based on the filters that you create, either allow rule or based on the outbound traffic rule. Let me show you in the demonstration. Let me go back to the network security groups that have already created. If I just go back to one of the all resources and select one of my current production resource, here you can see here NSG is already there, which is created as a network security group. So with this, you have the rules to allow or inbound to be allowed as well as the outbound to be allowed. That means the rule has been created here with a priority of 101 and the ending of the 65,500, which means that the lowest number would take the priority. That means any request comes, it would actually process here, and if the rule is not matching, it will go to the 102, that's the highest number, and followed by 1,000 and 65,000. And similarly, if any of these rules are not matched, the default rule, which is the deny rule, will be applicable here. So based on this, here you have the options for port number 81 and port 80, both are allowed, and these are the descriptions given wrongly, but the port numbers are here mentioned as 81 and 80. And similarly, if you want to create here, you can actually create from here directly by going to the inbound rules and outbound rules. Outbound is from your virtual machine to outside, everything is allowed. That's how the rule was created. From any protocol, any port, any source, you're actually allowing within the virtual networks. And if you have created any of the inbound ports, that is from the outside to inside, you can allow. So these are the security groups which can be created. Let me create one of the resource group first, and then we would be creating here. This creates the resource group. If I just refresh, the resource group should be created by this time. If it is not coming, I can refresh sometimes. Now the resource group has been created. I can go back to AZ-900, which is the resource group, and I can create here one of the network security group. So I can simply go back to networking and choose the network security group. I can give here an SG name and the location of my region and click on create. That would create the security group. I can check the NSG, just go to the resource, and you see here by default it has created all the default allow rules here. If I want only exception to be given, some other rule, like here I can choose port IT as a destination. So I would be giving here as a priority 100 and give any destination to any destination, or I can choose a specific IP address or VNet, or maybe I can choose the application security gateway also. So all these can be chosen as a condition or the destination. So I'm choosing here any of the destination, click on add. That would actually create a rule here to allow port ID, and if this network security group is associated with any of the subnets, all I have to do is I have to associate any of the subnet. So in my case, I do not have any of the subnets. In case if I have any of the subnets, I should be able to associate, so that within that network, any of the, for example, if I associated with this VNet, so here the NSG would coming up and it would actually work at the network layer to filter all that traffic. Let's take a design and check out how and where it actually shows. So these are your Azure deployments, and this is the front face of your Azure. That means the entire things comes into the Azure. And this is where you start provisioning the Azure resources inside. So if any machine is trying to connect from over the internet, the first point would be the DDoS would be coming into the picture, which is a subscription level, and the resource level, which is gonna protect you with the basic plan automatically. And if you choose the standard plan, it's gonna more dedicatedly you can configure, and you can remediate some of the steps, and you get the more reporting. And also you have the next isolation point here is the in this case it would be the VNet, that's the virtual network appliances, so it's a software based VNet. And then you also have the NSG, which we are talking about. And the later point, you can also do the VNet isolation, so that from one VNet to another VNet there will not be any communication. And also you can configure at the endpoint level, configuration also can be done. So these are the ways you can check out how the Azure deployment will progress, and you can secure with the configuration of either with the NSG, or maybe with the VNets, or for the isolation, or maybe for that matter DDoS. I hope this is useful for you. Thank you for watching this. Hello and welcome back. Today we will be looking at best practices in choosing the Microsoft Azure Network Security products and solutions. When it comes to choosing the Azure Network Security solution, there is no single product is usually going to give you everything that you wanted to have. For example, if you see here within this, there are multiple different products what we are going to use, and we are trying to secure them. Similarly, there's no single product that can do all the securing of all the network or network resources. So because of this, you are looking at how we can build together in a different Azure products and services, as well as some of the best practices. By following those best practices, we can arrange our resources, and so we get the most network security for our resources. Out of these four pillars, the first pillar is the isolation. So when we talk about the isolation, we are really looking to do is to take certain data or resources that we have sensitive information, or something that we need to protect a little bit more than standard. We are looking to isolate, so that other resources don't have much access to this specific data. That's where you can get more security. So that's one other pillar what we can talk. For example, there could be medical records or customer financial information, where there's only few laws will be allowed or regulations that would around it. So when you store that data, who and when, or who's going to access, when to be accessed, such kind of policies might be you can configure. So in a lot of cases, a simple way to explain those
or these laws is that you have to secure this data encrypted, and in some cases it has to be isolated and where only authorized people have access to it. And when we want it, we can achieve that with the Azure by using the virtual networks. That's a VNet what we have used. Within that VNets you can create multiple subnets and to create your segments of networks to isolate these resources as we need it. So as I said, you can go for multiple when we talk about the isolation. So within this one subnet you may have one more subnet like similarly, so that the two subnets are completely isolated, so they don't talk with each other. That's how one other option that you can follow in terms of the isolation. If we had a financial systems or some financial that we need to isolate from our normal systems application, the one thing we could do it from the networking side is to create entirely new network just for that data, and with that data, the new network, we can have some kind of rules to make sure that only authorized people or the systems can only actually access that specific network. Now, along with the lines of the isolation that we can really look at, network security is one of the key point to enforce that the least privileges can be applied, so that if the resource is trying to access from one user or some other system is trying to access also, the first part would be the isolation, and then if you want to grant it, we are granting a least permission, least privileges. That way we are securing the complete data. So when we talk about really limiting every user's access reads to absolute minimum permissions, they need to perform their work, and we don't want to give anyone more access than they need, because that could lead to that person gaining access to data that is that they shouldn't access it, and that might means that we no longer comply with our laws, and we have to stop this thing. Otherwise we are going to spend money on fines and other things like that, and that we wanted to avoid that. If you remember, the same things we have done with the Windows Azure firewalls, not just Windows firewalls, with the Azure firewall configurations, with the principles of least privileging, we wanted to assign users rights only for what they wanted to perform and what they need, nothing more than that. And we saw that principle in the least privilege in playing when we need to configure our Azure firewall, because we saw that Azure firewall denies all traffic by default, if you remember that. And also, if you remember the network security groups that we have configured, or we can even integrate within the Azure firewall to create a bare minimum network connectivity that we need. Network security groups, as we learned, their way to enforce rules along only the minimum network access needed between those systems. Along with the Azure firewalls, we also had a look on Azure DDoS protection. That kind of services also can be integrated in such a way so that you are securing from any kind of DDoS attacks, because this DDoS protection also have the threat intelligence that we can use to automatically block out any malicious IPs or domains or agents based on the data which is Microsoft owns. And Azure DDoS takes it up a step further and actually protects us against from DDoS attacks, and lets us automatically mitigate these attacks by blocking the traffic that is does not explode our builds, as we talked about in the previous lectures. If you remember, the auto scaling, other things would automatically spin up. So if you use the DDoS kind of protection, that would definitely save your bill when we have to protect ourselves from any kind of attacking request. There are other products also fall into the Azure network security best practices, but they are not covered into the AZ-900 exam or the fundamental exam. For example, one of the common things that the pupil will try to do is to make sure that all the traffic within your network should be encrypted. And while Azure firewall and network security groups don't do that, there is another product that does actually, and which we haven't covered in this course. That's nothing but your application gateway, or Azure application gateway, which is again encrypting your application data, so that any kind of hackers in between, or if they try to do anything uh, they get only encrypted information, right? So they can't do anything with that. And if this is a link which talks about the Microsoft within the Azure cloud, the best practices for securing your network, and like using the strong network controllers and logical segment subnetting, the subnet best practices. That's what it has discussed here, and also adopting a zero trust approach. And you can use the control routing behavior. Otherwise, the route using for any VNet to any VNet or such things would gives the not the non-isolated, and that would lead to the other problem. So better to use the control routing behavior and also the VNet appliances. uh, that's nothing but your firewall or other configurations can be done within the OSI model, and deploying a perimeter network for securing your zones. That's nothing but your DMZ with the help of Azure firewalls or application gateways, or maybe next generation firewalls. You can use a third party products like Sophos or any other products to avoid any kind of DMZ security concerns, and also to avoid the exposure to the internet with a dedicated VLAN. So what you can do is you can go for the site-to-site VPN and Azure Express route. All that has been discussed within this link, and many more here. And I hope you should be going through this link in order to cover the in-depth of the best practices, as this course is very limited to fundamentals exam. I hope this has been helpful and clarifying some of the ways that we can secure our networks within Microsoft Azure Cloud. Thank you for watching this. I'll see you in the next lesson. Hello and welcome back. In the previous lecture or previous section, we looked at the security. Now we are going to looking into the privacy and compliance and trust. Within this, we will be in detail look at the authentication and authorization. In terms of the security, we had a look on DDoS, Windows Firewall, that's Azure Firewall, and the NSGs, and the security solutions, different security solutions. We looked into it. Now it's a time for the privacy and compliance and trust. So we would follow it, and we would try to learn about the identity services within this section. Within this Azure identity, the first one would be the definitely authentication and authorization. So what exactly this authentication and authorization? I did differentiate it here. If you see here, all these points falls for the authentication and here authorization. And also I did explain here what would happen in the authentication and the types of authentication you have, and also the authorization. Let's begin to look at authorization and authentication a little bit more. The difference between these two is actually relatively pretty simple. Authentication aims to prove you who you are. If you see here authentication, it's just asking for who you are, like your username and the password needs to be entered, and that would actually validate at the authentication layer. And coming to the authorization, it's a simple process in other hand, but it actually specifies what kind of data to be allowed, or what kind of permissions you have. That's all about the authorization. Sometimes in the documentation we also simply call auth-n. It stands for the authentication, and auth-z for authorization. So you no need to confuse, but just for when you're trying to read the documentation, or people will call as auth-n, auth-z, then you would in that way. Let's take one example as a web application, and when a user here sitting here and he's trying to open a web page which is asking for the username and password, that would actually authenticate. That means it's actually going in the background to involve the authentication as well as the authorization. Now with the authentication, what we are really looking at is just the user ID and the password. We might have configure here different kind of authentication factors, like a multi-factor authentication, or maybe a phone or secondary authentication layer. In other way, we call it as a single factor authentication. That means a simple form for authenticating a method which requires a password to grant it to access that particular system, or such kind of website, or to enter into that network for that matter. So that's called the single factor authentication. And also if you enable the two-factor authentication, that means this authentication also required a two-step verification process, which not only require your user ID and password,
but also to a piece of information only the user knows. For example, it could be a confidential information that only user knows, or maybe a VPN kind of thing, or maybe a security token key, or such things maybe. Now, that's a second way within the authentication. And also we have other one called multi-factor authentication. These are the three things which we talked about in the authentication. There are three things. One is a single factor authentication, two-factor authentication, and multi-factor authentication. So we're talking about now multi-factor authentication. Within the multi-factor authentication, this is most advanced method of authentication, which requires two or more level of security forms, independent categories of authentication to grant that user ID and the password, to grant that maybe a page or maybe a web page or to a system. So this form of authentication utilizes factors that are independent of each other in order to eliminate any data exposure. It is commonly for financial organizations or maybe for the banks. They use it, or some kind of law enforcement agencies use this kind of multi-factor authentication. But these days it's quite common that multi-factor authentication is enabled for most of the applications. And now, in the other hand, we are going to talk about the authorization. So authorization would occur only after identity is successful. That means this process is successful. That means the example which we are taking here is the website. So when a user enters a website, if it is asking for the user ID and password, so we need to know either go for the single factor authentication, two factor, or multi-factor, whatever the configuration we have done. Once we have gone through that, it's going to the authorization. Hey, this user and the password is really authorized to access what kind of data. That's where the authorization comes into the here. So it would actually check whether what kind of files or database or such things it would validate. However, authorization really verifies your right to grant your access to that specific resources only for determining your ability to access the system up to what kind of an extent. In other words, authorization is a process to determine whether the authenticated user has access to that particular resource. A good example for this could be once verifying the confirmation of your employee ID or maybe the password through the authentication. The next step would be determining which employee have an access to which floor. And let's apply purely to the Azure case and try to learn more about the authentication and authorization inside. So what would happen is when we first authenticate into a system, we're actually giving a piece of text that's called a security token. So as I said, exactly this token was given by identity server, in this case Azure AD or maybe your Active Directory server, just for an example. So that token proves that who we are. And the security token contains information outside of some base information like our username and the time, not the password, okay? And that we guaranteed, and even things like when authentication going to be expired, because this information was given by your identity service. So the token contains now the user ID and the time and the authenticated time and when it's going to expire. So if you want us to force our users to relog in every 1 hour, for example, outside of all that in a security token, there is a whole section of authorization in the token as well as. So this is a way that's called a claim. So what exactly claim? Claim is it's a piece of text inside our security token that is in some way tells us or one of our system that we are coming and we are not allowed to do certain types of actions. And the cool part about these claims is that we can configure our identity server to make any kind of claims that we wanted to specific to our systems and applications. If you wanted to see what exactly this looks like, this is a sample file you can check out as sample access token response. So this comes into a JSON format. And if you just Google as OAuth2 token response example, so these are all of the examples that you can think about it. So this is how it looks like. If you see here the scope, read and write, expired, the time and token type and access token. This is access token what we have talked now. Let's take one of the example and how best we can reuse or apply different ways. For example, you have a shopping cart application, and you might have another client saying that only read-only or analytic system, and other one may be just the claiming that you might have it access denied access to the accounting system, like that, different claims you have. So with these claims within your token, you can really make any kind of application that you want, and you can use them across all the systems to provide authorization against all of your different applications. I've always thought that the claims were really one of the cool feature in identity management, because they are so customizable, since you can make any claim you want. That's why this is one of the coolest feature in identity management, these claims, because they're so customizable, since you can make any claim you wanted. And you can really felt that it's very helpful in allowing security tokens to be tailored towards to each individual organizations and their systems and applications. So that's kind of general flow about how we authorize and get a security token back, and then we have all the claim information within our token. The first thing that's going to be happen in a web application is going to see the users do not have a security token, and it's going to redirect to them to log into your identity server. Then the Azure identity server is going to be definitely Azure Active Directory in our case, which we will take a look at in the next lesson maybe. And that's like your Active Directory where you create your user IDs and passwords if you're aware on premises. Similar method, but it's a cloud-based Azure Active Directory. We call it as a tenant sometime. And there it just validates your user ID and the password, and our identity server will retain an access token, in this case Azure AD. And this token might have a claim that's saying that user is allowed to look at the certain web pages, and also claim that says that he has some pages to log in as a user and some of them are not allowed. Now the user will get a token based on the redirected back to the web application based on his access level, and that would open the web page. That's how it's going to work. So here from start to end, like authentication and authorization, we talked a typical high-level flow of how we authenticate an identity server and use our security token with other applications and systems, and how these or with other applications and systems can be authorized our request based on that token. We can use get that access. I hope that was helpful in explaining the difference between authentication and authorization. Thank you for watching this. I'll catch you in the next lecture. Hello and welcome back. In this lecture, we will be learning about Azure Multi-Factor Authentication. We also call in short MFA. In our last lecture, we had a look on authentication and authorization, and we learned that authentication is providing the way the user ID and password here, and that itself also have different methods like one-step, two-step, and multi-factor authentications. Now we will be looking at the multi-factor authentication in this lecture. Now the multi-factor authentication is a kind of setup from regular authentication. It's really same thing, but we are just trying to prove here who we are, and with the help of the multi-factor authentication. The difference is that we are proving it through two or more different means. Like you see, you logged in here and you might get in a phone that is this you or not. So you are actually proving yourself in a two or more different ways or means. You are trying to prove yourself, so that it would be very hard for any of the hacker to gain access more than one mechanism of authentication. Let's say if user ID and password compromises, it might not be compromised a phone, a mobile phone, or a security token which changes all the time. So that's where the multi-factor authentication comes into the picture, and it's called a typical multi-factor authentication. It actually flows actually shown in this image, how it looks like with the flow. For example, here the user ID and password entered, and you're going to get here the is this you kind of
message, or maybe a text message to be entered, or maybe a phone call you will be getting, or a pop-up, a smart pop-up will come up on your phone, and if you just click on yes, or maybe you might have to enter a code from a authenticator app, which is an app from Microsoft. So once you prove that, it actually combinationally it would verify, and it would actually grant the access. So that's all about the multi-factor authentication in the background. You might be already worked similar situations or similar configurations that might be used. For example, if you are going for the banking sites, mostly they would for any of the transactions these days, they are requesting us to enter the SMS code that is sent by bank. So once you enter the password, and when you're trying to log in or when you're trying to do a transaction, it will ask you to enter a passcode which sends to your either email or to your mobile phone, so that you need to prove yourself as a second layer. So that's the additional layer of example. And also you might have noticed, or you might have remember that if you worked with any of the company which has a Cisco RSA token or RSA device, which would actually change every time, every 15 seconds. The new code will generate on every 15 seconds on your RSA device. It could be a 6-digit number, something like that. So having worked in that kind of corporate environment for a longer time, one of the things we can think that is a company called RSA. So this RSA token ID, it keeps on changing, so that you need to enter the first as your normal password and then the code which was displayed on your device. So it would be additional layer which would protect that you are actually proving that you have that device and you are the one who's actually logging, so that it would be difficult for any of the hackers or attacker to get all that authentication details from us. That's the beauty of multi-factor authentication. If somebody steals your username and password, then still won't be able to log in as you, because they need another authentication mechanism that is probably much harder for them to steal, like your phone or RSA token, or maybe a code which you receive, or a phone call that you receive it. Let's have a look on the Microsoft documentation side. So this is a page how the multi-factor authentication works. Something you only know, typically a password and a trusted device or a biometric devices also can be configured, and you can actually configure this directly from Azure Active Directory Premium. So, or if you're using a Azure AD free, that's Office 365 licenses, then you can configure the multi-factor authentication. And also for all the global admins, by default they set it as the multi-factor authentication within the Microsoft Azure. And coming back to the configuration part, it's so easy that you can configure if you're trying to configure this multi-factor authentication in maybe on a hybrid. When I say hybrid, you have your on-premises Active Directory and also your Azure Active Directory on cloud. Both, if you sync up with AD Connect, there's a tool called AD Connect, then you can set it up as a hybrid, so that your on-premises users also, if they are trying to log in, you can configure for them the multi-factor authentication. So you can extend your cloud capabilities to your on-premises users. Similarly, if you just want it for your cloud only users, you can definitely do it, and there is no additional pre-requirements to be configured for that. But if it is a hybrid user, then you need to go for AD Connect. And let me show you Azure AD specific one. So just go to the three dots and then search for the Azure Active Directory. You would be getting it here. So this is Azure Active Directory. You can check out here from the users. You can create groups, and also you want to configure your security layers, and here you can configure the MFA. So this is where the MFA can be configured. To configure the authentication, multi-factor authentication, just go to the Azure Active Directory and select the user which you want to configure. For example, in my case, maybe test demo, and this is the user, and I wanted to set him authentication methods as required to re-register his MFA. So what would happen is, when a user tries to log in, it's gonna prompt her to enter his mobile phone number or maybe an application that would actually validate his
identity. So that's how you can configure here for a single user. If you want to configure for multiple users, just go to the Azure Active Directory and then go to the security. This is where you can configure getting started MFA. You can configure right from here the MFA specific one. Accounts can be logged out, such information you can do it within the configurations of MFA, and you can find out the settings that you wanted to configure as the MFA server. You can do it directly from here, but we don't do it much here. So all we do is we simply go to the getting started, and we would start from here additional cloud MFA settings, and then we would start doing it the MFA. We can also do it from the portal.office.com. So this is actually Office 365 specific. So if you just log in with the portal.office.com, if you have the Office 365 subscription, you still can do it. Multi-factor authentication can be set. For example, he's a global admin, so I just log in here and going back. So this would actually open up that specific user's Office 365 environment or admin center, and simply select that specific user. In this case, maybe test user, and I can force here the manage multi-factor authentication. That would actually takes me to go to the portal. So this is the same portal as similar to your multi-factor authentication from the configure wizard or from this space, and this is a place where you have the multi-factor authentication. Let's say if you see here multi-factor authentication is not enabled for any of the user, if I want to enforce, I can simply enable. That would actually enable the multi-factor authentication for that specific user. And if I just do the refresh or wait for a second, see I got it as it's already enabled for this specific user. So that's how you configure the authentication. If you just wanted to disable the multi-factor authentication, you can go ahead and disable it. Now we talked about the multi-factor authentication, but it doesn't come you as a free of cost. Actually, you need to pay for that. So let's jump into the licensing and have a look on what is actually cost for this. The multi-factor authentication also comes as part of the Azure Active Directory, so you might have to check for the Azure Active Directory. So within the Azure Active Directory, which I'm going to talk in the upcoming lecture, but you see here you're also getting multi-factor authentication with a condition of 3. So if you just go down and see the condition as 3, third point, it comes with the capabilities of many subscriptions, because if you check the documentation, there is a Azure Active Directory P2, P1, EMS, all these kind of options you have. So what I have tested and shown you is from the free trial, and then I have taken the EMS license for that specific user. That's why I was able to show you the Azure Active Directory multi-factor authentication. You can check out under licensing from the Active Directory. There's a licensing you see here, and see all the licenses here. So I have here EMS plus security E5 subscription. That means I have the full-fledged subscription, that is the highest level. E5 is the highest level. So what would happen is you have a P1 and a P2 as the Azure Active Directory premium services, and these are the subscriptions will have different features you have. So if you see here, MFA reports, you would only get it from P1 and P2. Also, MFA for only can be protected for admin accounts, but not for the user accounts. So if you want to configure for the user accounts, then you might have to configure go for P1 or P2 subscription, but it's not available for the Azure Active Directory free subscription. At the same time, it's available for Office 365, again E3, E5 licenses. You might have to look at those licensing and whether it is available on those licenses or not. So you see here multi-factor authentication. This is actually the P1. So within the P1 you have most of the features are covered, at least mostly what we use, third-party integration of MFA and other features. But it's going to costly for you, close to $6, because this also includes other features, not just the MFA. And you should be aware of that. And let's go to if you have Office 365, as I said, this also included within the Office 365 subscription, these features. So that means the multi-factor authentication also part of the your Office 365 subscription. That's what I tried to show you here from the admin center, and you can enable multi-factor authentication.
Now let's actually look at other pricing details. Let's try to add to the calculator and see. So if I just go to the calculator, and it's just added me Active Directory, and I can check out here. I'm going to use either free or the P1 or P2. Such kind of information I have to choose, because with the free you get it as a normal Active Directory, but most of the companies they go with the P1 and P2 combination, because you can mix and match with your existing licenses. Like for users, a few of the users may be a P1, and for other users maybe P2, because they are maybe your global admins, and you need to configure maybe PIM kind of configuration, or uh, just the securing more, and you might need to configure such things. Then definitely it's going to be P2. So you can play mix and match even the licenses. You don't need to worry about I should go for all the users with just the P2 or P1. You can play with them for P1 and P2 combinations also. So it's just closely costing you close to $9 for the P2, and P1 is $6. And you can also go for definitely enterprise or volume licensing feature that would actually covers more cheaper when you go for the Office 365 subscription, because it's just not the AD. You may have already Office 365 subscriptions. In that case, you need to validate or what kind of a subscription you have, and whether this multi-factor authentication is covered there or not. I hope this is useful for you. Thank you for watching this.
Hello and welcome back. In this lecture, we will be looking at Azure Active Directory a little bit more. Now, in our last few lessons, we learned about authentication, authorization, as well as with multi-factor authentication. And we have about Azure Active Directory a little bit in those sections. However, we didn't cover in depth. So now we're gonna look at in depth about Active Directory, Azure Active Directory, not just the Active Directory, because when you call Active Directory, it will be on your on-premises Active Directory. So this Active Directory is on-premises Active Directory is where you can enable the Active Directory services role from your Windows servers. So when it's a Windows server, it can be starting from 2000, from the Windows Server 2002 till 2019 servers. Whatever the servers you have, all that will have the Active Directory where you can enable for your company, so that the users can log in by authenticating from the tokens that are issued by Active Directory. So in our case now, we are talking about Azure Active Directory. So when we say Azure Active Directory, so Microsoft has not just moved this as it is to here, because this Active Directory, which is in an on-premises Active Directory, is not compatible fully with the cloud modern application based one. So that's why Microsoft created a new Active Directory mechanism for called Azure Active Directory. Sometimes we also call the AAD. That's a double AD or AAD. So that this is a symbol for Azure Active Directory. So what would happen is, ideally within the Azure, completely Azure Active Directory can manage your applications, your SaaS application or your resources. Everything can be managed with the help of accounts that you are going to create within the Azure Active Directory. Let me show you that how it looks like. If you just go to Azure Active Directory, like just go to the home page and search here for Active Directory, or just go to all services and look at Azure Active Directory. So this is the Azure Active Directory. This is where you can create your user accounts. So a user account is the normal user where he can log in by using your user account, like a company name, user at companyname.com or something like that. And also you can create your groups very similar to our groups which we create in your on-premises, but these groups can be your security groups to grant access somewhere in within the Microsoft Azure resources. And these can be even dynamic, like if a specific user belongs to some location, then automatically this can be the users can be part of that group. Such a powerful mechanisms you can introduce within the groups also. So it's a dynamic, and dynamic device based also can be done if that specific device
has some specific attribute, then it would automatically falls into that device, into that security group. And also the Office 365 groups also can be created here. So we talked about the users and we talked about the groups, and now when you're trying to log on, you can customize with the company branding by giving some kind of logo and text so that you feel that the users are logging into their corporate environment altogether. Let's think Active Directory in an easy way that it actually stores your identity store. So if you think about the users or the resources, their usernames and the passwords information would be stored in Azure Active Directory, and it gives you the authentication, means like the username and the password and the authentication information will be verified, and it gives you a security token back to other resources as an output. Azure Active Directory is a comprehensive, highly available identity access management cloud solution. So you hear that term quite a bit. Moving forward about identity and access management, or in short IAM. Let me show you what I'm trying to talk. If I go to anywhere in the within the Microsoft Azure portal, for example, this computer, which was created as a VM, and you see here there's an IAM, access control management. So this is where you can grant permissions for the specific user. If you want to add it, for example, add a specific role or for a specific user, like this user has to grant an access some kind of maybe a permission. Such things can be done directly from the AM. So AM is, or IAM is, your access control. So in other way, it's identity access management. So that's why you will be hearing everywhere whenever you go to any of the resources, you will see here access control. From this is where for that specific object you can grant the permissions and you can apply, hey, that does that specific use a permission for read and write or delete. Such configurations can be done. And also, of course, you do have the rollback access management. That means there are different groups which are available by default, and that uses or that specific groups can be have the more permissions on specific to the users, or specific to the permissions on that specific object. Now if you think about what is exactly the Active Directory and compared with the Azure Active Directory. So Active Directory is on premises and Azure Active Directory is purely from the cloud enabled and cloud compatible, cloud native. Azure Active Directory is. And if you want to integrate with on premises, you need to install something called Azure AD Connect. This is a tool that has to be set it up on one of the member server, and then that acts as the mediator. And what happens is your on-premises users will sync up to the Azure cloud, and you can configure the resources. For example, as I just shown you that there's a VM, so for that VM also you can grant access for that specific user who is coming from your on-premises Active Directory. So the connector is between, that's called Azure AD Connect. And just to enforce that, whatever the user accounts you're going to create here, they are going to pay. That means for these licenses, for these users, you need to assign a specific license. Otherwise, those users are not valid. Maybe they can't use specific services. I'm going to come back to the Azure Active Directory model, because you have different pricing, different setup altogether, different plans you have. I'm going to talk on that. For example, if you can see here, Azure Active Directory free, that means it's a completely free. You no need to pay for anything. There's also P1 and P2 plan, where you're going to pay for $6 and here $9, close to with a P2. And also you have a pay as you go for business to business, business to customer, or kind of configurations to be configure when you go for the pay as you go for features, licensing. So either way, you need to know that there are different plans, and you can mix and match those plans for the users so that they can be work. For example, if you configure the P1 license, that means users can, if for example, if a user forget his password, he can reset on his own. So you don't need to come back to the help desk and so that help desk can help him. But in the normal case with the P1, he can self reset services like the identity management, the passwords. He can self sign, self reset can be done. Such things can be configured, and also multi-factor authentication for the P1 and P2 can be configured. And when you go to the P2, which is a $9 per user, this gives the privileged identity management. In short, we also call PIM, so which would restrict the any of the admins, uh, so that they don't get to work with all the permissions all the time. Instead, they need to go to the PIM management and request for an access as the admin for that specific time. So that specific time they can be as the admin, and post to that it expires their privileges, so that you very well monitor why and where we use that account for what purpose, so it will be easily tracked. So that kind of access can be configured with the P2 licenses. If you see here the compassion table, which is mentioned very clearly in the pricing section, the free one has a 10 apps limit for the single sign-on. So when it's a single sign-on, if there is any user has some of the application, let's say SAP or maybe Dropbox or maybe Google, these are the third-party applications also can be offered and can be integrated, so that, for example, in your on-premises or on your cloud users, you bought maybe a Dropbox for maybe 1,000 licenses for your 1,000 users. So they don't need to enter Dropbox user ID and password, additional password. Instead, you actually configure these applications by using Azure AZ, and you would actually enter that user ID and password once. And the users, what they do is they enter the user ID and password to log in normally. But when they install this Dropbox, it would automatically set up for them with their current user ID of our company and the password of our company. So they don't need to again configure at the Dropbox level additional user IDs and other things, and also it would be automatically open. So this is called a single sign-on mechanism, also can be configured. If you're interested on that part, you can configure the single sign-on. And also by default, the Office 365, definitely these are your single sign-on compatible applications. So keep in mind that you have the single sign-on and other configurations that you can play when you go with the more higher plans. And you see here, these are the plans which are ending up here, from starting from the Office 365 identity management, like self-sign, self-service for the resetting their passwords. You see here from the Office 365 apps and the P1 and P2. Maybe if you're wondering for the first time, or you are talking about, or you may be listening Azure Active Directory for the first time, guys, Office 365 is built on top of Azure Active Directory. So when you have Office 365 subscription, it means that you are actually working on a Azure Active Directory. So that's why they did mention here a few of the explicitly some of the features they talked about here, like company branding, or maybe a self sign, or SLA. That means if something goes down, they would give you a timeline based on that they are going to fix it. Let's say sometimes we can see that some services might go down, or definitely a little bit of impact. In that situation, they would come up with a SLA. And coming back to the device write back objects, that's a two-way synchronization between your on-premises Active Directory and to your Azure. Then you need to you can play with your Office 365, which is this feature is especially for the hybrid configurations. This can be worked. And similarly, P1 P2 also will cover on that. And premium features, which are password protection, custom branding, that all comes under P1 and the P2. So these are the additional features you maybe check with these. Like if you're trying to play with the Intune or mobile device management for auto enrollment and other things, you might have to go for P1 or P2 options. And also the group policy specific settings also can be managed within the MDM as the admin template. So such things, if you want to play and apply as a mobile device management, such things, P1 and P2 would give options. And you can check out here hybrid identities like application proxy and cal-based licensing, content health, all that are P1, P2. So these features and also conditional access is when we talk about the conditional access, like you have a user who's coming up and he's going to log in from, let's say this user is coming and is trying to log in from trying to access a device from maybe India, and the login was allowed. But the same user, after maybe 30 minutes or maybe after 1 hour, he's trying to log in from London, different location altogether, which is practically not possible as on date. He can't travel within 1 hour or 30 minutes time to a different geographical location and log in. In that situation, definitely it can be identified as a risky user, so it would either go and give you conditional access, saying you must have to authenticate from the local subnet or local IP, or you have to uh, prove it is you with the third authentication level like multi-factor authentication or some other mechanism. Such things can be configured, called conditional access. So let's take one more example. If a user is trying to access from his mobile device, then uh, these applications, if any of the applications to gain the access, he has to prove that he's actually the right user. So he has to enter the multi-factor authentication. Such things, a conditional access can be configured. So these are the conditional access features which are listed here. Like you can see here, based on the AD group, location, and the definitely Azure information protection integration, SharePoint limited access, terms of the use for specific access, multi-factor authentication, cloud app security, third-party MFA also can be integrated. So all that are the conditional access specific, and also identity government. This is second PIM, which is a privileged identity management. For that specific time, users can have the access. So such configurations can be done, and the pricing here clearly mentioned with the $6 and $9, which we also talked these things almost. Some of them we did talk in the multi-factor authentication lecture. If you've not done, you can check out that lecture also. So if you are looking for the pricing, how to calculate, just go to the calculator. Simply it will be added. As I said, it's a $6 and $9. So as simple as that. You need to simply add the users that you wanted to configure, and remember that these Azure Active Directory can be configured in a mix and match. When it's a mix and match, let's say 10 users can be a P2 and 5 users can be a P1. Such configurations can be done so that you would actually save the cost. You see here, if you are using a free subscription, free one, there's no need to pay. That means you're good to go up to a few of the objects which are limited. And coming back to the P1, if you just use $6, and if you just go to the P2, then it's $9, and simply give the user account that you wanted. And this is per user based, and it's not for the device based. That means the user can log in from a different object, different type of devices. You see here, he can come from iPad, iPhone, or mobile, or in different mobiles, or maybe from a computer, or maybe a laptop. So this is all about Azure Active Directory. So there's a huge difference between your on-premises Active Directory and Cloud Active Directory. Cloud Active Directory, that is Azure Active Directory, we call it. It's a fully REST-based compatible. That means it's a cloud native, and it knows a cloud-based application mechanism, and it can easily talk with that. And also to fill the gap between your on-premises, you have AD Connect. So this connect, when you actually install and set it up, your objects from on-premises to Azure Cloud also can be synced, and users can log in with on-premises user ID and password, and can access your cloud application. So this is called hybrid environment. If you just have only this part, like within the cloud or within this Azure cloud, then Azure Active Directory natively can also work. But in that situation, these users, if there is no AD Connect is set it up, then they have to have another ID. And remember that if you're quite new, the Windows 10 machines also can be added to here. These Windows 10 computers also can be joined to Azure Active Directory and gain the access as a self-sign. That means the users can log into Azure Active Directory. That means what are the applications you are provisioning, all that can access directly from right from their applications or from their browser without entering any additional username and password, because single sign-on is can be configured. So all this happened just because in the previous lecture we talked about the authentication and authorization. So the token which is gives is here as your Active Directory, and that gives the token, and that token is valid uh, within the Azure cloud, and also if you have integrated with AWS or Google Cloud, that's where also this token also will be available and can be a valid and can access those applications also. That way we can also configure. um, that's why Azure Active Directory is the ocean. And let's say you have Azure Active Directory, and if I have my own company's Azure Active Directory, I call as my tenant and you call your tenant. So that's called a tenant because we are logging into Microsoft Azure Active Directory. So that's why when you try to look at any of the user account, normally it would be listed as you see here. Let me show you that. If you just go to the any of the users within the Azure Active Directory, you see the username is showing as on Microsoft.com. This is the tenant name or tenant ID, and after that on Microsoft.com. If you have a company, maybe example HP, so what would happen is HPE dot on Microsoft.com. So if somebody else has taken that HPE, you can't get that name. So for example, I have taken here Madhavan 007. In that situation, nobody else can take Madhavan 007. So you need to remember that these names are unique here, the tenant ID. So if I try to log in here, you might be thinking that if you're quite new, if I try to log in, I need to enter this name that's true, like the job at Madhavan007 dot on Microsoft.com as a login ID and my password. But if you think that it doesn't look like a great name, and if you wanted to standardize as your company name, for example, username at companyname.com, yes, you can do that. If you actually verify your custom domain, that is, you need to prove your domain to be added, because I logged in as the job. This is a normal user kind of thing, so you don't have much permissions. But if I log in with other users, so I can get here permission to add custom domain, then I would add my companyname.com and validate by creating some of the a record or a text record kind of thing. Then all my users can change to a companyname.com. Let's say user at maybe tcs.com or tata.com or maybe accenture.com. Such kind of name can be given so that they would use that specific domain name and they can log in it. So now to summarize, you have within the Azure Active Directory, you have the users and the groups. User-based licensing devices can be added uh, to join as the member for your Azure Active Directory. And also you can set up the Azure AD Connect for hybrid connection. You can set up your company branding. Users can log in with their on-premises user account, or they can also use verified domain name.com, let's say company name.com, user it. So these are the things you need to remember. I hope this is useful for you. Make sure that you go through the documentation which I'm attaching. That would really help you. And this is very useful for the folks who are interested in identity management or Active Directory guys, because they have to migrate their skills to definitely Azure Active Directory. Thank you for watching. Hello and welcome back. In this new module, we will be looking at Azure security tools and features. In the next few lessons, we will be looking at security in Microsoft Azure Cloud. Also, we'll also look at Key Wallet and Azure Security Center, Azure Information Protection in short AIP, and also ATP in short, which is Azure Advanced Threat Protection. These are the upcoming lessons which you're going to learn within this module. I'll see you in the next lectures upcoming. Until then, bye. Hello and welcome back. In this lecture, we will be looking at overall security within Microsoft Azure a little bit more. Azure has a security is built in every layer. When I say every layer, it's right starting from the securing the foundation layer, like the Azure has a state of art of security at every layer of their data centers around the world, including the advanced physical building security, integrated security controls within the hardware and the firmware components, and the automatic protection against threats like uh, DDoS attacks, or maybe we looked at in the before, like DDoS attacks. Such kind of services are already uh, hard-coded within the Microsoft security as a built-in services. The idea when building out Azure was to enable at highest level of security at every single level for us. And a lot of this built-in security has been built within the Microsoft Azure. I mean to say we don't have to manage a lot of it, or to do a lot of configurations at the to work this security to be configured, and we just take that advantage of the security benefits which are built in services. I'm going to list all the security related services and technologies that Microsoft Azure can offer for us. To begin with that, the general security, which is the first one which we can think about it. So within this general security, when I say general security, you can think about the Azure Security Center, which comes as the within the Microsoft Azure Cloud. If you just go back to this portal and look for Azure Security Center, which is nothing but this service, which is already pinned here for me in my case, and most of the time it would be there for you also. It would be docked. If not, search in the all services and go to the Security Center. So what exactly the Security Center? Security Center is a cloud workload protection solution that gives or that provides you the security management and advanced threat protection across the hybrid cloud workloads. So let's say you have the services which you wanted to configure for your virtual machines or any of the instances. It's going to build based on that, and these are you need to enable at the tile level, and this would be costed to you as an additional cost.